So before starting our coding on Node.js, let's first install our IDE. We'll be using Visual Studio Code throughout this course, and we'll be exploring some awesome extensions that will help us become a better backend developer and help us code efficiently. So for downloading the Visual Studio Code, just browse through code.visualstudio.com and select a Visual Studio Code for your device. So now that you have installed the Visual Studio Code on your system, it's time for installing some extension that will help us code efficiently. So for that, on your left hand side, go to the extensions tab, and the first extension that we will be installing is ESLint. Search for ESLint and you'll be presented with some of the extensions, and you can install the first extension that pops up here. So click at install and wait for a while. So what ESLint actually does, it recognizes the patterns and find errors and bugs on our JavaScript code as we type. So it will help us write error-free codes and can help us debug issues faster. So this is the most important extension that any JavaScript developer can have. So after installing this, let's move to our next extension. So the next extension we'll be installing is a Prettier extension. So on search bar, type Prettier, Prettier, and you'll be presented with some of the plugins, and as usual, click at the first plugin and click on install. So what Prettier does is, as the name implies, it makes our code prettier. Prettier is a code formatter that takes care of all the indentations, makes our code easy to read, easy to understand, and more organized. So there's one more step involved in activating the Prettier for our Visual Studio Code. For that, click at File, go to Preferences, click at Settings, and type Format on Save. Once you type Format on Save, you can see these options, and you must check this option. What we are saying is we are allowing the Prettier to format our code or lines of codes once we save the file. So this is the first step. The next step is to select the Prettier as our default formatter. For that, clear the source bar and type Formatter. So you can see this first option, the default formatter is none, make it Prettier. So by performing these steps, what we are doing is we are allowing the Prettier to be our default formatter and asking the Prettier to format our codes each time we save the file. So now that we are done with Prettier, let's close all the windows or all the tabs and search for another extension. So the next extension we will be installing is the error lanes extension. So as usual, click at the first one and click at install. So what error lanes actually does is it highlights the warnings and errors in our JavaScript code as we type. It shows the error side by side, so we know exactly where the error is occurring, which will help us write error-free codes and help us debug faster. So these three extensions, ESLint, Prettier, and error lanes, are the most important extensions for any JavaScript developers. Now there are a couple of other extensions that I'll be talking about, but these are totally optional. You can opt out of not installing them, but I do recommend that you install these as well. So the first extension will be Material Icon Theme. So what this does, it makes our working directory beautiful. Beautiful in the sense that it provides an icon, material icon, for each of our file system type. So if you are prompted with select icon file theme dialog, then click at material icon theme, or simply you can click at set file icon theme and you can select material icon theme. So the next extension we will be installing, or the optional extension that we will be installing, is the Oceanic theme. So this theme is totally a personal preference. You don't need to install this, but if you are like me, have trouble working at night, then this would be a go-to theme for you. So click at install, and after installing you should be prompted with a dialog to apply the theme, and I personally like this dimmed busy one. So click at this and you are done. So I believe this extension that we have just installed will help you on your journey of becoming a efficient backend developer. So without further ado, let's move to our next lesson. So the next step for setting up our development environment is installing the Node.js on our device. It is a JavaScript runtime environment that enables us to run JavaScript on the server side. It also enables us to start the server and do other stuffs on our device that we'll typically do on a real online server. So for installing the Node.js, just browse in through nodejs.org and then download the long-term support version on your device. After you have downloaded the installer file, go ahead and install it. You'll be guided through a wizard, and everything is pretty straightforward, so just accept the terms and click on next. You will be installing all these things. Click it next, next, and then install. So now that we have installed Node.js on our device, let's verify that the Node.js has been installed successfully. For that, go to command prompt or the terminal and type node-js version. It is a version check for Node. And if you see the version of the Node.js that you just installed, then the Node.js is working fine. And we are ready for our development of our backend. So if Node.js version check is working on your device, then you have successfully installed and the Node.js is up and running on your device. There is no additional configurations required. So by installing the Node.js, what we did is we created an environment for the JavaScript to be executed on the server side, which will help us create a server and do other backend stuffs. So after the Node.js has been installed, we are ready for our journey of the backend development. So I'll see you at the next lesson. So before diving into the coding of Node.js, let's first understand what Node.js is. So if you look into the typical behavior of the JavaScript, most of the JavaScript codes are executed by the browser on the client side, right? What Node.js does is it creates the environment in which the JavaScript can thrive and execute on the backend or on the server side. Why? Because it enables the JavaScript to access the stuffs that were not previously available to JavaScript. For instance, accessing the file system of your server. There was no way for the JavaScript to access the file system if it was only running on the browser side, right? But Node.js enables the JavaScript to access the things like file system and many different other stuff that we will typically need for the backend development. What enables the Node.js for doing so? How does it create the environment? Is Node.js is built, it is JavaScript runtime built on Google V8 JavaScript engine, which creates an environment for the JavaScript to be executed on the server side. But in simple terms, you can say that the Node.js is the backend that is built on the JavaScript. So now that we have a basic understanding of what Node.js is and what it does, let's create our first web server. For that, I have created a directory. You can go ahead and create any directory that you want. I've created a Node.js playground on one of my devices. So now what you need to do is you need to open this directory on your Visual Studio Code. For doing so, launch the Visual Studio Code and click at File and open the folder. Navigate through your folder or navigate through the directory that we just created and that we'll be working on and select a folder. After that, Visual Studio Code restarts, and what it does, it opens the folder for you. So in our working directory, let's create a new file. Right click and create a new file. We'll say index.js. Index.js is the entry point for our Node.js app. So index.js being our entry point, we will place all the server codes in index.js and we will try to execute it from the Node.js. So let's get started and create our first web server. For that, we need a built-in package called HTTP in our project or in this file. So let's import. So const HTTP is, we need to require the default package called HTTP on our file. So I'll create another variable called const server equals to, now we will be using this HTTP to create a server. So HTTP dot create server, which is a function. And the next step we need to do is we need to listen the incoming request from our client or from the user. So for doing so, let's write server.listen. Now first parameter would be the port that we'll be listening. So typically in Node.js we use 8000 ports, so let's write 8000. And the second parameter would be the host name. For now, let's write localhost. And the third parameter will be a callback function if the server is successfully listening to port 8000. So in third parameter, when the server is successfully started, let's console.log server is started, right? So now let's try executing this code on our Node.js. For doing so, click at terminal and click at new terminal. When the terminal starts on our directory, type node and then the entry folder or entry file. So in our case, it will be index.js. So as you can see, we have successfully started the Node.js server, right? So let's open our browser and see what localhost 8000 is currently doing. So open up your browser and go to localhost and semicolon and port 8000. So localhost 8000 keeps on running and doesn't provide any response. Why is this? Because we have not done anything for providing the response to our client. So let's go ahead and provide a server response to our clients from our server. For doing so, we need to go into the HTTP create server method, and inside of it will be a arrow function which will have a request and response that is used by the server to communicate with the client. So this would be a arrow function. In arrow function, we will be writing res.end, and we'll be providing the response hello from the server, right? Now we'll be explaining in detail about request and response, or REQ and RES, in the upcoming lessons. But for now, what we are doing is we are sending a response to our client from our server. So let's save this, and then what we are going to do is we are going to restart the server. For restarting the server, you need to click Control C or Command C, and you need to exit this, and then again node index.js, right? And again the server is started, and let's go to the localhost 8000 and refresh the page. And as you can see, it says hello from the server. Congratulations, you have successfully created a first web server. Now let's move into the next lesson. So now that we have learned how to start our first web server, it's now time for us to make that server dynamic in nature. Currently our server is static in nature. Why do I say that? Because every time a client requests on our server, sends a request to our server, every time we reply with them with the text hello from the server, right? We are not detecting the user request, we are doing nothing, we are just responding with hello from the server. This is not a typical how typical server works, right? For instance, if I go into the localhost 8000, it's completely fine that I get hello from the server. But when I go to the localhost 8000/cars, I will want a list of cars, right? Not hello from server every time. Yes, this is a static server, or we are sending only one data no matter where the user goes, anywhere in our URL or anywhere in between the localhost 8000, every time they get hello from the server. This is not how typical website or the server backend works, right? What backend does, it is accept the request of the user and then provide the data accordingly. So what we need to do is we need to detect what request are we getting, so that we can fulfill the request and provide the response accordingly. So for that, let's see what request we are getting. So for that, we are doing console.log request. Let's see what request we are getting for now. So we have changed our code. So let's restart our server. ctrl-c will restart the server. So node index.js. So a server is started. Let's refresh this page. First, let's go to localhost 8000. So when I go to localhost 8000, what you can see here is we get a lot of requests, right? Now the only thing relevant here to us for dynamic routing our server is request.url. You can go through every request information, right? But for now we will look into the request.url. So let's save it. So restart our server once saved, and then node index.js again. Server is started. So let's go ahead and refresh this page. So when I land into localhost 8000, what you can see here is we only get the slash mark over here. And if I go to localhost 8000/cars, what I get on console is /cars. Now that we have the request or the route that user is trying to go, we can dynamically provide the response. We can provide the response in a conditional manner. So how can we do that is if URL equals /cars. If user is going to /cars, then what we'll do is we'll send rest.send, and this is cars, right? And if user goes to, I'll write this with else if request.url/fruits, then we'll send the response. This is for fruits, right? And if the URL is not declared over here, we'll just do else, and then we'll send hello from the server. Let me minimize this a bit and save this code. As you can see here, code is a bit non-organized, right? It is indentation are not making any sense, but when I save this, the prettier does its magic and it organizes the code. That's why we install the prettier. So now the changes have been made in our code. Let's restart the server, and then again node index.js. So if I go into the localhost 8000, right? Hello from the server. If I go into localhost 8000 slash cars, this is for cars. And then if I go to fruits, and then this is for fruits. And then if I go to animal, then again it is hello from the server because it came back into the fallback request. So this is how we handle or how we dynamic route a server, right? This in this case we have listened to the user request and we have provided response according to the request, and this is how the typical server works, right? So you might have noticed when our code base becomes larger, when we do different types of stuff from our backend, this routing part will be very difficult to maintain because each route may have different controllers, it may have different functionalities and so on, and the routes may be 100 if not thousands, right? So it will be very difficult for us to maintain. So there is a easier way for us to do so, an easier way for us to start the server and work on the server, and this is provided by the Express. Now in the next lesson we will be learning and we will be using Express for developing a server and for routing the server, and throughout this course we will be using Express, and I'll explain you how Express will help us build a scalable Node.js applications and why we use Express instead of reusing the inbuilt package HTTP. So I'll see you at the next lesson. In this lesson, we'll be learning about Express, why it is the widely used framework for Node.js, and what is Node Package Manager. Till now, what we have done is we have created our first web server. We have listened to the user request and provide data accordingly, or we can say it we have dynamic routed a server. And then I highlighted the problem that if our code base becomes more and more complex and there are hundreds and thousands of routings and each have its own controllers and functionalities, the code will be very much complex and it will be difficult for us to create scalable applications. So instead of depending on the HTTP inbuilt module of the Node.js, what we will do is we will use Express for the creation of our server and for handling requests and providing the response. Now, Express is a popular web application framework for Node.js that is built in top of the HTTP module. What Express does is it uses the HTTP, but it provides us an easier interface for us to handle the request and provide the response. It also helps us simplify the process of building the web applications. Express offers features like routing, middleware support, request and response handling. These all stuff that will help us make our server more scalable in the long run and organized in the process. So instead of using HTTP, what we will do is we will replace it with Express. Now Express is a package, and for installing these types of package and different other packages we need Node Package Manager. So let's have a look about what Node Package Manager or NPM is. NPM stands for Node Package Manager, and it is a huge online repository of pre-built and reusable code. For instance, we are trying to use Express in our project now, right? So Express is built on top of the HTTP module. Someone or some team developed Express framework so that developers like us can use it for scaling our server and to make our code organized and more effective, right? So someone has already done the job for us. So NPM or package manager or this repository is the way for us to get those packages, so we do not have to reinvent the wheel and spend too much time on things that are already built. So let's go ahead and search for Express. If you want any other package, you can search those packages as well. But for now, let's search for Express. So type Express and click at search. And you can see that the Express is available as an open source on NPM. So you can install this Express through Node Package Manager or NPM. So for that, what we need to do is we need to initialize the Node Package Manager in our project. So how can you do that? Is let's open our code and then let's close all the terminals, start a new terminal, fresh terminal, and then what we can do here is we can type npm Node Package Manager init. What it does, it is initialize the Node Package Manager and makes it ready to use on our directory. So npm init has started doing its job. It is asking for the package name, and Node.js Playground is great for me. If you want any other thing, you can just type in here. For now, I'll just press enter a couple of times, and then it will initialize a dummy project in our directory. So enter a couple of times. There's nothing to worry about in this, just enter will do fine. By initializing the npm in our project, what we have done is we have enabled our project to get advantage of thousands and millions of open source packages, right? Now you might have noticed there have been created a new file over here, the package.json. This is the file that will be created by npm init. Nothing to worry about. There are some of the codes over here that we will go through each of them individually. But for now, what we need to do is we need to install the express. So let's go ahead and type npm install express. So this is the code for installing the package. So npm install express, and then let the npm do its job. So when we installed a package, or when we did npm init, a package.json and other different folders and files were created. Now in this next lesson, we'll be explaining each and every files and folders, and I'll try to give you the clear view of each and every folder and what it does in the next lesson. So I'll see you there. So when we initialize the npm and when we install the express package, there were some files and folders created automatically. We didn't create that, it was created by the system. So let's try to understand what they were. The first thing that we noticed is package.json file. This was created when npm init was executed in our terminal, right? So let's see what's inside package.json. So most of the lines over here are just the metadata of the project, like name, version, description, author, license are just the metadata. Main is the entry point of our project. And the two things I want to stress on this lesson is the scripts and dependencies. So let's first understand about the dependencies, and then we'll go to the scripts. So in dependencies, you can see that express. What does it mean? It means that our project is dependent to the package express. Without express being installed in the system, our project will not run. So when we perform the task npm install express, what happened was we installed the express from the npm repository, and all the installations from the npm repository are under the node modules. So you can see that dependencies and node modules are interlinked. So when we did npm install express, what it did was it installed the express, it brought the open source project and it installed it here over here. So what are the other files that we see inside the node modules are express in itself has some other dependencies, right? So for express to run, this dependencies also needs to be installed in our system, right? So these are other dependencies that express needs to run, and some other dependencies has other dependencies that they need to install for running. So these are a bunch of files and folders that are important for our project to run. So you don't ever need to go inside the node modules folders and make some changes here. We only edit our code, and everything else is managed by the npm. So why is this dependency super important in a package.json? So imagine a situation. You are a developer of a company. You have started to work on a new Node.js project. Everything you write is dependent upon the Express package, right? And you are using other different packages as well. So if another developer comes and you want to share your code, how would he or she know that which dependencies you are using and which dependencies he should install for running your project, right? So these are the things that dependencies hold. Once you share this project with your colleague or with another developer, what they can do is they can run npm install and they can get all the dependencies file for the project to run successfully. So this is the important part of package.json. It not only declares the dependencies but also the version of dependencies that our project depends upon. If there are breaking changes, or if you just say that install express and they install the express of version 2, then that may bring some breaking changes and there may be some problems in our code. So package.json inside dependencies, there are not only the dependencies but also the version that is applicable for our project to run. So these are the important things. Another thing that is important in package.json are the scripts. So scripts in package.json allows us to define and execute various scripts for our project. We'll eventually write some scripts Till then, I don't think it is super important for me to explain in scripts in detail, because we'll use it eventually, and when we use it in our project, it will be much clearer than me just saying it without doing anything, right? So we'll see about the scripts later when we write some scripts ourselves. Another important file that you can see here is the package log.json. So what is this? It is a log file that is automatically created, which has the information about the package and the version that is required for your project to run effectively. So when you run npm install, or you install certain packages, this file get regenerated so that there will be no conflict in the future related to packages. The steps over you see over here is not super important to understand. These are things that will be taken care by the npm itself. So I believe you are clear on what are the files and folders that were generated by npm, what are node modules, what was package.json stuff inside the package.json. So by knowing this, we have opened a pathway for us to use these file systems and these modules. And in the next lesson, we will be installing the Express, and we using Express. We have already installed it. We will be using Express, and then we will redefine our code in the Express ecosystem. So I'll see you there. So after understanding npm, node modules, and package.json, we are now ready to code our server through Express. Now what we need to do is we need to replicate the index.js file by using Express instead of HTTP in build module. So let's create another file so as we can compare index.js and that file, and we can replicate the same things in our another file. So in most of our Node.js project, we keep app.js as an entry file. So let's create that file as well. So app.js. So what we are going to do is we want to compare the index and app.js. In index, we have done our server creation process with HTTP module, and in app.js, we will do it through the Express. And then we'll entirely delete this index.js file and start working on app.js. So the first thing that we want to do is we want to import the HTTP, but not on app.js. We want to import Express here. So const express equals to require Express. So what this did was we brought Express in this file. So our next step is const app. This app is the Express app. We need to declare that this app is Express app. So the next step for us will be to listen the port 8000. So for that, we can write app.listen. The first parameter would be the port, 8000 port, and second parameter will be the callback function if the port listening was successful. So let's do here console.log server connected successfully. Let's save that and let's run this from Node.js, right? So for running this, what we need to do is node. Previously we did index.js, but now we will do app.js. So you can see that server connected successfully. It means that our server is initiated, our server has started from the Express. Congratulations. So another thing that we should build is the dynamic routing system. So how can we build this? Let's first start this localhost 8000 in our browser to see what response we get. So let's go with localhost 8000. So you can see that there is a custom error message that says cannot get slash. It means that there is no route defined that could handle the localhost 8000 slash route. So what we can do is we can define that route. So for that, what we can do is we can write app.get if requests are coming through only localhost 8000. Then the second parameter will be a callback function that would expect request and response, and then we'll write response.send and hello from the server. Right now let's restart this, and again node app.js, and let's see if someone lands in our localhost 8000, will they get hello from server or not. So let me refresh. So hello from server. So we have successfully created the server from Express, and we have also sent a static data from the server, right? Now how can we use Express for dynamic routing? It is too much easier than HTTP module. So in Express, we do not need to detect the request.url and do different other stuffs. We only need to declare the route. For instance, as you can see here, if user goes to users/cars, localhost 8000/cars, then they will get the message this is cars, right? How can we do this in our Express app? So for this, app.get if user lands in/cars, then same you can copy and paste this over here, and you can write here this is for cars, right? Now restart the server and node app.js, and then let's refresh it here. So in localhost 8000 hello from the server, and if I go to cars, then this is for cars. Now compare this code, right, which is readable. If there ought to be 1000 routes, then how complex this code would be, right? Each route might have some functionalities, some codes inside of them, and the page will exponentially grow, right? But in this case, you can see the code is managed, and what we can do is we can export the functions and keep this function in another file, which will make our code organized and easy to read. So this is why you are using Express. Not only this, Express has tons of other features that will be helpful for us in our development journey. So by saying this, let's delete the index.js because it is of no relevance to us, and let's move to the next lesson where we will learn different other stuffs of backend development. So I'll see you there. So until now, what we have done is we have created our server from Express. We have also defined the dynamic routing in our server, but it's always been a hassle for us to start our server every time we make a slightest change in our code. For instance, if I modify the response of hello from the server and keep a simple exclamation sign over here, it will be easier for me if the server restarted automatically so as to reflect the changes. If I make a slight change over here and if I refresh the response, if I refresh my browser to see the response, I see no exclamation sign here because the server is not restarted, right? So I need to manually close the server, and so from ctrlc or command plus c, and then I need to do again node app.js. So by doing this, we are restarting the server, and now we'll be able to see the changes made in our code base. So let me go into the browser and refresh localhost 8000. So you can see that there is an exclamation sign. So if you are dealing with a few lines of codes, and if you are only handling a few requests and responses, it will not be a problem for you to restart your server manually. But as our code base increases, as we are dealing with other more request and response stuffs, and we are dealing with more number of code, it will be difficult for us to restart manually our server every time we make a slightest change in our code. So for that, we need to automate our server starting process, and for doing so, we need to install NodeMon, which monitors the changes in our code and then restarts the server automatically, so we do not have to do it manually every time we make changes in our code. So let's see how we can install NodeMon and how we can start our server through NodeMon. So if you browse into npmjs.com and search for NodeMon, you can see the explanation of the NodeMon and way to use it. So it says that NodeMon is a tool that helps develop Node.js based application by automatically restarting the Node application when file changes in the directory are detected. So this is exactly what we need, as it automates the server restarting process, so we can focus more on our code instead of restarting our server every time. So for us to install the NodeMon in our project, what we need to do is we need to go to the terminal, and then we need to repeat the same process like npm install that we did in the Express. So let's stop the server for now, and then npm install nodemon. So what it does, it brings the code from npm repository and it initializes in our project. So as the nodemon is installed in our project, we need to allow nodemon to start the server for us. For that, what we need to do is we need to go into the package.json, and then in another line of scripts part, we need to keep another line here, and then we need to write start. And when the script of start is executed, we need to run nodemon app.js. So let me explain what we just did over here. So the start script that we just wrote over here is the npm script. So when we type in our console npm start, so npm being the node package manager and start being the script, the identifier of the script, right? So if I do npm start, what it does, it navigates into the package.json, our app navigates into package.json, it searches for the start script and then execute the script, right? So By writing the script, it allows us to do certain operations from our terminal itself. So what we have did is we have written the start script over here, and what start script does, it start the node and it executes the app.js. So what exactly happens here is when we type npm start, our app navigates into package.json. It looks for the start scripts. Then what it does, it goes into the node that is inside our node modules. So you can see that we have a node file over here, as you can see here. So what it does, it navigates into the node file over here, our node package manager, and then through this it executes the app.js file. So let's go ahead and start the server through npm start. Now instead of doing node app.js every time, what we need to do is we need to type npm start, the script that we have just written over here. So what it did, it navigated into package.json, found the start script, and then it executed the nodemon and it started the app.js. So nodemon says that it is started successfully and it is watching for the changes that will be made over here. So server started successfully. If I navigated into the localhost 8000, we can see that it is hello from the server. Now let me make a slight change in our server. So instead of hello from the server, I'll write hi from the server. And if I save the code, nodemon will automatically restart our server. So if I refresh it, you can see hi from the server. So by doing this, we have automated the restarting process, and we'll be saving a lot of time, and we can focus entirely in our code instead of restarting our server every time. So by doing this, we are ready to expound our Node.js application and then dive deeper into the code of backend. So I'll see you at the next lesson. So by automating the process of restarting the server, we are now able to focus on the code and expand our knowledge on the backend development. So from this lesson onward, we will be learning about the file system module of Node.js. So what exactly file system module does, it allows the Node.js to access the device files and folders. So if you look into the default behavior of the JavaScript that is executed on the browser side, it does not have the authority or the access to the file system or device storage. For instance, if I navigated into any site, let it be Wikipedia for now, if I navigated into this site and it executed certain JavaScript code, this JavaScript code does not have the authority or the access to manipulate my file system. Now it is a good thing. Why it is a good thing? Because if the JavaScript had the authority to access my file system, then it could have saved thousands and millions of files that I do not necessarily want, right? It could have saved viruses, it could have saved zip files, it could have saved PNG, JPG that I do not need. So the default behavior of the JavaScript that is executed in the browser side is that it could not save or it could not access the device storage, right? But what Node.js does, it creates an environment, the V8 engine, Google's V8 engine, on which the Node.js is built upon. It creates the environment for the JavaScript to access the device file system through our Node.js or through the JavaScript. So now, as you know, we can access the file system. Let's go ahead and create a file in our working directory. New file and data.txt over here. It is a simple text file that our server will read and it will pass through the response. It will pass it through our response. So for that, what we need to do is first we'll be learning how to read the file, and then in another video we'll be learning how to write a file in our file system. Before reading the file, let's first modify our data.txt to include some of the things over here. So let the data.txt be the name of the fruit. So let me write apple and orange and grape. So I have 3 fruits over here. Now what I need to do is when someone goes into the localhost 8000, instead of outputting hi from the server, I need to show the data that is inside the data.txt. So how can I do that? I can do that using the Node.js inbuilt module fs system. So for that, let's import the fs into our project. So for that, const, I do not need to npm install for it because it is the inbuilt module. So const fs, meaning the file system, is the require. Let's require it from fs, meaning the file system itself. So using the fs module, now we can read the file of data.txt. Now let me write a comment over here in Node.js. You can, or JavaScript, you can write comment through /. So we will read file over here, right? So after writing the comment, let's use the fs file module. So for reading the file, what we need to do is we need to write fs, meaning the file system, read file, and the first parameter will be the directory or the place where our file is located. For that, it will be dot slash is the working directory. It is the working directory that we can see over here, and in the working directory we have data.txt. So let's go ahead and write data.txt. Now what it does is it will read data from data.txt. Second parameter will be the encoding. Let's write it utf8 for now. And the third parameter is the callback function. Now it will have two parameters. The first one is error. If some error occurs, then the error will be triggered, and the second one will be data. It will, if everything is good, if it find the file and it could read the file, then the data will be triggered, or the response of the file or the contents of the file that we are reading right here will be available in the data. This is a error function. And then what it will do is we can send the response from here itself instead of sending the response from here. So rest.send, and we will be sending the data that we have just read from data.txt. Now let's remove this. Now save the file, let the prettier do its job of formatting, and then start your server. Now going to the new terminal. I have not started the server. If I had started the server, then nodemon would have restarted it. For now, npm start, which means nodemon app.js. So by doing npm start, we will be starting our server. Let's go into our browser and see the response. So it's currently saying hi from the server. It is a previous one. So if I refresh it, you can see apple, orange, and grapes that is saved in our data.txt. Now let me modify a little bit in our data.txt. So apple, orange, grapes, and the another fruit will be the mango, right? If I save into it, the node.js does not modify because it looks only in the changes of JS, MJS, and JSON. For now, we need to configure additionally for data.txt or .txt file, but we will not do it now. What we will do is we will resave the code without any changes. By saving the code, it also assume it to be changed, so it will restart the server. And if I refresh this page, I can see apple, orange, grapes, and mango. That is the updated data of data.txt. By doing so, we can read the file using the fs module of node.js. But what happens if I provide a URL or the file system that does not exist in our system? Let me say data.txt. Now if I refresh this, our node.js server will not be able to detect this file. So I need to throw some error response over here, right? So for doing so, I can write if error exists. This means that if something is in the error, then what we need to do is we need to send rest.send, and then we need to type that there was an error accessing the file. So we can handle the fs system module error like this way. So let me restart the server. Let me rebrowse the file, and there is the error. There was an error accessing the file is the response that we will see, because this data does not exist in the file system. Now if I provide the valid file system, then it will be able to show us what are the contents inside the file. So in this way, we can use the fs module to read the file in our file system, and in the next lesson we'll be learning how to write file in our file system using the fs module. So I'll see you there. So now that we have understood how we can read file from the file system using the fs module of node.js, in this lesson we'll be learning how you can write a content to the file in the file system through fs module of the node.js. So for that, I'm going to use this route, but instead of /cars, I'll be writing /write. So if someone goes to the localhost 8000 /write, instead of reading the data, we'll be writing to a data. So for that, instead of sending the response of this is for cars, I'll be using the fs module over here. So fs dot for writing the file, we need this function fs write file. The first parameter will be the same one as the read file, meaning the working directory, and then the file data.txt. We will be writing a data.txt for now. The second parameter over here would be the thing that you want to write to that file. So for now, as it is the list of the fruits, I'll be writing the cherry over there. And the third parameter, as there is nothing to return, the third parameter will be an arrow function that will have parameter of only error, right? So you can see the difference between the read file and write file. In read file, there is an encoding thing that we do not use on the write file. Instead of encoding, there will be the content that you want to write into that file. And in the callback function, there is no data, as there is nothing to written over here. So if this is successful, we'll be showing that response.send, or we'll be sending the response that file return data returned successfully, right? And we should also handle the error, and if anything happens, or if there is a data in the error in this callback function, in this parameter, then we should write the res.send, res.send, meaning the response.send, and it would be error writing to file. So let's go ahead and test this. So for that, we need to go to the localhost 8000/write. So currently in localhost 8000, what we can see is the list of fruits that we have in data.txt. So I want to navigate into the right thing or right route, and if I press this, it will write this is for cars. But this is not the expected response that we are trying to get. So let's see in our code and what we have done wrong. So our app has also crashed, and when app crashes, when we are using the node it will wait for something to change in our code so that it can start the server again. So the error that I see here is you cannot send res.send for 2 times in a same route, right? If the response is already sent, then you cannot send respond again, because the data or the response to the client is already sent, so you cannot resend it. So we had forgot to remove this line, so let's remove this line, let the node do its job and restart the server, and let's check the route again. So if I click or refresh this page, it will say that the data returned successfully. Now let's verify. Let's go into the data.txt and see for ourselves. So you can see cherry, but the problem over here is it has replaced all the contents that were previously here, like mango, orange, and other stuff that we had there. So how can we preserve the current data and then append the new data on the file itself? So let's learn that. So in the case you don't want to lose the previous value, instead of writing the using the code write file, you should use append file, right? What append file does, it preserves the previous values and then adds new value into it. So when someone visits the localhost 8000/write, we'll preserve the current value and then add cherry right next to it, right? So let's test this. So going to the localhost 8000/write, and then data is written successfully. And if you visit into it, the data.txt file, you can see there are 2 cherries. Now let me send the request again, and you can see that there are 3 cherries, a lot of cherries. But if you want the cherry to go into the next line, or if you want to break the line, you can also use /n over here. So let's write into that file again. So if you refresh it and if you see data.txt, you can see there is a new cherry over here. And if someone goes to localhost 8000, we have read the file and we have displayed the contents over it. The thing you should know about append file and read file is that if the file system or if the FS module could not find this file specified, the append file and write file creates that file for you, so you can write data on the new file. For instance, if I provided the file that does not exist in our system, for instance datas.txt does not exist in our system, but if I run this code anyways, localhost 8000/write, then it says that data returns successfully, right? So it creates a new file. Append file and write file creates a new file and appends data or writes data into it. So this is also the thing that you should understand. So let me delete this file for now and then revert this data to data.txt. So this is how you read and write file of the file system or the file of the server using the FS module in Node.js. What made it possible is the environment that Node.js created for the JavaScript to access the file system data. So in the next lesson, we'll be learning some of the other things, and then we'll wrap up the FS module. So I'll see you there. So there are a lot of things that we can do using the FS module of Node.js. We have only learned a few. We have learned how you can read a file, how you can write or append to a file. But if you go into the documentation of FS module, if you search for Node.js FS module and go into this documentation, you can find tons of stuff that are available for the FS module system. For instance, you can change the permissions of the file, you can read file as a stream, you can sync the file, truncate them, and different other stuffs. But we will not be learning each and every one of them. And the reason is, in Node.js, we do not use file system as often, right? We use databases to store the data, to retrieve the data, to update the data, and do other things that are related to the data. And in this course, we'll be learning about how we can use MongoDB for the storage of the data. In real world application, there is barely any system that uses the file system to save the data and to retrieve the data, right? But you might need this occasionally, so I have included this read system and write system. But in this course, FS module is not relevant and we will not be using this module in any time throughout this course. But if you are interested to learn more, you can always go to the Node.js documentation and then you can search for the FS module and then you can try out all other stuffs. So instead of learning these things that we will barely use in the future, let's learn something that is relevant to us. So by saying this, let's move to the next lesson. So throughout this course, we'll be working with lots of requests and responses. We'll take requests from the client, process it in the server, and then provide the adequate response to the client. And every request and response processing will be done by an API. API stands for Application Programming Interface. And before diving into the code of API or coding the API, let's first understand what API is. So think of a restaurant for a while. When you go into the restaurant for consuming some food, do you actually go there, cook yourself, bring the food into the table by yourself and then consume it? No, you don't. You ask for the server or the waiter to bring a certain type of food from the kitchen. They bring it to you and then you consume it, right? So think API as a server or a waiter in the restaurant. What they did was they took the order from the client, right? They took the order to the kitchen provided them with the dish and they served it to you. So you can associate the server or the waiter as the API, right? So what API does in our system is it takes requests from the client, it then processes it, it takes the data or the data that is relevant data from the database and then it serves the response to you. So this is how the API works. API is an application programming interface where the client can communicate with the server or the database. Database has a lot of stuffs. So think of database as a kitchen in a restaurant. In a restaurant kitchen, there are lots of dishes being prepared simultaneously. But the only dish that is relevant to the client is the one that they ordered. So the responsibility of the API or the server or the waiter is to bring that particular dish. And this is how the API works. It gets the request from the client and provides the necessary response by processing it in the server. You might have heard about REST API before, and in this lesson we'll be understanding what REST API is and how it is different from a normal API. REST API in itself is not a different thing. REST API is an API that has a certain design principles and set forth a ways or methods in which the client can request or send request data to the server and how the server responds to those requests. So you can say that a REST API is an improved version of API. REST API is widely used in a backend development and in the front-end development as well, because it has clear rules of how a client can communicate with the server and it has methods which determines what things need to be done when a client requests for the certain things on the server. So let's see an example. So this is how a typical REST API works, right? The things you see over here are the methods of REST API. This is the client and this is the server where all the processing is done. So what happens at first is client request for some data or it provides some request data to the server. Now the REST API has certain methods in which it can send the data through. For instance, to get the data from the server, they should be using the get method. These are the method. For getting the data, the client should be using the get method. If they are trying to post some data on the server or keep some data on the server, they should be using the post request. If they want to create something in the server or if they want to edit it, they want to use put or patch request to the server. And if they want to delete certain data or remove certain data from the server, they should be using the delete method. So what REST API does with its design principles is that it set forth a certain ways for the client to send request to the server. Not only that, it also help the developers, front-end developer and back-end developer work in synchronization, as it makes it easier for them and provide a standard way for the request to be sent and the response to be received. It also helps multiple developers work on a single project, as everyone will be familiar with the methods and they will beforehand be able to understand what the method is doing. So by creating any standard, it facilitates the developer, reduce the development time and work in symphony. So REST API is popular, and throughout this course we will be using the REST API, and we will be using this method from Postman and through the front end to achieve what we are trying to achieve. So by saying this, I hope you have understand what REST API is, how it is different from the API. So let's move to the next lesson. So to make it easier for you to understand what API is, how API works, what are the method of REST APIs, and in general, to make it easier for you to understand how we can test an APIs, I have created a project for you. I have named it Movies Database Dummy API for Node.js. The resource file for this project can be found in the next lesson. Now this is only a test project that gives you a basic idea of how API works and how we can test in API. It is not necessary for you to understand every code that is written inside of it. It might be too complex for you now. We will be only using this project for understanding the API and API testing. In the later part of this course, we'll try to replicate this API and create an API similar to this. But for now, you do not need to understand every code that is inside of it. So simply go ahead into the next lesson and download this code, and we'll only be using this code base for testing the APIs, and I'll see you in the next lesson. So now that you have downloaded or cloned the MoviesDB dummy API, we are ready to install dependencies and make it work. So for that, open the folder in your Visual Studio Code. After opening the folder in Visual Studio Code, go to Terminal, New Terminal, and for this project to run successfully in our device, we need to install the dependencies. So navigate into package.json and see what are the dependencies that this project is dependent upon. So the first one is Express and the second one is NodeMoon. So it says us that the dependencies are Express and NodeMoon, and without this project will not run successfully. So for that to install, let's type in our terminal npm install. So after all the dependencies are installed, go ahead and type npm start. If everything is good, you should see server started successfully. Now navigate to your browser and type localhost 4000, because this time our app is listening at the port 4000, right? So navigating at localhost 4000, you should be able to see the documentation page for this API, which means that the server is working fine and we are ready to test this movies API on our device. So let's go ahead and see what are the API endpoints that we can test. So the documentation states that the base URL for testing our API is localhost 4000/API. The combination of base URL, the method on it, and the route is what makes the API URL complete. So let's go ahead and try our first API endpoint that says get all movies. For that, let's copy the base URL and then the route that says get all movies. So localhost 8000/API/movies, and if I browse through this URL, I can see that the API has responded me with the list of movies. So if you are using the Mozilla Firefox browser, the data on the JSON will be shown in a structured format. If you are using Chrome or any other browser, it can be shown in a raw data. It does not matter how the data is shown to you. What does matter is that API is responding fine and we are ready to test the APIs. Now what we need is an API testing platform that we can use to test all these APIs that are available to us. It is not a good approach to test the APIs through browser. Even if we can test the get method, it will be difficult for us in the long run to test post, patch, delete and other method of REST API through our browser. So we need an API platform where we can seamlessly test and debug our APIs. And for that, we will be installing Postman, which is an API platform that will make our API testing easier and efficient. So in our next lesson, we will be installing Postman and we will be testing these APIs through Postman. So I'll see you there. To test the APIs and to make our process of testing API easier, we will be installing Postman. Postman is an API platform that will help us run and debug our code in an easier way. So visit postman.com on your browser and then download Postman on your device. So after downloading and installing the Postman, this is the screen that you should be presented with. If the Postman asks you to sign up, create a free account so that you can access your API code later in another devices. So after this screen is shown to you, click at new, and by clicking at new, we will start a new collection. Now that we have created a new collection, let's rename it as Movies DB. So in this collection, we will be testing our APIs. Now navigate into the Visual Studio Code, open up the project of Movies DB dummy API for Node.js, go to terminal, new terminal, and start the server. Type npm start and your server will be started. If you had previously started the server, then no need to do this. Then after the server has been started successfully, navigate into localhost 4000 to see the documentation again. So in localhost 4000, you can see the documentation. Now it's time for us to test this API from the Postman. So let's test the first API endpoint that we tested from the browser previously. So the first API endpoint is get all movies, and for that we need a base URL, we need a method, and we need a route. So let's copy the base URL localhost 4000/API. Open up your Postman and expand it. Right click on it and create add a request, or you can simply add a request from here. So add a request, right? And in the new request, you can rename it and say get all movies, right? And as you can see here, the method will be get method. So in Postman, you can see a method switcher here. So the method is get method, and the URL base URL would be localhost 4000/API, and then the route would be /movies. So the complete API route would be http localhost 4000/API/movies. So navigate into the Postman and type it here. So if any spaces are left around here, you can clear it and you can save this code. Now after you click at send, you can see the response of API over here. So you do not need to open tab every time in the browser to test an API, and you can save API in the Postman and access it faster, and you can debug your code faster. So this is how we test an API on Postman. So in next lesson, we'll be importing other routes as well and work with other route through Postman. So I'll see you there. So now that we have added get all movies API to our Postman, it's time for us to add other APIs as well. So make sure your server has started successfully and then navigate to localhost 4000 to access the documentation. Now another API that we will be adding, or another API endpoint or the route that we will be adding, is for getting a single movie. So for that, navigate into the Postman, and instead of writing everything like localhost 4000 API movies, we'll simply right click on this request and then duplicate it. And we'll rename this as get single movie. So if you see the routing of this get single movie, there is a dynamic string. By the way, if you see a curly braces like this in a documentation of an API, it means that this needs to be dynamic if it is surrounded by curly braces, right? So what our API endpoint is saying, that our API will be getting a single movie if we pass a movie ID into it. So how do you get the movie ID? We can get the movie ID by querying all the movies at first. So let's go navigate into the Postman and see the get all movies API. So you can see that in every part of this array, or the every object of this movie object has a unique ID over it, right? So what we need to do is we need to copy this ID, and if you want to see the response of get single movie as the Grand Budapest Hotel, then you need to copy this ID and then you need to paste the ID over here. As the API endpoint says in the documentation, /movies/movie ID to be a dynamic ID. So if you send this request, then you can get the Grand Budapest Hotel in the response. Let's try with another ID. So if I want to get the movie of the Intouchables, I need to copy this, and then in get single movie I need to pass this ID over here, and after sending the request I can see the Intouchables. Now let's add another important API endpoint that is for creating a movie or adding a movie in the database. Now for this we will be using a post method in a slash movies route for creating a movie. Now post method is a little different from the get method. Let's get started by adding this in a postman. So instead of writing everything from the start, let's duplicate this at first. And after duplicating, let's rename this. Rename this as add a movie, right? And this time the request method would be a post method because we are sending some data to the server to be added. We are sending some data to be processed. So these types of data, if you want to send some data for server processing, then we will be sending through a post request. Now we'd also need to modify the URL of our API request, because in post request it is said that we need to query API slash movies, and this dynamic ID should not be provided in the post request. So we will modify our script, our API URL accordingly, and then without doing anything or without sending any payload data, let's request this at first. So if you send this, it says the movie name is required. Now this error is triggered because you are sending a request in the server for a movie data to be created, but you are not providing any parameters like movie name, rating, and information and all other informations that is required for creating a movie. If you look into the API endpoint or the API documentation, you can see that this post request requires a payload which will include the movie name, the name of the movie, which will be of type string, and then the info, which will be a type of string as well, so which is the movie info, of course, and then the rating, which will be a type of number, and the rating should be between 1 to 10. So how do you send a payload in a post request, or how do you send data to the server, is we need to navigate into the body tab, and then instead of none we should switch this to raw, and then instead of text we will be sending the JSON. So the reason for us to use the JSON for the request payload is because JSON is extremely light, the file size of the JSON is very small, and it is in the human readable format as well, and it processes faster in the server. So we'll be using JSON as in request payload. If you look into the get all movies response of the get all movies, you can also see that the response is also in the JSON. So entirely in this course we will be using JSON for sending the request and getting the responses. So using the JSON, let's send the payload that is being requested by our post route. So the first payload or the first data or the first parameter is the movie name. So for sending the movie name, let's start our JSON file. The first key would be the movie underscore name, right? And the movie name, let's let the movie name be the best offer. And the second parameter that it expects is the info. So let's write here info, and the info will be this is great movie. And the third parameter that it expects is the rating. It should be between 1 to 10. So let me write the rating over here, and it should be in the range of between 1 to 10. So I want to rate it as 9, and then click at beautify so that your JSON gets formatted, and then click as send. So if you are doing everything fine, then you should get the response of 200. Okay. Also, I have got the response of movie added successfully. So if I go into the get all movies route and then send the request or refresh the request, I can see that the best offer has been added in the database. Right. So our add a movie route is working as expected. Now there are two more routes that need to be added for editing a movie and deleting a movie that we'll be doing in the next lesson. So I'll see you there. So until now we have added three APIs, one for getting all the movies, one for getting a single movie, and one for adding a movie to the database. Now it's time for us to add the two other remaining APIs from our documentation. One is the edit movie API that is using the patch method, and another the delete movie API which is using a delete method. So before adding these routes in our Postman, I want to take a time and explain about a feature of Postman that will help you when you are working in a production or development environment and when you are handling a large number of requests in your Postman. So the feature that I'm going to talk about is the Postman environment. If you see at the left hand side of your Postman, you can see the environments. This environment will help you save certain variables so that you do not have to repeat yourself by using same variables again and again. So let me explain how it's done. So for creating an environment, you click at the plus icon, and after that you name your environment. Let the environment be, click at rename, let the environment be development environment for now. And inside the development environment, you can declare some of the variables that you will be using throughout this environment. So the first variable we will be using is the URL variable. So the initial value will be our base URL. So http localhost 4000/API is the base URL that our documentation has given us. So for now we will be setting the URL value to be localhost 4000/API. So we will copy this and we will also paste it over here if it is not available here automatically. So initial value is localhost 4000/API and current value is 4000 API. Now save this environment and go to your collections and then switch an environment from here. Now switch to dev environment, and after you switch to dev environment, the variables will be available globally on all the requests, right? So in get all movies, instead of writing localhost 4000/APIs, you can simply replace all of these with two curly braces and then URL and /movies. So what this means is localhost 4000/API and then /movies. So we do not have to type http localhost 4000/API every time. What we have done is we have created a variable in our environment, in our dev environment, right? We have created a URL variable and then we are using the URL variable throughout all of our requests. Now if you have multiple collection and if the environment is set to dev environment, then you can access the URL variable from anywhere from any request, right? So let's go ahead and replace other base URL as well. So copy this URL and then replace it over here as well, right? So localhost 4000/movies/movie name, movie ID. So in add movie as well, do the same thing. Now if you call this API get all movies API, you can see that you will get the same result. The advantage of using the environment or environment variables is that you do not have to repeat. Not only URL, we will be using this environment or this environment variables in authentication as well in our upcoming lessons. So I'm making you prepared for what we will be using in the future as well. So let's go ahead and create or add the routes that were missing in our requests in our Postman. So the routes that are missing is the pass route and delete route. So right click as movies DB and create add a request, right? And this will be the request for editing our movie. So edit a movie, right? And then the URL will be base URL, and then the route would be /movies. So let's go ahead and type movies. And in patch, the patch will work as same as the Postman. It will also accept the payload data. And according to our documentation, it says that the payload movie ID is required. And then providing the movie ID, we can edit other parameters like movie name, info, and rating. So the most important variable or the required variable is the movie ID. So you know how you can send the JSON request to our server. Navigate into body and then raw and then JSON, and then you can send the JSON data over here. The first variable will be movie_ID, and the movie ID, as you know, you can get it from the get all movies. So if we want to edit the Grand Budapest Hotel, copy this ID over here and then go to edit a movie. And I forgot to change the route or method of this request. It will be a patch request according to our documentation. Save this and then provide movie ID here, and then what you want to do is you want to send a key, or you want to say a key and value pair or the parameter to change certain request, right? So in get all movies, if you want to edit the movie underscore name, provide movie underscore name over here, right? And the movie name will be, for now the movie name is the Grand Budapest Hotel. Let's copy this, and then instead of Grand Budapest Hotel, we will be replacing as English. Just editing, nothing too fancy. So if I send this request, I can see that the movie has been updated successfully. If I go to get all movies and then refresh this page or resend the request, you can see that the movie name is edited. And the variables that we can edit has been provided by the documentation. The other parameters that we can edit is movie name, info, and rating. You can also simultaneously edit two or more options. For instance, if you want to edit the rating, you can provide the rating as well. For now, let me set the rating to 2 and then send the request. After the movie has been updated successfully, let's go to get all movies, and then if you refresh this, you can see the rating has also been updated. Now that we have successfully edited the movie, it's now time for us to add the last remaining API endpoint, which is the delete movie API. So go ahead in movies DB and then add a request. This time our method is the delete, right? And the base URL is URL and then movies. And then according to our documentation, the last parameter is the dynamic string or the dynamic data, which should be the movie ID. And the way to get movie ID is to see on get all movies. And if you want to delete this Grand Budapest Hotel, copy this ID and then also rename this delete a movie and then save this. And then if you provide 50073 or the ID of the Budapest Hotel and send it, the data will be removed or the movie will be deleted from the database. And if it says movie have been removed successfully, you go to get all movies, and then if you reload this, you can see that the Grand Budapest Hotel is no longer available in our list of databases or list of movies. So now that we have added every API endpoint in our Postman and tested every API, it's now time for us to replicate the same API using the MongoDB database. In our upcoming lessons, we'll be trying to replicate this API and we'll be trying to duplicate the request and response cycle of this API using the database CRUD operations. The main reason for using this test API or testing this API was to make you understand how the request and response cycle work, how environment variable works, and many things in between. Now this has created a solid foundation for us to test the APIs. In our upcoming lessons, we will be creating the actual API through Express, MongoDB, and Node.js. So I'll see you in the next lesson. Now from this lesson onward, we will be trying to replicate the MoviesDB dummy API. We will be replicating all the API endpoints that we had tested in the Postman before. We will be working in depth with requests, responses, payload data, different routes, and this time we will be saving the data on MongoDB database instead of saving the data on JSON file using the FS module. And now to get started, let's create a new project. So for the new project, I'll be using the name Movies API using MongoDB. You are free to choose your own project name. Now let's go ahead and open this project in Visual Studio Code. So the first thing that needs to be done to start a new project is creating a new file with name app.js, which will be our entry point for the app. Now go to the terminal and start a new terminal, and in this project also we will be using the Express, MongoDB and different other packages. So for that we will need to initialize the npm in our project. So npm init to start npm in our project. So pressing enter multiple times will do the job for us. So after that we will be getting the package.json, and for now let's install the Express and NodeMon for speeding our development. So npm install Express and then npm install NodeMon. After the NodeMon is installed, you want to navigate to the package.json and add a new line in the script that says start, and it will command our Node.js to open our app.js from NodeMon. So save this file and we are ready to go. Now let's start by creating a server. So navigate into apps.js and const express. We are requiring or importing the express over here, and then const express is require express, and our const app is the express app, right? And this time we will be listening app.listen to port 8000, right? And in the callback function we will be writing console.log server started successfully, right? And let's save this and start our server with npm start. So if everything is working fine, your server should be started. Now if you navigate into the Postman, you can see that there are 5 API endpoints with different methods that does different thing in our backend. So now our task is to replicate these routes or these API endpoints. Now let's navigate to app.js and write our code over there. Now if I write everything in the app.js, then the code will be too much complex for me to maintain and to code itself, right? So instead of writing everything or every logic in app.js file, what we will do is we'll create a new folder named controllers. So new folder named controllers, and we'll be keeping our logic and functionality of each route inside of controllers. So now let's go ahead and create some route in our project. So let me comment this as routes. So the first route that we'll be adding to our app is add a movie route. If you look into the postman, this add a movies route will be the first route that you'll be adding. So you might be asking, why add a movie route? Why not get all movies at first? Because to get all the movies, you should have some data in the database, right? Now we are trying to create a new database. When we will create a new database, there will be no movie data in the database. So to query the database and get all the movies, first we need to add some data in the database. So for that reason only, we will be adding the post request first in our app. So to accept the post request from the user, instead of doing app.get, we will be doing app.post. And if user lands to API/movies, as you can see in this postman, if a user lands at, if you see the base URL, it's localhost 4000. In our case, it's localhost 8000. And if someone lands to localhost 8000/API/movies, in our case, it's localhost 8000 API/movies, then I want them to be able to receive some request or get their request and then provide some response, right? But instead of doing this, or instead of providing all the logic in this app.js file, what I want to do is I want to create a different JS file and then handle all the logic and functionalities from there. By doing so, what we will do is we will not be cluttering up our app.js file, and it will be easier for us to access the functions in the future and also make our code more maintainable and more simpler, or not too much complex, right? So instead of doing arrow functions over here, what you want to do is you want to go to the controller and then create a new file and rename that file as addmovie.js. Now inside of add movie, I want you to create a variable. So const add movie is a arrow function, dummy arrow function, and then we also want to export this. So module.exports, by exporting, what we are doing is we are making this file available for this another file to access, right? So if you export it, the function from here, you will be able to access that function over here. So this is exactly what we need. So module.export is what we will be exporting is add movie, right? And if you save this and if you go to the app.js, and in the second parameter we will be writing add movie. Now in some cases Visual Studio Code will automatically suggest you the import, but if it does not, you can move to the end of this word and press control space or command and space, and the Visual Studio Code will suggest you with that file. And if it does not, you should be importing this manually. So the way to import this manually is const add movie. So the same variable that is here, so it will be imported from require working directory, controllers, and then add movie.js, or JS is also not required, right? So if you save this, you can see that now, so if some request is sent to API/movies, then the request will be handled by add movie. Now let's go ahead in our postman and create another collection. So the reason for adding a new collection is because we do not want to get confused with this existing API endpoint. So go ahead and click at the plus icon and rename this new collection as movies API using database, or anything you want. Movies API using database. Now we will be adding the first request over here. So expand this and click at add a request, right? And in the request, our request will be of post method, and the URL will be http localhost 8000/API and then /movies, right? This is our route. So let's first start our server by npm start, and after the server is started, let's go into the postman and send a post request. Now if I send a post request on this route keep on loading and does not provide any response. The reason for it to not provide response is because we have not provided any response in our code, right? So let's go ahead and provide a response from our code. So to send a response from this add a movie.js, so if someone lands into this route using a post request, then they will be forwarded to this route, and from this route we will be trying to send a response to our client. So for sending the response, we will be needing the request and the response variable. So if you are using this app.post, app.get or anything from here, then the second parameter will be able to assess the request and the response, right? So now that we have request and response over here, we can send response dot status 200 is 200. Okay, this everything is working fine. And then the JSON, and inside of JSON we will be writing the status success. But for now, let me write this as this is add a movie route, for me to detect that everything is working fine. So by restarting, so the node has restarted our server. Now if I navigated into the postman and send this request again, you can see that this is add a movie route. So everything seems to be working fine. So now that we have a post request which will create a movie, let's go ahead and integrate database into our system and then add a movie in real time. So I'll see you in the next lesson. So it's now time that we integrate a real database into our Node.js app. So we'll be using MongoDB as our database in this course. The reason for using MongoDB is that they are extremely fast, they are performant, they are reliable, and they are easy to scale. Now there are two ways to use MongoDB as our database. The first one is using MongoDB locally, in which you download the instance of MongoDB into your system and then use it from there. And the second way is to use MongoDB Cloud Storage, or MongoDB that is hosted in the cloud, which is also known as MongoDB Atlas. It is a service provided by the MongoDB for those users who want to host their database in the cloud. And we will also be using the MongoDB Atlas or cloud hosted MongoDB because it is too much hassle to install it locally. And by the way, you will still need an online hosted MongoDB instance if you are going into the production anyways, right? So why not start from now? So we will be registering our account, or we will be signing up for MongoDB Cloud, or also known as MongoDB Atlas. So create your free account to get started. So click at try free and then sign up using your email address. You can also use your Google account for easy sign up. So once your account is created, you can accept the privacy policy, you can read it if you want, and then click at submit. And then if you are prompted with any other questions, you can answer that. And in the deployment process, select a M0 free version for now, because we will be hosting it for free for now. And then the provider is AWS is completely fine. And then select one region. And then let's rename it as my DB data for now, or you can change the database name to anything you want. And when this wizard is shown to you, select username and password for authentication. And username will be our username for connecting the database. The password, you can select a password or auto generate a secure password and copy this password for using it later. So let's copy it and then paste it somewhere in your notepad, your notes, or somewhere, so that we can access this again. And then click at create a user. After creating the user, we are ready to move into the next process. And where would you like to connect from? So we would like to be connected from our local environment from now, not from the cloud. And then in the IP address, write 0.0.0.0/0 is globally accessible. When you go into the production, you can change this. But for now, you add this accessible from any part of this world. And click at add an entry and then finish and close for now. So once you have done that, you will be presented with the dashboard of our database. Now our first task will be to connect to our database. So click at connect, and if you have prompted with this, click at drivers, and then you need to copy this connection string. So go ahead and copy this connection string, and let's modify this a little bit. Now this time we will be using the password that we had saved previously to replace this connection string. So copy it and then paste it, and then take the password that you have saved somewhere in your file, and then replace this password placeholder with your password. Now this will be our connection string for connecting to our MongoDB database from our local device, also from the production, and also from the Node.js app. Now securely store this connection string for using it later. Now click at close, and then we are done.
Now, if you want to see the data that are collected in your database, click at Browse Collections, and then you will be able to see the data that have been stored in your database. Now, there are two ways to view the data that is stored in your database. One is to use this online portal or go into the MongoDB Atlas and use this dashboard to view the data in the Collections tab. The another way to view our data is using the MongoDB Compass app. It is a native software that we can use in our system. It is a convenient way to view the data. So we'll also be installing MongoDB Compass for viewing our data on the database. So let's go ahead and install MongoDB Compass as well, because every time logging into the MongoDB Atlas and seeing it from the browser is not a very good way to access our database, right? So let's go ahead and install MongoDB Compass. Now search for the MongoDB Compass and then download the MongoDB Compass on your device. So once the MongoDB Atlas is installed on your system, this will be the user interface that you will be seeing. And from the new connection, you want to copy the previous connection string that you have built, the connection string to connect the MongoDB, copy it and paste it over here, right? And then click at save and connect. We also want to connect, and then also we want to save this connection for using this later. So click at save and connect, and then it wants the name for saving this. So for now we'll be writing testing database, right? And then select the color of your choice and then save and connect. So this will try to make a connection to your MongoDB. So once the connection is done, you will be presented with your database. Now you don't need to go into your website or MongoDB Atlas website and log in to see your data from there. This is a convenient way to access your cloud stored MongoDB database. Now if you go into the database, you can see two databases. Do not delete that. These are automatically created by the MongoDB. And now we will be creating the database from our NodeJS app. So in this next lesson, we will be learning how we can connect our NodeJS app with the MongoDB Atlas that is hosted in the cloud. So I'll see you at the next lesson. So now that we are able to connect to our MongoDB cloud from MongoDB Compass, it's time for us to add MongoDB on our Node.js app so as to save, retrieve and perform other necessary operations. So for making a connection to the MongoDB from our Node.js app, we will be needing a package from npm. Now there are two packages available for making a connection to MongoDB. The two packages are Mongoose and MongoDB. Now MongoDB is a Node.js driver. It is an official MongoDB driver for Node.js. But I personally prefer Mongoose. Now Mongoose uses MongoDB under the hood, but it also provides many features that MongoDB does not provide, like creation of schema, models and different other data modeling things. It will be easier for us to use Mongoose, and many developers, millions of developers use Mongoose while they are working on the MongoDB database from Node.js. So we will also be using Mongoose. We will not be using MongoDB. Although you can use MongoDB and you can research on it, but throughout this course you will be using Mongoose and performs operations from Mongoose. So let's go ahead and install Mongoose in our system. So if you haven't started server, close it for now, and then npm install Mongoose. Once the Mongoose is installed on your system, you can go ahead and import the Mongoose. So const Mongoose equals to require Mongoose. Now what you need to do is you need to make a connection. So I'll comment it connection to MongoDB. Now the way to make a connection using the Mongoose to MongoDB is mongoose.connect, and the first parameter will be the URI or the connection string that we had saved previously in our MongoDB Compass. So bring that over from the MongoDB Compass or any place that you have saved it previously and paste it in the first parameter. And in the second parameter, we do not want anything, so pass an empty brackets. And then if the connection is successful, we'll be getting an console.log connection to MongoDB successful. And then if error, we'll be throwing an error like console.log connection to MongoDB failed, right? Now after saving this, if you restart the server, You can see that server started successfully, and then the connection to MongoDB was also successful. In this way, you can connect to your MongoDB database using Mongoose. Now in our code, we have exposed our database string or our connection string to our database. It is not a very good way to expose critical information like this or hard code critical information like this in our code. So in our next lesson, we will be learning how we can secure the sensitive data on our Node.js app using the environment variables. So I'll see you at the next lesson. In this lesson, we will be learning about the environment variables. Environment variables are a way for us to securely store the sensitive data. Instead of writing this in a plain code and hard coding it in our program, we'll be storing this type of sensitive data, like sensitive data may be connection to our database, API keys, API secret code, and stuffs like that. This type of sensitive data will be stored in our environment file or .env file as you call it, instead of hard coding in our code itself. So let's go ahead and store this connection string in our environment or environment file or .env file instead of hard coding it over here. So for that, create a new file and rename it as .env, meaning an environment variables. So in environment file is nothing but a combination of key and value pair. So let me create a key and value pair for our Mongo connection string. So for that, I'll be writing Mongo underscore connection, right? This will be our key for the connection, and then the value will be, let me cut this and paste it over here. So we have taken out the sensitive data or the connection string to the database from our app.js hard-coded file, and then we have kept it on our environment variable or .env file. Now it's time for the app.js file to access the environment variable. For that, we will be needing a package called .env. So if your server is running, close that server for now, and then npm install .env. So once it's installed, we need to require or import that .env. So for that, after the express, write const or simply require .env and then env and then initialize the config function. So save your code, and after the code is saved, you will be able to access the environment variable key and value pair. And the way to access this is, now the previously where we had a string for MongoDB connection, we can access the Mongo connection string from our env file by using process.env dot and then the connection string key. So Mongo underscore connection. So let's save this and let's start our server. npm run start or npm start. So the connection to MongoDB is successful, meaning that our .env file is working as expected. Now even if I push this code in a repository, I will not be pushing the .env file into my repository. So in this way, my connection string to database will be secured. Now if anyone want to replicate this code or use this code for their own purpose, they will be needing to create an .env file on their own, and then they need to provide Mongo connection and their own connection string to database. Now if I want anyone of my team or any developer to have access to my database, I will share this .env file secretly to them. I will not be pushing this file in the repository. So everything or every code I write inside the env file will be secured, and only my team members, my developers, or me individually can access those key and value pair. So now that we have learned how we can securely store data on environment variable instead of hard coding it, it's time for us to make a progress in our course. So let's move to the next lesson. In this lesson, we'll be learning about models and schema, and to make you better understand how models and schema work, I've created a Google Sheet for you, which will act as a dummy database for understanding the basic concept of models and schema. So this models and schema thing is brought by Mongoose, and it is not a feature of MongoDB. This model and schema of Mongoose will help us structure our data and then model our data in an easier way and then validate our data. So the primary reason for us using the Mongoose instead of MongoDB code driver was for utilizing the models and schema that Mongoose provides to us.
So let's try to understand what models and schemas are and how a typical database works. So using this Google Sheet, we'll try to understand what models and schema actually are. So let's suppose this to be a database of an school. A database of an school can hold different records like records of students, right? Record of books and different other things. So if you look into the student table, you can see that there are certain keys that will have a property of a certain student, right? So if you go into the books, you can see that there is a certain book, and then these are the keys that represent, or these are the properties of that book. So every collection or every table has a key properties or the headers inside of them. So in Mongoose, the collection is said to be an model. So this is an student model. This is an books model. And the keys you see over here inside of the model are the schemas. Schema will define what type of data is allowed in this column. For instance, in Age, I will not be able to write ABC if it was for Mongoose, because it will not allow strings where the numbers are only accepted.
So to make you better understand, I have replicated the database system of MoviesDB dummy API that we tested in our previous lessons. So if you look into the Postman and the response of the get all movies in our MoviesDB dummy API, by the way, you do not need to start the server and see the response, just see here. You can see that in the data of movies, there is an object, movie object, and inside the movie object, there are some key and value pair. And in every movie object, you will see similar kind of key and value pair. The keys are ID, movie name, info, and rating. Now, if I have to present this visually, this is what it looks like. So if you look into the movies DB, the movies database or movies DB is the complete database system. The movies list is the collection of movies, which can also be said as the movies list model in our Mongoose term. And the headers you see over here, which will hold the value of the movie, are the schemas, right? And this is the movie data. So in our next lesson, we'll be trying to create the movies list model and then the schema inside of it. So I'll see you at the next lesson. So now that we have a basic understanding of what models and schemas are, let's create one for our movies API. So now instead of writing the model code in our app.js file, our goal is to minimize app.js code as much as possible, because it will be easier for us to maintain and to read our own codes, right? So instead of writing the model codes here, let's create a new folder, name it as models, and all of our models will be inside this folder. Now inside of models, let's create a file and name it as movies.model.js. Now reason for using this model in our JS file is because it will be easier for us to search for models. Now in Visual Studio Code, you can search for the file directly by pressing Command and P. Now if I type model here, I can see all the models related files over here. So it will be easier for me to navigate. So I am naming it as movies.model.js instead of just movies.js. Now inside of this file, let's create a model. For that, we need to import Mongoose in this file. So const Mongoose is require Mongoose, right? Now after this, we'll be creating a model over here. So the code for creating a model is const movies model equals to Mongoose dot model, and the first parameter will be the name of that model. So in case of naming this model, I generally use lowercase to avoid the case sensitive issues in the future. So I also recommend you use the lowercase while creating the model. So we'll name the model as movies, and then in our second parameter we will have an schema of the movie. So let's write it as movies schema, and now we should be creating this movies schema. So const movies schema equals new mongoose dot schema. So inside of this schema object, we will be creating these headers, right? So we do not need to create this ID header because it is automatically generated by Mongoose. In most of the databases, this ID is a unique field that is automatically created by the database. So we do not need to create this, and we will start by creating a movie name. So inside of it, you need to write movie name, underscore name, and the properties will be inside of this curly braces. So the type of movie name is the string. As you can see, the movie name is of type string. Now the second field that we need to add is the info field. So let's go ahead and create an info field, comma, and then info. Info is also of type string, and then one last remaining is the rating, and the rating is of type number, right? Now by doing so, you can save this file, and for this file to be accessed in other part of our code, we need to export it. So module.exports, and then movies model, and by exporting this model, we will be able to use this model in our other files as well. Now before importing it and using our model, let's have a look at our MongoDB Compass, where we had connected to our testing database previously. So if you navigated into the database tab, you can see that there are these predefined databases, and there is no database of our own. So we need to first create a database. And while using Mongoose, we will not be creating database from here. Instead, we will be creating the database using our own code. So for creating the database using our code, navigate into .env file where we had saved the connection string previously, and before this query parameters, type your database name over here. So let my database name be moviesdb, and save this file. Now if your server is already started, close the server and start the server again. But if your server is not started, you can go ahead and start the server. Now after the connection is successful to MongoDB, you can have a look at your MongoDB Compass and refresh it, but you will still not see the database over here. The reason is because we have not initialized any models or collection inside of it. So if you do not have any collection inside the database, the MongoDB Compass will not be able to display your database. So let's initialize our movies model. So for initializing the movie model, go into your app.js file, and right after the MongoDB connection or anywhere below this MongoDB connection, type or import this movies model over here. So require, and then working directory models, and then movies.model.js or movies.model. So after making the change, save this, and after the server is restarted and MongoDB connected successfully, you navigate into MongoDB Compass and refresh. So now you can see that your database is created named moviesdb. So this moviesdb is created by the name that we used over here, and inside of our database there will be a movies model, and the name that we have selected over here is the name that we have created in this. Now this movies, in terms of Mongoose, it is a model, but in terms of MongoDB and MongoDB Compass, it is a collection. So models and collections can be said as the same thing and can be used interchangeably. Now if you navigate inside of these movies, there is no data available because we have not added any. Now it's time for us to work on our add movie route. So I'll see you at the next lesson where we will be adding a movie data in our database. So I'll see you there. Now after creating models and schema and then initializing it, we are now ready to work on our add movie route. But before that, let me comment models over here so that it will be easier for us to read, and then the model will be inside of this comment, and then the routes will be inside of this comments, making it easier for us to read. Now let's work on add movie route. Now easier way to navigate to add movie route or any file that have been imported, you can simply press ctrl and then click over here to land in this file. So if you see in this route, we can see that there is a code which returns this is an add a movie route in JSON format. So let's go in our postman and send this request again, right? Also rename this request as add a movie. So let's go ahead and send a payload data to our server. For that, navigate into the body, raw, and then we'll be sending this JSON file. So write your JSON over here. Now for now we'll only be sending movie underscore name, right? And then movie name is the best offer. And let's see if our server can read the request that is being sent from here. Now if I click at send, it's still responding with this is an add movie route. So let's change that. Let's read the user request. Now in this code we are not reading the user request, and every user request will be available in this request parameter. So let's go ahead and console that. So console.log, and then the request parameter, we will be seeing all the requests that our clients are sending. So after this, after the server is started, navigate into the postman and send the request again. Now you can still see this is an add movie route because this is the response we are sending. But if you navigate into the VS Code, in the console, you can see that we are currently reading the request that is being sent from our client. So there are a lot of request data over here and most of them are irrelevant to us. The only thing relevant to us for now is if you navigate into the Postman, we have sent a request from body. So we will be able to access this JSON if we could console.log the request body. So after making the changes from request to request.body, we will be able to access the request body of our request. So once the server has started, go into your Postman and send the request again. Now if you see your console, you can see that we are getting an undefined data. This is because Express by default does not accept the JSON data. So for us to be able to access the JSON data, navigate into app.js and right after where the app we have declared app as an Express app, you must write app.use and then express.json. By doing so, we are instructing the Express to accept the JSON payloads as well. So after that, after the server is restarted successfully, go into your Postman and send the request again. So you will be able to see the movie name and the key and value pair as in JSON. So you can see that we have received movie name and the movie value over here. So this is how you work with user request. So now that we are able to access the data that is being sent by the client, it's now time to take that data and insert into our database. Now if you look into the previous request that we have saved in the Postman of movies dummy API, in the add movie route you can see that we have sent 3 variables on this. The movie name, info and rating. So let's copy these variables and paste it in our new API. So instead of typing each and every code, we are just pasting it over here. So this time we are sending movie name, info and rating. So let's send that and see what data will be retrieving in our console. So you can see that we have retrieved every data that was sent from the payload. Now instead of reading all the data and validating all the data, we will only be validating data that will be relevant to us. For instance, from Postman payload, if I send the data that is not relevant to us, let's say the description. For now, we will not be needing a description, right? So let the description be XYZ. And then if I send this, you can see that we have also got the data of description, but we only need these 3 variables. So how can we accept and validate only the required variables is we need to use the destructuring method. So const starting the curly braces, we can destructure the object that is being received as a payload. So we will be needing movie underscore name comma info and rating from request.body. So what this destructuring did is it created 3 variables named movie name, info and rating and then assigned the value of this payload into their respective variables. So if we send in this status, we are only sending this is an add movie route. Instead we can send movie underscore name, let it be movie underscore name for now, and info we will be sending the info and then in the rating we will be sending the rating. So let's save that and see the response in our Postman. So if I click at send, we can see that we are able to read the payload data from our response. So everything is working fine and our destructuring is also working. By destructuring, we are removing any variable that is not relevant to us. Or instead of removing, you can say that we are ignoring the variables that are not relevant to us or to our code. So now that we have 3 variables that are relevant to us, let's write some validation code. So let's remove the console.log for now and let's remove this as well from our response, and in the status we will be writing success because this is successful. If nothing happens, no error occurs, then it is successful, and in message we will be writing movie added successfully. So the reason for us to write movie added successfully at the end of this code is because all the validations will be checked above this code. Let me write validations over here. So we will check all the validations in this part of the code, and if everything is okay and there is no error in the request or in creating process, then only the client will be able to see this response. And if any error occurs in the validation process or while saving the data to the database, we will send another response and we will be returning our code so that client does not reach at this part of the code. So we can say that this part of the code is a success part of our code. So in throughout of this course we'll be writing our success message at the end, so that if everything goes right, then the client will be able to see the success message, and if anything goes wrong, we will handle the error here and send the respective error message accordingly. So in the next lesson, we will learn about the validations and how we can validate the incoming request of our clients. So I'll see you at the next lesson. In this lesson, we will be learning about validations of our client request. It is not necessary that client request is always valid. Sometimes we need to perform some validations. For instance, if the client does not provide the movie name, then we cannot add an empty movie into our database. So validation is needed. So let's write some validations. So in validation section, what we will write is, if the client does not provide movie name, if movie name is undefined or there is no movie name in the payload, then what we will do is we will be sending a error status code. So response.status, if everything is okay, we will be sending 200 status code, and if something is not fine, we will be sending 400 status code. 400 status code means bad request. To learn more about the status code, you can search for HTTP status code in your search engine and you can have a look at the status codes. So if you search for HTTP status code and click on the first link, then you can see that there are different status code, and one relevant to us is 200 OK, which is if everything is fine, then we can send 200 OK, and if something is wrong, we can send other error status code, but for now we will be sending 400 bad request. You can have a look at different status code and send the relevant status code accordingly. But for now we will be sending response.status 400, and in JSON we will be sending status failed, and the message for the failure is movie name must be provided. So if the request does not have movie name on it, then we will be sending the response of 400 bad request, and the message will be movie name is not provided or must be provided. So if the request does not have movie name, then the validation fails, and instead of providing the response of movie added successfully, we will be providing the response of 400 status code, and we will say movie name must be provided. Now what we need to do is we need to return this block of code. By returning this block of code, we are making sure that after this response, the code will not go any further into this line. Now if you do not return this block of the code, let me remove this for now and let me restart the server and show you the issue if you do not return the code. So let's start our server. Now in Postman, if I send the request without the movie name, then you can see that a movie name must be provided and the request has failed. Everything is working fine, but if you see at the console, our app has crashed. Our app has crashed because there is an error. An error says that HTTP headers already sent. So in Express or in any other HTTP platform, we cannot send response twice. So by removing the return from our code block, what we are doing is we are sending this response of error, and then again we are trying to send this response, which is not a valid thing, because once the response is already sent to the client side, we cannot send another response, or we cannot send multiple response at once. So what we need to do is we need to return this block of code so that another status code or another response does not get triggered, and the client will not be able to reach this part of the code and they will return from here itself. So after the server has restarted, let's go in the Postman and send the request again, and you can see movie name must be provided, and if you see at the console, our app has not crashed. In this way we can validate the request of our client. For now we are checking for movie name. Let's check for the info and rating as well. Now if the payload does not have info in it, then we will be saying info must be provided, and if the client does not have rating on it, then we will be writing rating must be provided, right? Now if we save this and if we look into our Postman and send a request over here, without the movie name, we can see that movie name must be provided. Now let's write movie name over here, the best offer. And then if I try to send a response, send a request, it says movie added successfully because validation, all the validations are working successfully. There is no errors. And if I try to remove this info, key and value pair from here, and if I try to send the response, send the request, it says that info must be provided. So all our validations are working fine. Now if I try to send the request in which the JSON is not formatted in a correct way, you can see that there is a red mark, meaning that the JSON is not correct because we are not providing comma over here, and in Postman there is a strict checking of JSON. So if I do not provide comma, then the Express will throw error. It says that the JSON is not formatted or unexpected string at JSON and some error related to JSON. So make sure while sending the payload, you make sure that the JSON is correct and there is no red marking over in the JSON payload data. So if you send this, you can see that movie added successfully because everything is working fine. You can also check other validations over here, like in the rating, rating must be between 0 to 100. Then what you can do is you can again copy this block of code and then write if rating thing is less than 1 and or rating is more than 10, then what we need to throw our response error is rating must be between 1 to 10. So now if user tries to manipulate the request or if user want to send the request in which the rating is 100, then they will get the error of rating must be between 1 to 100. So in this way, what you can do is you can validate the user request, and only if the validation is successful, then the user will be able to see movie added successfully. Now if you see at this code, it is a very long code and it is not a good approach to repeat our code every time. So in the next lesson, we will see how we can handle the code, this type of validation code effectively using a try-catch block. So I'll see you there. So if you look into our code carefully, you can see that we have repeated same line of code for multiple times. Only difference between them is the message, right? So it goes against our philosophy of DRY, don't repeat yourself. So instead of writing and repeating same code over and over, we should find a way in which we can minimize our code and handle the error from one block of code for everything. So we can use try-catch block for effectively handling the errors. So let's see how it's done. Now instead of providing an error response in this way and returning every time in each block of code, what we will do is we will trigger an exception using a throw statement. A throw in JavaScript is a statement which will trigger an error or an exception. So not having a movie data in the payload is an error. So what we can do is we can throw an exception using a throw statement. So we can write here movie name is required. So what we are doing over here is we are throwing an exception or an error that says a movie name is required. Now if we use a throw statement, then the code below it will not execute. The function will exit from here itself. So we do not have to use return statement as well. So let's save this code and try to send a request from our Postman. Now if I send a request from Postman by doing everything right, and if I send the request, then the rating must be between 10. We should make this rating 9 for now. And then if everything is okay, movie added successfully. But if we remove the movie name, then the exception should be triggered. So if I click at send, then there is an exception. But this exception is not handled well. This exception is handled by Express. Now most of the time, Express handles the expression so that our server will not crash. But in rare scenarios, our server might crash if we do not handle this throw statement. So a way to handle a throw statement is to wrap this throw block or the throw statement by try-catch block. So by using the try-catch block, what we can do is if any error occurs inside of this try block, the error will be passed down to this catch block, and in the catch block we can gracefully handle the error. So try catch block will help us gracefully handle the JavaScript error and other errors as well. So what we can do is we can cut this code and we can paste it inside the try block. So if error is thrown from here, then this catch will catch all the exceptions, and inside of this catch block what we can do is we can gracefully handle the error. Now to gracefully handle the error, what we can do is we can copy this block of code and then paste it over here. So if any error occurs inside of this try block, the exception will be thrown and caught by this catch block, and this exception, the e variable over here, will hold the message that is written in the throw. So we will replace this info must be provided by e or the exception. So let's save this. So let's go to our postman and then send this same request. So you can see that the request is failed and the movie name is required. Response is now thrown by gracefully handling exception that was triggered from here. Now what we can do is, instead of writing in these two lines, what we can do is we can remove the curly braces and write this throw in the same line. Now instead of throwing this response error message every time and returning every time, what we can do is we can check all these exceptions inside of this try catch block. So instead of doing this, what we can do is, if info is not provided, then we can throw the exception of info must be provided. Now let's do for another one as well. And if rating is not provided, we can throw the exception of rating is not provided, right? And in the next exception, where rating must be between 1 to 10, let's copy this, and inside of this what we can do is we can throw an exception, rating must be between 1 to 10. Now we can remove all of this code, and all of this code is now handled by a single try catch block, which will accept the exception. We will get an exception that is thrown inside of the try block and gracefully handle and return the response of failed status. So using the try catch block will help us minimize the code that needs to be done for handling the errors and exceptions, and will make our code more readable and more reliable. So I'll see you in the next lesson, where we will be learning more and diving deeper into the code of Node.js. So I'll see you there. Now, before we interact with the database or perform operations inside of database, we need to first understand what code execution methods are. What is asynchronous and synchronous method of code execution? What are promises, and what are async and await statements? So let's get started. There are two types of code execution methods: synchronous code execution and asynchronous code execution. So JavaScript uses asynchronous way of executing the code. So let's try to understand what synchronous and asynchronous are with an example. Now this is a very basic code of JavaScript. At the first block of code, we are assigning the values to the variable, and in second part of the code, we are adding those variables and storing the results in a results variable, and in the third part of code, we are logging in the results so as to see the addition of these two variables. Now in this block of code, there is no any code that might delay the execution process of this code block. So everything will execute instantly in this scenario. And synchronous and asynchronous code will handle this code execution in a similar way, because there is nothing to block this code execution. Now let's have a look at a block of code in which the code execution might delay. So in this code, you can see there is a function called getData, and inside of it there are three code blocks. The first block of code is only logging in the hello world. However, the second code block is getting something from the internet. Now this second block of code is trying to send a request to the internet or external API, and then it is trying to store the response results in the variable called results. Now if you have a look at the third block of code, it is trying to display the results that was brought from the internet by code 2. So it is not always necessary that this code 2 will bring the results from the internet instantly. There may be some delay in the execution process, right? The delay might be because of slow internet connection, or there may be an issue with an external API, or due to other factors. So let's see the asynchronous and synchronous way of executing this code. In synchronous method of code execution, every block of code runs in sync. If we try to execute this block of code in synchronous way, let's see what happens. At first, the hello world will be logged. And when the code reaches here, the code will try to get an API response from the external API, or try to communicate with the database for doing some operations. And without this code being completed, the code 3 will not start. It will wait for the code 2 to complete or to throw an error, and after the code 2 has failed or succeeded, then only code 3 will run, because every code is running in sync. The asynchronous code execution is different from the synchronous code execution. In asynchronous code, there is no blocking code. None of the code will wait for another code to execute or to throw the response or error. In this case, if you try to execute the same block of code in an asynchronous way, what happens is at first the hello log will be logged, and then this code will run. The code will be trying to get the response from the internet, and while the code 2 is trying to get the data from the internet or data from the database, code 3 will be executed at the same time. So in this asynchronous code execution, none of the code wait for another code to execute or to perform successfully or throw an error. There is no blocking in the code, and JavaScript code is an asynchronous code. So using a non-blocking architecture, asynchronous code is super fast because none of the code will block the execution of another code. But in some cases, it can be a problem. So let's see how. So if I try to execute this block of code in JavaScript, I will not be getting the desirable results. This is because code 3 will not wait for code 2 to complete, because code are executed in an asynchronous way in JavaScript and it does not wait for any delays in the code. Now, if you try to run this same block of code in a synchronous way, you will be getting the desirable results, because in synchronous way, this code 3 will wait for code 2 to execute. Code 3 will wait for the execution of code 2 and only execute when the response is provided from code 2 or there is an error in the code 2 execution. And this is what we expect from our code. Without waiting for code 2, if the code 3 is executed, we will not be getting the desirable results, or we will not be getting the response data from the internet or the database. So in this type of scenario, synchronous code execution wins over asynchronous code execution. So if we try to get the desirable response in this console using an asynchronous method, we need to use a promise or async and await. Using promise or async and await, we can wait for the code execution same as in the synchronous code execution method and get the desirable results. And by introducing async and await into our JavaScript code, we can execute certain parts of our code in a synchronous way. So you can say that async await is a way for us to convert the asynchronous code execution type to asynchronous code execution, but only at certain parts of our code, so that our other parts of the code are performant and working on a non-blocking architecture, and where we need the synchronous code execution type, we can achieve that using async and await. So let's see how it's done. So now we'll try to execute this code in a synchronous way but in JavaScript. So for doing that, what we need to do is we need to use async await in our function. So if you want to wait for the code execution or delayed execution, then you need to create an asynchronous function, or you need to convert your function into an asynchronous function. And by using the asynchronous function instead of regular function, you will be able to access the await statement. This await statement will make sure that without completion of this code block where the await is used, the code block below it will not execute. And this whole method is called promise because code 3 promises to code 2 that it will wait for the execution. So the name promise. And it was important for us to understand async and await before proceeding into our course, because database connection or operating data or accessing the data from the database will also make some execution delays. So to handle that, we will be needing an asynchronous function, and inside of it we will write our await statement and then perform the database operations. So I'll see you at the next lesson where we will be trying to add data to the database and we will create our first data in the database. So I'll see you there. So now that we have an idea of what promises are, what async and await are, and how they work, we are ready to create our first record in the database. Now it was important for us to understand the concept of async and await before we could interact with the database, because while interacting with the database, there is some code execution delay. So now that we have an idea of how execution delay can be handled in our code, we are ready to interact with the database and create our first record. So we will be using the add movie route to add a movie to our database. So start up your Postman, start up your MongoDB Compass,
And let's start writing some codes. So let me start the server first. So after the server has started, navigate into add movie route, and from this route we will be adding a movie data into our database. So if I need to interact with database from this file, I need to first import mongoose into our code. So const mongoose is require mongoose. Now to add a data to our movies model, we will be needing to import the movies model as well. But as we have already initialized our movies model in the app.js file, we do not need to import movies model every time into our code. Instead, what we can do is we can create a variable over here. So const movies is the mongoose model of movies. So you need to make sure that the model name that you have written here should match with the actual model name. So now inside of add movie.js, we have an SS2 movies model. Now we can use this to create a record in this model. So to avoid confusion, let's rename this movies as movies model, which is of course the movies mongoose model of movies. So we'll use this variable and then create a record in that model. So right above the movie added successfully, we'll be writing movies model dot create. Create is a function that will help us add data or add new record to that model. So the data we will be sending for writing into our database are the data that we have received from the request movie name, info, and rating. So we'll be sending movie underscore name, which is the movie name that we have got from requested body, and the info is the info that we have got from requested body as well, and the rating. Now from our previous lesson, what we have learned is if you are trying to interact with the database, the interaction can have some delay in the execution. So to handle the delay in the execution, what we need to do is we need to use the await statement. And for us to use the await statement, the function that we are using await statement should be an asynchronous function. So let's add async over here. Now by using async, we will be able to use the await statement. Now by doing this, what we are assuring is without executing this function or without getting the response from this function, this response will not be returned. So let's go ahead in the postman and try to send the request of creating a movie. So everything is fine in our payload. Let's click at send. Now after the movie is added successfully, you can navigate into your MongoDB compass, and then if you click at refresh or find, you can see that the new record is created in our database in our movies model. So congratulations for creating the first data in your database. Now if you want to see the recently created data from this code, what you can do is you can assign a variable to this function. So const created movie is the movies model.create function. Now this function will return the recent data that is created in that model. So created, let's console and see this created movie data. So console.log created movie. Now let's send this request from postman and we will be able to see the created movie data in our console. So navigate into the postman, payload seems fine, click at send. And in console, you can see that the recently created movie is being displayed in our console. Now, if you refresh your MongoDB compass, you can see that there are two records created. Now, movie name, info, and rating are the variable that we sent while creating this record. And this ID variable is auto created by the database. And it is always unique throughout this movies model. Now, if you want to manipulate data in your MongoDB compass, you can click at this edit button and then you can make changes directly from here, right? And it says document is modified, and if you click at update, the database data record is updated directly in the MongoDB compass or directly in our database. Also, you can use this delete icon to delete this record. For now, there are two the best offer movies, so let's delete one. Now there is one very important thing that you need to understand while working with async await statements. That is, you need to always wrap your await statement with try catch block. The reason we do this is because this statement of creating the data or any statement that has an await in it might throw some error or throw some exceptions. The exception may be triggered due to the connection error,
or the creation validation error, or by many different factors. But if we do not handle those errors in an effective way or in a graceful way, our server might crash. So to prevent that, what we need to do is we need to wrap await statement with try catch block and then handle the error gracefully. So let's wrap our code, this creation code, with try catch block as well. So try to perform this creation code, and if something goes wrong, we'll be handling the exception inside of this catch block. So inside of this catch block, I'll be copying this error validation error code, and then I'll paste it over here. And instead of throwing this exception from here, what I want to do is I want to return a static message that says our validation error will already provide the customized message, but if the error is in our mongoose, or if the error is in the creation process, what I want to write is movie creation failed, something went wrong. Now by doing this, we are gracefully handling the error and preventing our server from crashing. Now let's try adding some movies from our postman. So the movie I'll be adding this time is the Hangover movie. I've modified the response for the Hangover movie, and let me send the request. If I click at send, our server has crashed. But if you see into our MongoDB compass and refresh the page, you can see that the Hangover movie has been created, but our server is crashed. So let's debug why the server has crashed. So the server has said that created movie is not defined. So another thing that you need to keep in mind while using the try catch block is if you are initializing any variable inside of the try block, this variable will not be accessible outside of the try catch block. So what you need to do is you need to cut this code and paste it inside of the try block. Now our code will run successfully without throwing any errors. So let me add one more movie into our database. So this time I'll be sending the payload of perfume movie. So let's send this and see the response. So movie added successfully. Now if I navigate into the MongoDB compass and refresh the page, I can see that the perfume has been added and our server is also working fine, and our server this time has responded with the newly created movie. In this lesson, we'll be learning about the schema validations. It is important for us to learn about the schema validations because it affects the way we create and update our data in the database. So I want you to navigate into the add movie route. Now as you can see, we are taking three request variables from the payload, right? The movie name, info, and rating, right? And if you look into the postman, we have been sending this description value from a very long time while we are creating a data in the database. But this description value is not being displayed in our records. The primary reason for it is we are ignoring the description from our payload, and we are also not providing the description key value pair while creating and record in the database. So it is obvious that it will not be displayed, but let's go ahead and provide a description in our data as well. So I'll be writing a description, and now that I have access of description, I'll be sending that in our create object. So description is the description. Let me save this, and we'll be sending a request from postman to see if we can create a new movie data with the description field. So let's go ahead in the postman and let me modify this request. I've written stored little over here, and now I'm making sure that there is a description key and value pair over here, and I'm clicking at send request. As you can see, movie is added successfully. Now if I refresh my MongoDB compass, you can see that a movie is created with the name Stuart Little, information, rating, but there is no description. And the reason for missing description is that this description field is not available in the movie's model schema. Now we are pretty sure that we have sent a description in the create object, but due to the missing schema object or missing schema definition of the description is not added to our database. Now if you want the description to be displayed, you need to create that object in your schema. So description, and the description type is the string, right? Now let's save this model and send the request over again. So navigate into the postman, and with the same payload, let's send a request. So movie is added successfully. Now if I refresh this page and if you navigate down, you can see that there is a description. Now this is rule number 1 of schema validation, or how the schema in Mongoose work. If you do not define the field in the schema, then that field will be ignored entirely. Now that was the first rule. The second rule of the schema of Mongoose is that if I remove any object or any field from our schema, it will not affect the database or the data that is already stored in our database. And this change in the schema will only affect the new data that will be created after the schema has been changed. Now using this updated schema, let's send a request from Postman using the same payload. If I click at send, you can see that the movie is added successfully. If I refresh our database, you can see that at the end, the rating field is missing. This is because the newly created data has respected the updated schema. Now there is an advantage to it. If you accidentally remove or accidentally rename the field in the schema, it will not affect the existing data. Now imagine this, that you have hundreds and thousands or millions of data in your movies model. Now if you accidentally remove any schema field or accidentally rename the schema field, and if it updated the data or removed that field from our database, then it will be a problem, right? But in Mongoose it is not the case. The updated schema will not affect the previous record. It will only affect the upcoming data. Now these are the things that you need to understand while working with Mongoose. Now the other thing that you need to understand is we can apply validation inside of the model itself. For instance, if you want this movie name to be a required field while creating a data in the movies model, what you can do is you can simply write required true. And by doing this, we are directly validating our data from the schema itself. Now if I try to send the data to the server without the movie name, the result I'll be getting is movie name is required. Now this exception is thrown by our general validation that we have written here. Let's comment this out as well. So we are not validating that the movie name should be a required field, but instead we are writing this validation in the model itself. Now let's try sending the request again. So if I click at send, you can see that the movie creation failed, something went wrong. Now this exception is triggered by Mongoose itself from this part of the code. We have already removed the general validation from here, but the validation is now done by the model. And when we are trying to create a data without the movie name, the validation of the schema is failing. Thus Mongoose is throwing an exception, and we are catching that exception and handling it in a graceful way. Now to see an error message, a detailed error message, what you can do is you can remove this message from here and type e.message. Now save this and try to send the request again from the Postman. So you can see that a little bit of formatted message is shown, but it shows the actual error. It says that path movie name is required. Now if you want a custom message to be displayed here, what you can do is you can navigate into your schema, and then instead of writing required true, you need to create an array, and the first parameter will be the true, or first data will be the true, and the second data of an array will be the error that needs to be thrown while the validation fails. So movie name is required. So if I save this and if I restart the server and send the request again, you can see that there is an error, movie name is required. And this is how schema validation works. Now there are other validations as well. We will be learning that in the upcoming part of this course. So now that we have understood how schema validation work and how we can create a data in the database, and we do have enough data in the database, we can proceed to creating another route of getting the movies. So I'll see you at the next lesson. In this lesson, we'll be learning about update operations on Mongoose. We'll be learning how we can modify the data that is already stored in the database. And for that, we'll be using the edit movie route. So let's go ahead and create that route. So inside of controllers, new file. And our file name will be editmovie.js, and inside of it an arrow function edit movie, and module.exports equals to edit movie. Now we will be using the database operations, so why not change our regular function to async function. And the parameters we will be getting is request and response, Now let's save this code and navigate into app.js, and let's create a route for this as well. For updating the data or making changes in the database, we generally use patch request. So app.patch, and if someone sends a request with patch method into API/movies, then our edit movie will handle the request. So we have also imported the edit movie over here. So let's save this and let's try to send a request from our postman. And before that, let's modify our edit movie so we send some response to the postman. So rest.status 200, and JSON will be sending status hello from update route. Now let's navigate into the postman and let's send a request. So navigate into the postman, and you can duplicate this add a movie route. So let's duplicate it and rename it as edit movie, and then the post request method will be changed to patch request, and the API is the same. If someone send and request to API/movies in a patch method, then our patch movie will handle the request. And inside of a body, let's remove this first, and let's send a request to see if we are getting the desired response. So we have not started the server, sorry for that. So npm start. So after the server is started, into the postman again, and let's send the request. So our route seems to be working fine and we are getting the desired response. So let's modify the route for now. So we will be using the database operations. So const mongoose is require mongoose, and inside of this function we will be initializing our model. So const movies model is mongoose.model of movies. Now if you look into the postman and navigate to edit a movie route of dummy movies API, you can see that we are sending a JSON payload in our request, and inside of JSON payload you can see that there is a movie ID. Now the reason for sending the movie ID and why it is mandatory is that if a client is trying to make a change in a certain movie, we should be able to, or our API should be able to detect that specific data, right, in the database. Now if you have a look into our database, you can see that there are a lot of movies in our database. Now if you see the data of the movies, let's compare two movies for now. You can see almost everything is similar in these two data, but the only difference is the ID. Now in a model, this ID does not repeat and it is always unique. So it is the best way to detect the data that the user is trying to edit through an ID variable. All other things can be changed, but this ID cannot be changed. So we are detecting the request or ID of the movie from the request, and we will update the data accordingly. So let's set up that in our route. Now let's go ahead in our route and then destructure the data that we will be needing. So const, let's start the destructuring from request.body, right? And the things that we need, or the variable that we need for making the changes, one mandatory is movie underscore ID that we will be sending from payload, and other variables are, let's see, our model. So what are the things that we want user to change? One is the movie name, info, and description. Also we might have forgot to write rating over here, so let's write rating as well. So our rating will be of type number and it is capital numbers. Now let's select some of the data that we will allow our user to make changes to. So the movie name, info, rating, description. So we want everything. So movie underscore name, rating, info, and description. Now once we have that, we will be running update one query to update data in our model. So movies model dot update one, and by using update one function, we are instructing mongoose to make changes to only one data in our model. So the update one will hold three objects inside of it. The first object will be the condition to find that specific data. Second will be the key value pair for updating the data, and third will be the configuration, right? Now in the first parameter or the first object, we will be trying to find the data that user is trying to edit. So for editing the data, user will be sending the movie ID, but in our movies model, our ID is underscore ID. So we'll be assigning movie ID with the ID. So underscore ID is the movie underscore ID that user has provided. Now in the second parameter inside of this object, we'll be writing the actual data that needs to be updated. So if a user is trying to update the movie name, then we'll be writing movie underscore name is the movie name that is received from the payload. And in the last parameter, we will be writing run validators to be true. Now, if you do not run validators, then this required validation will not work. So always make sure to use run validators true when you are trying to update the data in the database. Also, we are trying to interact with the database, so this should be an await statement, and by using await statement we should be wrapping it with try catch as well. So try performing this action, and if it fails, then catch the exception, and then inside of it res.status 400.json, and inside of JSON we will have status failed, and the message is e.message, right? And then we also need to return this, otherwise request headers will be sent twice, response header will be sent twice. So let's save this and let's try to update data in our database. So navigate into the postman, find the edit movie route, and inside of it we will be sending the payload data. So our first parameter will be the movie underscore ID. So movie ID is the ID that we will be getting from the database, or that is stored in the database. So let's query get all movies, and this time we'll be trying to make an edit to the best offer. So let's copy this, and inside of edit a movie we will be pasting this in our movie ID, right? Now the second parameter that we will be sending is the movie name that we are trying to edit. So movie underscore name is inside, instead of the best offer we will be writing the good offer. So the good offer. So if I send a request, you can see hello from the update route. Now let's modify this as well, but the data is already modified. So if you go into the get all movies and send a request, you can see that the best offer has been changed to the good offer, but our response is not correct. We are only writing hello from the update route, but instead of this what you'll be writing is you'll be writing success, and then message is movie updated successfully, right? So let's save this and let's send the request again. So inside of get all movies, inside of edit movies, let's send the request. So movie updated successfully. Now let me write the good offer too, and inside of get all movies there is a good offer too. Now if I try to send the empty data in the movie name, then let's see what happens. So validation failed, movie name is required. So by using the run validators true, we are validating our updated data from our model. If I did not provide this, let me comment this down, if I did not provide this run validators true, and if I try to send a request, it says movie updated successfully, and movie will be updated successfully without the movie name. Now this is not what we want, so we will be sending run validators true always, so that validations of our model works fine. Now let's see what happens when I try to update multiple fields. So will this request be able to accept the rating as well for updating the data? So what first, now if I see into the get all movies, I can see that there is an empty movie name. So let's fix that. So instead of empty movie name, let's modify it to the best offer. Let's send the request, and our data is showing the best offer over here. Now if I try to update the rating from the same request, will it work? So let me set the rating to 5 and send the request. So it's saying that the movie updated is successfully, but if I navigate into the get all movies and send a request, I can still see the rating to be 9. So our rating is not being updated. Now the reason for it to not update is we are not providing the updated rating in this object. So for fixing that, let's send the rating as well. So rating will be the rating. The info, also other variables, let's send other variables as well. So info will be the info, and description will be the description. So by doing this, we are updating all the variables. We are allowing user to update all the variables. So let's go ahead and try to modify the rating. So if I send 5, then the movie updated successfully. Let's query, and the rating is 5. Now I can use multiple data for updating my multiple fields or multiple payload data for updating my data. So info is this is best, and inside of description I'll be sending good job. Now let me send this request, and the movie is updated successfully. So let's see the response, and you can see that the movie is updated and we have got a new field over here, and this field is available here because the new schema has a definition for the description. And if there is a definition of the field in the schema and that field does not exist in the data, and if you try to update it, Mongoose will automatically add the updated data over here like this. Now what if I send a request from the postman without the movie ID? So in the patch request, let me remove this movie ID and let me send a request. Now it says movie updated successfully, but it was not able to find any document, so none of the document or none of the data in our model was changed, because our code or our Mongoose code could not find the specified ID. So what we need to do is we need to reject this kind of request. So let's run our general validators at the above of this try catch block. So if movie ID is not provided, throw by saying that movie ID is required. And by throwing this, we are throwing in JavaScript exception. So let's try wrap it with try catch block. So try doing this and handle the exception in a graceful way. Let me copy this from here. Also, don't forget to return the statement, otherwise you will have an error. So failed, and our exception will be the E. So save this, and if you navigate into the postman again, and if you try to send a request without the movie ID, it says movie ID is required. So this is how you make a change to the data in the database. So in next lesson, we'll be learning how we can remove the data entirely from our database. So I'll see you there. So in this lesson, we'll be learning about how you can delete a data from the database using the delete query. For that, let's create a controller first. So new file, delete movie.js, and inside of it const delete movie. And module.exports delete movie. Also, we will be using the database operations, so this will be an async function, and we will be getting request and response as well. So let's create a route inside of app.js for delete operations. So if someone sends a delete method, app.delete method to /API/movies, then we will be executing the delete movie controller. Now in order to execute the delete operation, we must first find the movie data that user is trying to delete. Now in case of this patch request, we are obtaining the movie ID from the request.body payload, right? But in case of delete method, we do not have access to request.body, or delete method does not allow the body parameters to be sent in the request. So for getting the movie that we want to delete, we will be using the params like we did for get single movie. So movies / the dynamic ID movie_ID. Now we will be able to access this in delete movie route using the request.params. So navigate into the delete movie, and inside of this, let's write response.send or response.status 200.json status success for now, and then message movie deleted successfully. Now movie will not be deleted for now, as we have not run any query, but for now let's read the params. So console.log request.params, and let's see if we are getting the movie ID. So navigate into the postman, duplicate this path request or any request that you want, change the method to delete and remove the body, as we do not have access to this body in delete request. And then after movies, the dynamic ID. Now in this case, we will be trying to delete the end movie, this Stuart Little that is at the end. So let's copy this and let's rename this as well, delete movie, and then we will be sending this over here. And now let's send the request, and movie deleted successfully. Now if you see at the console, you can get the dynamic ID over here through request.params. So inside of request.params is an object, and inside the object there is a movie ID. So const movie underscore ID equals to request.params.movie underscore ID, right? So let's remove this. And for deleting the data from database, we should be using the delete function. But before that, let's import mongoose. So const mongoose is require mongoose, and we'll be interacting with the schema model. So let's import model as well. So const movies model is mongoose.model, and inside of it we'll be writing movies, right? Now that we have an access to the model, we can use this model to execute a function of movies model that delete one. Now if we use delete many, then we can also delete the multiple instances, but for now we are trying to delete a single movie, so delete one. And inside of this delete one, we'll have an object, and this object will hold the condition for finding that ID. So underscore ID is the movie underscore ID, and also use the await statement, as we already have async here, and then wrap this with try catch as well. It will not, in most of the cases, it will not throw any exception errors, but staying on the safe side, let's do that as well. So try catch an exception, and inside of it res.status 400.json status failed, and then message is e.message, right? Now let's try to delete a movie. So navigate into the postman and send this request again. So we're trying to delete the movie with 61D ID at the end. So get all movies, and this is the 61D ID, which is at the end, of course. Now let's query the get all movies. So you can see that our movie has been deleted. Let's try to delete this best offer as well. So copy this, go into the delete movie route, paste it over here and send. If you go into the get all movies, you can see that the best offer is also removed, and it is removed from here as well. So instead of 6, we will have 4 data. So now what happens if you provide an invalid ID here that does not exist in our database? So let me remove this E and replace it with F, and let me send the request. Now it says that the movie is deleted successfully, but this ID did not exist in our database. Now the reason for it to say this is, in delete operation of mongoose, if it could not find the specified ID like in find and find one, the error will not be triggered or the exception will not be triggered. Now if you want to write an exception or throw an exception, if there is no movie related with this ID, then what you can do is you can execute the find one function and then check for the movie whether it exists or not. So for that, what we can do is we can use the find one functionality. So right above this, what we need to do is const get movie and await movies model dot find one, and inside of it we will send the condition, same condition, and if the get movie does not exist, throw an error of this movie does not exist. So we are using find one and delete in the same route, and in most of the cases we will be using many operations in the same file. So let's try wrap it with try catch as well. So try doing this, catch an error or exception, and this res.status 400.json, and then status failed, and message is E. Let's save this and do not forget to return this. If you do not return this and if response is sent twice, you will get an error like error HTTP headers already sent. So save this code. Now navigate into the Postman, and if I try to send the invalid ID here, it says the movie does not exist. Now let's go to get all movies and let's query it again and find an ID that actually exists. So go to delete movie, paste this over here, send. The movie is deleted, and if I try to send this request again, then the request fails because movies is already deleted from our system. And this is how you perform the delete query in the database. And by doing this, we have completed our replication of MoviesDB dummy API. Now in the next lesson, we'll be learning about the integration of OpenAI in this system so as to get the movie recommendations. That would be fun. So let's get started in the next section. I'll see you there. In this section, we'll be learning about integrating OpenAI into our app and prompting OpenAI for getting the movie suggestions. We'll start by installing OpenAI into our project. Then we'll be creating an OpenAI developers account. We will then generate our API key, and using the API key, we will be prompting OpenAI for providing us the movie suggestions that is based on the data of our database. It is going to be an exciting section. So let's go ahead and start integrating OpenAI for getting AI responses. So let's start integrating OpenAI into our system for getting the movie recommendations. So for this, we will be installing the npm package OpenAI. So you can search for the OpenAI in npm and open up your terminal and type npm install OpenAI. And this will bring the npm package OpenAI into your Node.js app. So now that OpenAI has been installed into our project, let's create a route that will handle the recommendation request. So in controllers, let's create a new file, movie recommendation.js. So inside of it, let's create a function. So const movie recommendation equals to an arrow function, and then let's export it. Module.exports equals to movie recommendation. So now that we have exported it, let's import it on app.js. So navigate into your app.js file and let's create a route here. So let me comment this as OpenAI suggestion. So let's create a route. So if anyone sends a request to app.get inside of API/movies and then get recommendations, our movie recommendations will be handling the request. Now there is an issue in this route, and the issue is this route will get confused with this get single movie route because the API endpoints are almost the same, or the request URL are almost the same. So /API movies, and then this is an dynamic ID, and if you send a request with get recommendation, our postman will treat this get recommendation as an single movie ID. Now let me demonstrate this in our postman. So navigate into your postman, duplicate any of these routes. So let me duplicate this get all movies and then rename this to OpenAI suggestion, and inside of it we'll be sending the request to /movies and then get recommendations. Right, let's save this and let's send a request. You can see there is an error. Although we are not sending anything from our movie recommendation, our postman is showing an error, and this error is being triggered by this get single movie because our Node.js app is being confused with this route and this route. So to avoid this, what we can do is we can modify our route a little bit, but before that, let's send a response from our route. So we'll be able to assess request and response as usual, and then inside of this we can write response.status 200.json, and then inside of this status hello from OpenAI. Now this is the response that we are expecting. Now to modify the URL, what you can do is you can simply keep an OpenAI here. So by doing this, you are making your URL unique by providing an extra parameter over here. Now our Node.js app will not get confused with this and this route. So let's go ahead and add this in our postman as well. So instead of movies/get recommendations, we'll be sending /OpenAI as well in our request. So let's send this. You can see that hello from OpenAI. So how we fixed this error was previously this API and this API endpoint were using the similar kind of address. Like this API was using API movies and get recommendations, and this was using API movies and then the dynamic ID. But when I introduced OpenAI here, I provided two parameters, but this is only expecting one parameter. So our Node.js app will skip this and it will move into this route. So by this way, we have fixed this error. So let's save this. And now we are ready to work on OpenAI for getting the recommendation. But before that, we must create a free account on OpenAI.com. So in the next lesson, we will be learning how we can create a free account on OpenAI and get our API key. So I'll see you at the next lesson. So now that we have installed OpenAI into our project and created the necessary routes, we are now ready to work on OpenAI. But before that, let's create a developer account on OpenAI.com. So in your browser, go to OpenAI.com and click at sign up. Now you can create your account using an email address, or you can use Microsoft, Apple, or Google account. So for now, I'm using the Google account. Now in most of the cases, when you sign up, you might see OpenAI is not available in your country, and if that's the case, you can always use the VPN to register your account. So now that you have registered, fill up this form, and you need to verify your number as well. So once you verify your number, this is the dashboard that you should be landed at. So click at API to see the API references. So you might be navigated to platform.openai.com. If not, you can navigate into here. And now for sending request to OpenAI, we must be generating our API key. So click at your account and click at view API keys. And then create a new secret key. And you can name your key. For now, I'll be writing testing key. And I'll be creating my secret key. So copy your key and place it somewhere in a safe place so that we can use it later. Now if you click at this usage, you can see your available limit on OpenAI. So currently OpenAI has granted me $5 credits. When you are creating a new account, they generally provide $5 credits to test the prompts. But I believe that this will be enough for us to test. But if you want to extend your limit, you can always upgrade your account. So now that we have a secret key, we can proceed to create an OpenAI request. And now go into the npm repository of this OpenAI, and then you can see the documentation of how we can integrate the OpenAI. So let me copy this code and let me paste this in our movie recommendation route. So we are importing the configuration in OpenAI from this OpenAI package. And the next step is to initialize our API key. So let's copy this and paste it inside of this function. And let's save this. And you need to replace this API, OpenAI API key with your API key. Now you can see that OpenAPI documentation has provided or has instructed us to use the environment variable to store our API key. So let's do that. So copy this and go into your env file, and then you can paste it over here, and this value will be our API key. So copy your API key from the place where you have saved this and paste it over here. And now you need to restart your server. So close your server with Command C and then npm start. Now again navigate into the documentation and then copy this completion code. So let's copy this and paste it in our VS Code. So paste it over here and then let's save this. As we are using await, this function should be async, right? Then let's save this. Now our OpenAI integration is almost complete. Let's play with a little bit. Let's provide it some prompt and see the response. Currently we are logging in our response, so let's provide a prompt, and you can provide the prompt from here. So let me type give me 3 cat names. So let me save this and let me open up my postman and let me send the request. So send, and let's see our console. So you can see that Tiger, Simba and Ariel. is the response provided by the OpenAI. Now, if you want to see the whole response of OpenAI, only keep completion.data and send the request again. So into the postman and send the request. And here you can see the actual response provided by OpenAI. You can see that it has returned an object ID with key and value pair. You can see how much credit is used for this prompt request. And inside of these choices is the prompt response. And to see your overall credit usage, you can navigate into OpenAI and hit this UI usage. If you refresh this page, you can see what is your current credit limit. So you can see that sending 2 requests is equal to 0.01. So we can send a hell lot of requests over this. So by using the $5 free credit, you can play around with it as much as you like. So in the next lesson, we will be prompting OpenAI to generate us movie recommendation based on the movies saved in our database. So I'll see you at the next lesson. So in this lesson, we will be learning about prompting OpenAI for providing us movie suggestions based on the movies in our movies model. So first, let's remove all the data inside of movies model because these are all the test data, and insert some of the movies that you like personally. And for inserting or adding the data, we will be using the add movie route. But for deleting the data, instead of copying this all ID and then deleting one by one, what we can do is we can delete it directly from here. So let's remove this and then populate this model with the movies that you want, that you like personally. So let's remove all of this and then let's add some movies. Now to check the response of OpenAI, I'll be sending only the movies that is animation related or that animated movies. So the first one is Stuart Little. Let's send this. Movie added successfully and it is available in our movies model or movies collection. And another movie that I want to add here is an epic movie. Let's send this as well. Another movie will be the Frozen movie. Let's send this as well. Another will be the Secret Life of Pets. And the last one will be the Toy Story. Sorry. Let's send this as well. So I've populated my movies model using only an animation movies. So let's see if ChatGPT or OpenAI can recommend some animation movies to me. So for that, we need to create a prompt over here. So let me remove this console log. And I see this, there is another console log as well. So let me search from overall everywhere. So console, by the way, you can search in every file from this search icon. So there is a console log. So let's comment this as well. And then navigating into movie recommendation, we will be needing the list of movies from this model. So for that, we need to initialize mongoose over here. So const mongoose is require mongoose, right? And we are trying to assess a movies model. So let's import movies model as well. So const movies model equals to mongoose.model movies. Now let's get all the data, all the movie data from our movies model. So for that, const all movies equals to await movies model dot find, and we will not be providing any condition over here so that all movie can be displayed. And let's console this, console.log all movies. Let's save this and let's see if we can get the list of all the movies in our console. So navigate into the postman and then let's run this OpenAI suggestion route. Okay, now let's see our console. So we can see that we have got all the movies in our console. So this is working fine. So now what we need to do is we need to take all this movie name out from these objects. So const movies string equals to all movies dot map, and then inside of this will be an element, and for each element we want to provide el.movie underscore name. By doing this, we'll only be getting the name. So let's console this movie string over here and let's send the request over again. So navigate into the postman, send the request and look out for the console. So you can see that there is an array with all the movies. but it is an array, it is not a string. So what I want to do is I want to join this using an comma. So again, let's console. So navigate into the Postman and send a request again. So you can see that I have got a list of movies from my database. Now let's build a prompt with this. So our prompt will be const prompt will be I need a movie recommendation based on these movies. So we will be providing our movie name here. So movies string provide me, sorry, it should be inside this. So provide me with 10 suggestions, right? So let's console and see this prompt. Console.log this prompt prompt. And you can see that I need a movie recommendation based on these movies, and these are the list of movies, and I have written provide me with 10 suggestions. Now I will send this as a prompt over here, right? And here I want to log the results. So console.log completion, and then we'll be looking for completion.data. So let's save this and send the request again from Postman. Now if I send the request, and in the console you can see the response from OpenAI. We have got an object, and inside of the object there is a key called choices, and inside of it we have a text key in which there is a suggestion of the movies. So let's console that as well. So completion.data.choices, and most of the time we will be only needing the first data of array and then the text. So let's save this and send the request over again. And in console we have a list of movies, but seems like OpenAI has truncated the response. Seems like it is not providing us the full text, right? And the reason for that is OpenAI charges the API according to the length of response. So by not declaring the maximum length, our OpenAI is reducing the response on its own, right? So if you want to see the full response, you must be providing the max underscore tokens. So you are allowing the ChatGPT or OpenAI to deduct your token for getting the larger responses. Now in production environment, you must be serious about this, but in test environment, let's give them 100 tokens for now. Let's save this and send the request again. And there you have it, 10 movies suggested by OpenAI based on the data on our database. And seems like all of these are animated movies. Now let's again send request to generate even more movie suggestions. And there you have it. Now you can do this for multiple times until your credit runs out. Now let's send this data back into the response, right? So for that, let's copy this, or let's cut this from here, remove this as well. And instead of status, let's write data or movies data or suggestions, right? And in place of suggestions, we are providing the suggestions from OpenAI. So let's save this and send the request. Now sending the request, and you can see the suggested movie in the response itself, but the data is not formatted well. So we will ask ChatGPT or OpenAI to separate these list of movies with comma. Separate movies with comma, right? Let's save this, send the request again, and there you have a list of movies separated with comma. And this is how you prompt OpenAI for generating responses. But you almost forgot one very important thing, and the thing is wrapping this await statement with try catch block. Now we know that if we are using the await statement and if it throws an exception, then our server will crash, and for preventing it we need to wrap it with try catch block. Now we could have done this before, but mistakes were made. We forgot to wrap it with try catch. Now if we forgot to wrap it with try catch and if the exception is thrown, let's see what happens. So let me modify this model to use something that does not exist. So let's save this and let's send the request from our Postman. And there you can see our server has crashed because this model does not exist. and our node is waiting for the file change to restart the server. Our app has crashed and it cannot handle any more requests. So this is not what we want. So we need to wrap this with try catch as well. So try doing this statement, and then if there is an error, catch an exception, and then we'll be sending the response.status 400.json status failed, and the message will be could not get recommendations. Also, don't forget to return this. And now we still have an issue, and the issue is we have an completion inside of this try block, but we are trying to assess this completion outside from the try block, right? So this will throw an exception. So what we can do is we can cut this and we can paste it over here. Now let's save this and send the request again. So send, and then you can see our Node.js app has handled the error in a graceful way, and our server is also working fine. Now let's modify this model to use the correct model. So let's save this and let's try to get the suggestion again. So send, and there you have your suggestions. Now you can modify this prompt to display any results you want. So play with it, modify the prompt and see the response for yourself. The possibilities of prompting are endless. So explore on your own what you can do by integrating OpenAI into your system in the future as well. So this ends this section of OpenAI integration. So now that you have an idea, you can use this idea to create awesome apps using Node.js. So I'll see you at the next section. In this lesson, we'll be learning about Express Async Error package and how we can use this package for effectively handling errors in our Node.js app. By using this package, we can speed up our development process by more than 50% because it will remove the hassle of wrapping our code with try and catch every time. Now, if you look into our code base, you can see that at every route or every controller, we have wrapped our code with try catch block multiple times. In every controller, we have used try catch so as to prevent our server from crashing if the exception or error is thrown. And therefore, our code is being more complex, and in the long run, it will be difficult to maintain. So we will be using Express Async Error package to effectively handle the error or exception thrown by our Node.js app, so that we don't need to wrap our code with try and catch block every time. By not using try and catch block every time for error handling, we'll be saving a lot of time, as you can directly throw an error and our Express Async Error package will handle the error for us. So let's go ahead and install that package. So open up your terminal and type npm install express async -errors. Now after installing the package, let's initialize it in our project. So for that, navigate into app.js, and this time we will be importing our Express Async Error directly into app.js and not on every route. So go to the starting of your app.js, and it must be the starting. If you import this file or this package after the express, then it will not work. It must be at the starting part of your app.js file. So require Express Async Errors. So after initializing it, move to the part where you have declared the app as an Express app. So at this part, here we will be creating a handler for our error handling purpose. So let's create a handler first. New folder, and then name it as handlers. And inside of it, we'll create a new file, error handler JS. And inside of it, let's create an arrow function. So const error handler, and export this as well. Module.exports equals to error handler. Now we will be using this error handler to handle all the errors in our Express app. Now we need to import this error handler and use it in our app.js. So for that, you need to write app.use and then inside of it error handler. Also don't forget to import this, and you should make sure that this app.use error handler should be at the end of all the routes. So in my part of the code, it should be around here where all the routes are ended, so that if any of this route throw an exception or an error, this error will be handled by our error handler. So it should be at the end where all the routes have ended. So make sure it is at the end, and let's save this code. Now this error handler will be able to assess 4 parameters over here. The first one is error, and then the request, the response as previous, and then the next functionality. Right? These are the 4 parameters that the Express will provide to our error handler. Now inside of the error handler, what we are going to write is, if there is an error in our app, then we will be sending response with status of 400, and this will be our JSON response, and then in status we will be writing failed, and our message will be something went wrong. Let's write it for now and let's customize it later. And if there is no error, we want this code to proceed, so next function will run here. So what is this next functionality and what is this app.use functionality? So these are the parts of Express middleware. We have not learned about the Express middleware until now, and in this lesson as well we will not be learning, because in our upcoming lesson there is a separate lesson for this Express middleware for us to understand, and if I explain it to you now, it will be difficult for you to understand as well. So what I'm going to do is I'm going to provide you a simple explanation of what this is. So app.use is we are using a certain functionality over here, and this next function is allowing our app to move further. Just understand this for now, and when we reach the middleware section, I'll revise this so you have a clear idea. So now we are ready to remove all the try and catch block from our app, right? So let's navigate into this add a movie first, and then let's remove this try and catch block. So remove this try and remove this as well. Now typically if you throw this kind of error and do not wrap it with try and catch block, our server will crash. But now that we have used error handler, let's go ahead and test this route. But first make sure that in your app.js error handler is moved at the end of all the routes. So now we will see how our server will respond now that we have removed try catch block when we are throwing an exception. So navigate into the postman on add movie route. So add a movie, and in this payload let's comment out this info key. If you see at our code, if there is no info in request.body payload, then the exception is thrown of info must be provided. So let's test that. So info, we have commented out the info, so send the request. And there you have it, our server has not crashed and our error handler has successfully handled the exception errors. So instead of saying something went wrong, what we can do is we can display error over here. So the error is the error. So let's save this and let's navigate into the postman again and let's send the request again. So send, and there you can see it, info must be provided. So our error handler is working perfectly fine, and we do not need to wrap each and every part of our code with try and catch block. And this will help us write clean code, more maintainable code, and it will save our time in development. Also, you can remove this try and catch block that you have wrapped for the await statement. So we can completely remove all this try and catch block and let express async error do all the hard work. So let's save this and let's try to trigger an error from the mongoose by not providing the movie name. Now we are not checking the movie name using a general validation. Instead what we are doing is we are checking the movie name as a required item from the model itself. So if someone tries to create a movie without a movie name, then the mongoose must throw error. And let's see if our error handler can handle the error thrown by mongoose, that is using an await statement. So navigate into the postman, uncomment this info and comment this movie name. So save this and try to send a request. So you can see our error is being handled gracefully. Our server has not crashed, and then you can see the actual error over here, but it is not formatted well. So let's make some changes in our error handler. So in our error handler, if there is an error, and if there is an error dot message inside of our error, then we will be sending a response which has error dot message. right? And if it does not have message, then we will simply provide a response with an error only. So let's save this. Take your time to understand this code. In this code we have written, if the error object or the error or the exception has a message key in the object, then we will be showing that message, like we did in a previously in our mongoose errors. So in mongoose error there was a message key in our error, so we displayed error.message. But in our own exception, where we triggered a throw statement, where we provided a throw statement, we were only displaying this exception. So in our error handler, what we are writing is, if there is a message key in the error, then display the error message, and if there is no message, then simply display the error. Now this error handling function will handle most of the errors. So let's navigate into the Postman and let's send this request again. So you can see there is a beautiful error message, not so much beautiful, but it is kind of beautiful. So it says that the movie validation failed, movie name is required. And if I modify my payload to send the movie name but not the info name and trigger our own exception, then it says that the info must be provided. So in most of the cases, this error handling code will work fine. And if it does not, you can always console the error and see where exactly the error message is, and you can format it in your own way. But let's leave it as it is now. So now what you can do is, you can remove try catch from all of our code and make our code easier to read. So we have removed the try catch block from add movie. So let's go ahead and delete movie as well and remove this try and catch block here as well. Let's remove this. See the difference that it has made in our code. In edit movie as well, let's remove this try and catch block and this as well. Let's save this. Inside of get all movies, let's remove this as well. Let's save this. In get single movie, let's save this. And in movie recommendation, also here we are using an create completion function with an await statement in OpenAI. Our express async error is capable of handling all these kind of thing without try catch, so remove this as well. So now if you test any of this route, our server will not crash, as all the errors will be handled by our express async error. And there is one last thing that should be done. So navigate into your error handler, and inside of this if error statement, you should console.log the actual error. You are displaying this error, a beautiful error message for your users or for your clients, but you should be able to see the actual error. So if an error occurs, your user will see the customized error message, but you will still be able to see the actual error message in your console. So let's try this. Navigate into add movie route. Don't provide the movie name so that the mongoose exception will occur. So if I send this, you can see that there is somewhat of a beautiful message over here, but if you see your console, you can see the exact error that is thrown here. The server has not crashed, but it has consoled our error. So you can see that the movie validation failed and all these different kind of stuff in your console log, so you can easily debug your code. And that's the way of handling the error in an effective way. This will increase your productivity and help you code faster. Now we have reached the end of our movies API. From the next section, we will be starting a new project called Expense Tracker Pro, where we will be utilizing all the things that we have learned until now, and we will learn many things over there as well. So from the next section, we will dive in a little bit more. So I'll see you there. From this section, we will be working on our new project Expense Tracker Pro. So let's have a sneak peek at what we will be building. We'll start by setting up a project. Then we'll be integrating MongoDB and set up models and schemas. We'll then work on user registration and user login. Then we'll be learning about authentication middleware, how we can use JSON web tokens for authentications. We'll also be learning about sending emails in NodeJS, how we can create forget and reset password routes. And in between, we'll be learning so many things that will help us become a better backend developer. And then we'll be working on live deployment and testing our live API. I'm excited for this section and I hope you are too. So let's get started. Before we dive into the development process, let's have a look at the system that we are trying to build. This is an Expense Tracker Pro blueprint and it will help us understand what are the things that needs to be done for creating this app. Now, as you can see, we will be having two routes initially, the user registration and user login. So we will start our development by creating a user registration route from which we will register the user and keep the user data in our database. And then we will be working on user login. After that, we will be creating a user dashboard which will be a protected route. In this lesson, we will also be learning, or in this part of the project, we will also be learning how we can create a protected route and how we can authorize the user to be able to access the protected routes. And then we will have the transactions. We'll allow the user to enter the transactions, and transaction can be of two types, income and expenses type of transaction. So when user enters certain amount as an income, we will be adding that income to our user balance, and when user tries to enter the expenses, we'll be deducting it from the user balance. And then in the dashboard route, we'll be showing the user balance and most recent 5 transactions. Now, by having a glance at this blueprint, it seems like a very basic project and there's nothing much to learn while creating this project, right? But in reality, we'll be learning so much more stuff in this project. We'll be learning about the public route and protected route. We'll be learning how we can protect the route from unauthorized access, how we can authenticate the users for them to be able to access the protected route. We'll be learning about encrypting data in the database, about JWT authentication and how we can authenticate the user. We'll be learning about working with multiple models and schema and how we can create a link between them. And we'll be learning so much more throughout this project. So let's get started by setting up this project and starting our development in Expense Tracker Pro. So I'll see you at the next lesson. From this lesson, we'll be working on our new project Expense Tracker Pro. We'll be applying everything that we have learned till now, and then we will dive even more deeper into the backend development. So let's get started by creating a new directory. So I'm using Expense Tracker Pro as my directory name. Now let's open this in VS Code. Now once open, let's create our first file app.js. This will be our entry point, and then go into the new terminal and then npm install express. We will be installing all the dependencies. Also, it is recommended that first we do npm init before installing the packages, but running it later is also fine. So in typing just enter will do the job, and then we will be getting our full package.json file. So next dependency that we will be installing is the nodemon. So npm install nodemon. Let's initialize the nodemon now. So in package.json, if there is an npm start, then it will run nodemon app.js. So let's save this. The next dependency that we will be installing is npm install express async -errors. And now we can start our coding. So navigate into app.js. First import the express const. Express is the require express. And before that, we need to require express async errors. And almost forgot, we need to install the mongoose as well. So npm install mongoose. So now let's create a server. So const app is the express app, and then app.listen will be listening to port 8000, and if connection is successful, we'll be consoling server started successfully. Right, let's save this and let's perform npm start. And sometime you might be getting this error. This e address in use is the error that is triggered when this port 8000, something is running on port 8000. So if this error occurs in your side, check if there are instances of VS Code open in which the server is currently running on port 8000, and if they are running, then you can close that VS Code. Or if you have installed any other system that is using port 8000, then our server could not access the port 8000, so you might need to change the port. But for me, I'm currently using another VS Code for restarting the server, so let me close that. So after closing it, let me terminate this and npm start again. So now the server has started successfully. So we have set up all the dependencies that we might require, and if we require some more, we will be installing in the process of development. So now let's create our error handler as well, because eventually we need to do that. So new folder handlers, and then inside of it new file error handler.js, and inside of it const error handler equals to an error function, and module.exports is the error handler, right? And this is const. Save this, and this will have an ss2 error request response and then next function, right? Now if there is an error, we will be sending a message of res.status 400.json status failed, and then error will be the error, right? And if nothing is there, we want it to move to the next section. So let's save this and import it in our app.js. So at the end of all routes, and after this we will be importing our file. So app.use, and then inside of it we will be writing error handler. Let's save this. And the next thing we might need is app.use express.json, and another file that we need is .env file that will be used to store the secret data of our Node.js app. So seems like everything is set up. So let's move to another lesson, and in that lesson we will be connecting to our MongoDB database. So I'll see you there. So now that we have set up our project, let's go ahead and connect to our MongoDB database. Now for this project, you don't need to go to a MongoDB Atlas and create a new account. We can use the same connection string but a different database. So bring up your connection string from env file of your movies.db and then paste it in our environment variable file. So the thing that you need to understand over here is you can use a same connection string but be able to create and use multiple databases. Now the connection string that you see over here, this connection string is for the MongoDB cluster. If you navigate into the MongoDB compass, this whole system is a MongoDB cluster and not the database. These are the database, right? A cluster can have multiple databases. So in order to create a new database and use that for this project, simply rename this movies.db with the new database. So I'll be using expense tracker pro or expense tracker db, and by doing this I'll be able to create a new database into our cluster and then use it for the development of the expense tracker. As simple as that. Only you need to do is you need to rename the database. So now that you know, you do not need to create MongoDB Atlas account for every project. So now that we have our connection string in our environment variable, let's go ahead and connect to our MongoDB database. But before that, for accessing the environment variables, we will be needing .env package. So let's install that. So npm install .env. After the installation, we will be importing. So require .env and then execute the config function. So now we will be able to access the environment variable. So let's connect to our MongoDB database. So after the app is declared express, we'll be connecting. So first let's import the mongoose. So const mongoose equals to require mongoose, and then mongoose.connect. The first is the mongo URI. So process.in or environment dot the key mongo connection, and the second will be the configuration. We will leave it as it is, and then if the connection is successful, we will be displaying console.log mongo connection successful, and then if there is an error, we will be displaying Mongo connection failed. So now let's start our project, npm start, and there you can see server started successfully and the MongoDB connection was also successful. So let's navigate into the MongoDB compass and refresh this globally. So you can see that we do not have an expense tracker pro DB currently in our database, because without the collection, it will not be displayed by the MongoDB Compass. So now that we have connected to our MongoDB database, let's go ahead and create our first model. And the first model will be the users model that will hold the registration data of our users. So let's create a new folder. And the folder name will be the models. And inside of it, there will be a file called users.model.js. And inside of this model, we'll be writing our model development code. So let's first import mongoose. So const mongoose is require mongoose, right? And then we'll be creating the model. So const users model equals to mongoose.model, and then inside of it the users, and then the users schema. Let's create this user schema. So const user schema equals to new mongoose.schema, .schema, and then inside of this there will be an object that will hold the schema data of the users. So for the user registration or for storing the users data, we will be needing the full name of an user. So full underscore name, and then this will be of type string, and this is a required parameter true. And if user does not provide it, we will be writing please provide full name, right? And the second object will be the email address, so email, and then this will be of type string, and then this will also be a required field, and if user doesn't enter it, email is required. Also let's rename this as well, so full name is required, or simply we can ask for name, and this will be name is required, right? Now if you want a certain variable or the certain field to be unique, then you can write this validation in the model itself. So for that, unique equals to true. And if the user tries to provide the same email address for the registration that is already registered, our mongoose will throw an error, right? Now the other fields are name, email, and other field is password. So the password will be of type string, and then password will be the required field, and password is required, right? Now let's add one last important field, and the field will be the balance that will hold the actual balance of the user. So this will be of type number, right? And this is also required, balance is required, and then its default value will be the 0. So if the value is not provided in the balance, then the default value will be 0. So this is another rule for the schema. If you want the default value to appear even if the user does not provide it, then you can provide the default value. Now I think these fields will be enough for now, and if you need any other field, you can always come here and add the field. So let's save this, and now let's initialize it in app.js. So after the mongoose connection, let me write a comment. So models initialization, and here I'll be requiring the models, and inside of it users.model, but I have not exported from here. So module.exports, and then the model name users model, right? Let's save this, and by doing this our model has been initialized. And if you navigate into the MongoDB Compass and refresh your page, you can see that there is a new database called expense tracker DB, and inside of it there is a collection called users. So now that we have user collections or user model, let's go ahead and create our user registration route. So I'll be seeing you at the next lesson. In this lesson, we'll be learning about modular code organization in Node.js, or I like to call it modular approach of Node.js. And this approach will help you when you are working with larger projects. Now, if we have a look at our previous project, Movies API, you can see that for every route, we have a controller, right? And we have created a folder named controllers, and we have kept all the controllers over here, which is a good approach in itself, because writing everything inside of app.js will make our code more complex and difficult to maintain, right? So instead of writing everything inside of app.js, we created different files, and different functions will handle different aspects of our API. Now generally this will be a good approach because it will make our code more maintainable and easier to read. But when we are working on a larger project, it might not be enough for making our code maintainable and easier to read, because inside of controllers there may be hundreds if not thousands of files, and it will be difficult for us to maintain our code base. So for removing or reducing those complexity, we will be learning about modular code organization or modular approach of Node.js. In modular approach, instead of writing everything inside of a controller, we will be splitting the functionality of our entire project into different modules and work on different aspects of our functionalities in a different module. So let's see how it's done. Now if you look into the blueprint of Expense Tracker Pro, I can see two different modules. The first module will be the user module, in which there will be everything from user login, registration, authentication to different other things. And then another module will be the transactions module, which will handle the transaction. So what we have done is we have splitted our entire project functionality into two different modules. The first one being the user part and the second one being the transaction part. So now instead of creating a controller over here, I am going to create a new folder called modules, right? And inside of modules, I'll be creating two folders. The first one being users, and inside of module there will be another one called transactions. Make sure that this transaction is a child of modules and not of users. So inside of the modules there should be one transaction and one users. So this transaction module will handle everything related to the transaction, and this users module will handle everything related to the users. At first we will be working on this users module, and in the later part of this course we will be working on the transaction as well. But first now let's work inside the users. So inside of users, let's create a new file, and the file name will be users.routes.js. Now in this users route, we will be handling, or we will be keeping all the routes instead of populating our route in app.js. What it does, it makes our app.js simple and easier to read, while we will be handling all the functionalities related to this user module or related to this API endpoint from user routes.js. We are making our code simpler and easier to read, right? And inside of this user folder, we will have another folder called controllers. And inside of the controllers, there will be all the logics of users related to users. So user login, user registration, everything will be inside of the controllers. So let's create a file inside of a controller called register.js. So let's get started by creating a user registration functionality inside of register.js, and then we will be linking it finally to app.js. So const register equals to an arrow function, and then module.exports equals to register, right? And inside of this we will have an SS of request and response, though we have not sent it, but it will have a request and response parameter once we import it in app.js. So request and response, and in response we will be sending res.status 200, and then the JSON. Inside of it will be the status and hello from register, right? Let's save this. And now we will be importing this at user route.js, because everything inside of the controller will be defined by the routes. Now if you want to use routes separately instead of declaring it in app.js, you have to import a router functionality of Express. So let's start by importing Express. So const express equals to require express, and then const user route will be the express.router. So by using the express router, we can create the custom routes. Now the next step will be to export this. So module.exports, so that this can be used in our app.js, equals to user routes. And let's name this as routes, as well as it will hold multiple routes, right? Now inside of this, we can declare the routes. Before exporting, we can define our controllers over here. So let's save this and then navigate into app.js and let's import these user.routes, right? So in app.js, after this express.json has been used, what you can do is you can create a new route that will redirect us to this user routes. So app.use, and if request is sent to /API, meaning localhost 8000 /API/users, as this is the users module, right? So if someone sends a request to 8000 /API localhost 8000 /API/users, then we will be redirecting this request to user routes. And let's save this, and also let's comment this as routes. Let's save this as well. And now let's navigate into user.routes and use this register controller over here. Use this register controller inside of user routes. So for that, what we need to do is user routes, and if someone want to send a post request inside of /register, then we will be handling that request by using the register that is on the controllers. So your code should look like this, and let's save this code. So let's try to understand what has happened here. So inside of this app.js, we have imported our user routes, which is a router from Express. Now if you want to import a router from Express, you should be using app.use. We cannot use REST API method over here like get, post, patch and delete, because it will be used inside of this router, right? So for importing the router or Express router, we should be using app.use. Now what we are redirecting Express is, if someone sends a request to localhost 8000 /API/users, then all these requests will be handled by user routes. It can be of any method. It can be of get, post, pass, delete. All method will be handled by the user routes, right? And inside of this user route, we are defining the API, REST API method and the final URL, which will be handled by the controller. So for this controller to be triggered, the request should come through localhost 8000 /API/users/register. So let me show you how this works in our Postman. So let's start up the Postman and let's create a new collection. So let's create a new collection by clicking here, and then our collection name will be Expense Tracker Pro, right? Let's save this, and inside of it, let's create a new request. So add a request, and the request method will be the post method, and the URL will be http localhost 8000 /API/users and then /register. And by doing this, we are calling the register controller. So let's send the request and hello from register. And this is how you use the Express router functionality. You can take your time and try to understand what has happened if you are still confused. Now by using this Express routes, we are transferring all of these routes into a certain module. By this, we are saving a lot of time and making our code easier to read, maintainable, and we are not cluttering up our app.js by different routes and controllers. And in the large project, it will be very much easier for us to work. I know this because I have worked on CRM software, ERP software, support management, and so many other software, so many large projects, right? And I have always used this modular approach of coding, and I hope this will help you too. So in the next lesson, we will be working on user registration. So I'll see you there. In this lesson, we will be working on user registration. Now, when you are using a modular approach of Node.js, it will be easier for you to navigate the files that you are trying to work on. Like if you want to go to the register.js, you can simply navigate to modules, and then you know that the registration will be inside of users, and inside of users controller, you will be getting the register. So it will be easier for you when you are working on the larger projects as well, right? Also, I like to share with you a feature in Visual Studio Code that will help you when you are working on the larger project. Now, if you want to go into any file without navigating through all these folders, because in larger projects there will be multiple modules, hundreds of modules, right? And to search for the specific file, it will be difficult for you. So what you can do is you can type or you can press Ctrl P or Command P and search for this file easily. So this is one of the feature of Visual Studio Code. Control P or Command P and then the file name, and it will navigate you through that file. So let's start working on the registration route. Now the first thing that we want to do here is import the mongoose. So const mongoose is require mongoose, right? And then we will be importing the model as well. So const users model equals to mongoose.model and then the users, and make sure your name of this model matches with the name that is inside of this, right? So the next thing that you want to do is you want to destructure the request.body payload. So start destructuring from request.body, right? And the things that we'll be needing here is the email, the password, and then for confirming the password, we will be requiring confirm underscore password. We will not be entering it into the database, but we will run a validations over here. So email, password, confirm password. Let's check the model. Email, we have name, we have password and balance. So the password, name, and the balance, right? Now that we have all the necessary data from payload, what you want to do is we want to await, and inside of await, users model that create, and then inside of it we'll be writing name is the name, right? And then the email is the email, and then the password will be the password, and the balance will be the balance, right? Now this await functionality or the await statement requires the function to be async. So let's write that as well and let's save it. So now let's send the request from Postman. So navigate into the Postman and then inside of body, raw, JSON, and inside of it we will be providing the payload data. So name will be the Alex, and then the password, let it be 123456, right? And the confirm password will be 123456 as well, and then the email becomes alex@gmail.com, and then the balance, initial balance of Alex is maybe 100, right? Now let's change this. So it's saying hello from the register. Let's change that as well, but we might have already got the data in our database. So click it find, and there you have it, your results on the database, right? Now let's modify our response a little bit. So instead of this providing this hello from register, we'll be writing user registered successfully, right? Or generally if something is created in database, we send 201. So navigate into the Postman again, and then this time let's rename this first. So this will be user registration, and in Postman 2 we will be following the modular style. So create a folder, and inside of this folder there will be the users module. So rename it to users, and inside of users drag and drop it over here. So inside of users module there is a user registration. So our backend is in sync with the API testing, right? So inside of registration we have our registration page. Now what if I try to send this request again? We have kept our email as unique. You can see at the model we have kept our name email as the unique parameter or the unique value, so that it will not let our database to create a similar value in the same model, right? So if I send the request, then you'll see that our server has thrown an error, and it's saying this alex@gmail.com is already registered. There is a validation error that is thrown by Mongoose, but the error response that you can see over is not understood by the client. How will client be able to know that they have entered the same email address that is already in the database if you showed this kind of error? So we need to make our error handling a little bit effective. For that, navigate into our error handler, and then inside of it, what I want you to write is, if there is an error, and if error dot message, if it has a message, then we will be showing error.message, and else we will be displaying the same error. And if error has a message, then we will be displaying error.message. Let's save this and let's see the response again. And we'll be providing the same email address over again. So send. Now you can see here that it is a little bit better from what we are getting before. It is a little bit readable, right? But still, client will not be able to find the real error. Now to show the real error of mongoose or the exception that is thrown by the mongoose, we must detect the error code that is being thrown. And then we need to be able to detect in which key the error is being thrown. And also if the error is thrown by multiple validations, then the approach for displaying the errors are different. And also mongoose exceptions are of different types like cast error, validation error, validator error, duplicate key error, and so many other types, and each type needs to be handled in a different way. So instead of throwing the exceptions or displaying the exception that is thrown by the mongoose that is not formatted well, we are going to create our own validations. And this is how we do it. So in our register.js, we need to check if the email that is entered by the user exists in our model or not, right? So for that, what we can do is const get duplicate email, and then to get the duplicate email, we will be checking our user's model dot find one, and then in condition we will be writing email equals to email. So we are checking the data in the database if the email that is entered by the user matches the entry in our database or model or not, right? So if this get duplicate email gets some data from the database, then it means that this email already exists and we need to throw the exception. So if get duplicate email exists, then throw this email already exists. This email already exists. Now let's try sending the request over again. So navigate into the postman and let's send the request. So you can see this email already exists. So in this code, what we are doing is we are checking for the validations of the data before the creation process. By doing that, we are throwing our custom error messages and not letting the code pass to this create pipeline or create query, right? And by doing this, we are validating and throwing our own custom exception instead of relying on Mongoose throwing an exception for us. So now that we have restricted users with the same email address to register twice, let's check for other validations as well. So we'll be checking for email, password, confirm password, name and balance. So let's start writing our validations. So validations, let me comment this. If email does not exist, then throw email must be provided, right? And if there is no password, then throw password must be provided. And again, if password.length is less than 5, then throw password must be at least 5 characters long, right? And this is our validations. So if there is no name, throw name is required, right? And then if the password does not match with confirm underscore password, then we will be throwing an exception of password and confirmed password does not match, right? So let's save this. Now we have performed all the necessary validations and we have also checked for the duplicate email. Now we are ready to create a valid data on our database. So let's send this query from our postman. Let's send this request and then see if the data will be created. So I'm getting this email already exists error. So because the alex at gmail.com is already in our database. So let's use zone for now and then send the request. And everything seems to be working fine. So now the user registered successfully. So let's see our database. And we have two entries, alex@gmail.com and john@gmail.com. So now let's try to send the request by modifying our payload to throw some exception. So let's not provide this Alex. So without providing the name variable, we'll get an error name is required that is triggered from our code, right? And let's send without matching the password and confirm password. So the password is 123567 and confirm password is 12356. So if I send it, you'll get an error password and confirm password does not match. So seems like all the validations are working fine. So you might have noticed we are validating our data two times, one from the model and one from the controller. So in model we have written that in this name field, the name is required. This is a required field, right? This should already check for the validation, but we have also written the custom validation code over here in our controller. And the reason for it is we are writing the validation in the controller for displaying the custom error message and for keeping those validations which are not possible for us to include in the model or the schema. And also we have validated the data from the schema, right? And the reason for us to do so is because this is the final checkpoint of the data. If we ever forget to validate any data from the controllers, then the validation in the schema will work and the incorrect data will not be entered in the database. So it is super important that we include the validation logic in the schema as well. And by keeping the validation logic inside of the schema, we assure that the data that is stored in the database is correct and error free. You might have noticed that while saving the data in the database, we are saving this password in the plain text. Now we cannot save this password in the plain text in our database due to security issues. And in the next lesson, we will be learning how we can encrypt the data in the database and why it is important for encrypting the data in our database for assuring the user safety. So I'll see you at the next lesson. In this lesson, we will be learning about encrypting the data in our database. Until now, we have learned about the user registration and how we can handle the user registration. Now it's time that we provide some level of security to our users. It is very important that we encrypt the user password in our database because the user might have kept the same password over in the multiple platforms, right? So if our database get hacked or leaked, then the user account might be compromised in different other platforms, right? The user might be using same password for the social medias, for bank logins, and in many other platforms, right? So if our database get leaked, then if I are saving the password in a plain text, then user account over all platforms will be compromised. So to protect the user information and to protect the user privacy, we should be encrypting these passwords in the database, right? And for that, we will be using the bcrypt package from npm. So let's go ahead and install the bcrypt package. So npm install bcrypt. So after the bcrypt is installed, let's move into register.js. Command P and then register.js. So instead of navigating between all these folders, I am simply typing or pressing Command P or CTRL-P and then finding the file. So in the place where we are saving the data in the database, what we need to do is instead of sending the same password that is entered by user, we need to run the bcrypt hashing code over here. So let's import this bcrypt. So const bcrypt equals to require bcrypt, right? Now instead of sending the plain password when creating an account, what I want to do is I want to hash the password. So const hashed password equals to, then we will be using the bcrypt hashing method. So bcrypt dot hash, and the first parameter for hashing will be the string that you want to hash. So the password, right? The password from our payload. And the second parameter will be the rounds for hashing, which means that how many times this password should be hashed in order to provide you with the hashed password. If you provide a simple number like 1 or a lower number like 1, 2, 3, then the password will be hashed for 3 times or for 3 rounds. Now if you provide a smaller number like 1, 2 or 3, your password will be hashed for 1, 2 or 3 times, right? And it will be easier for the hacker to guess your password. So we should be using a little higher number but not too much higher. Now if we use the smaller number for hashing, then it will be easier for the hacker to guess our password. But if we use a larger number, then it will be difficult for the backend to hash the password because it is an expensive operation and it needs to hash over and over again. So we need to find the optimal hashing round. and the number between 10 to 12 is regarded as an optimal hashing. So we will be using 12 for this. And then as this is an expensive operation and it might delay, we will be using await as well. Without await, we will not be able to hash our password. And now instead of sending the plain password in our create pipeline, we will be sending the hashed password. So let's save this and let's try to send a request from Postman. Payload seems okay. So send. But the zone@gmail.com already exists, so we have got an exception. So let's use Chris for now and send the request. And you can see user registered successfully. Navigate into Mongo Compass and then find. And you can see here the password is now hashed and is stored safely in our database. And this hash password string cannot be ever converted into the plain text ever again. And this is how hashing works. So even if someone has access to our database and if they could see the password, they will only be seeing the hash password and not the plain text over in our database. So you might be wondering, if there is no way to convert this hash string to the original string, then how will we handle the login request of the user, right? If this cannot be converted into the plain text, how will we compare the password? Now there is a way, and we'll be discussing that in the next lesson where we will be working on user login. So I'll see you there. In this lesson, we will be working on user login, but before that, let's clear some data from our database. I have removed all the users from this user model so as to have a fresh start, right? You can also go ahead and delete all the data and create some new user logins. So let's go to the Postman and create a new account first. So our name will be Alex, password will be 12356, and the email will be Alex. Also let the balance be 100. So let me send the request and user registered successfully. Back to MongoDB Compass, and then we can see the user is registered over here and our password is hashed using the bcrypt, right? Now let's create a new route for user login. So inside of modules, inside of users, inside of controllers, we'll be creating a new route. So new file login.js. So let's start working on login.js. So const login equals to an arrow function, right? And then module.exports login. And then we will be needing the mongoose as well. So const mongoose, because we require mongoose. And then we'll be needing the model as well. So const users model equals to mongoose dot model, and then the users. And the payload will be sent as in JSON using the post request. So we will be destructuring that as well. So const, and the user will be sending email and password for validation. So we will be checking the email and password. And this is destructured from request.body, right? Now we will have an access to request and response variable from here. Now let's include this login in our user routes. So if someone send the request to, let's copy this, and someone send the request to login, then the login route will handle all the logics. So let's save this. And now let's create a new request in our Postman. So let's duplicate this and rename this as user login. And this will be the post request and the API will be login. And inside of the body, we will be having the email and password only. So email alex@gmail.com, and then the password is probably 123456, right? So let's save it and then let's try to send the request. Now we are not sending any request back from our code, so Postman will keep on sending the request. Navigate into the login.js and let's try sending a response. So rest.status 200.json, and inside of it we'll be sending status success, and then the message will be user logged in successfully. Right, let's save this, let the server restart, and then let's send the request again. So user logged in successfully, so our route is working fine. Now for handling the login, what we need to do first is to detect whether the email that the user provided for login exists in our database or not. For that, what we can do is const get user await users model dot find one, and then the condition will be email equals to email. So we are trying to find if the email that user provided exists in our database. So this will be an async function, right? And if there is a get user, then we can try login. But if there is not any user with this email address, if there is no user, we are keeping an exclamation, which denotes that if this get user is empty or undefined, then we will be throwing an error. This email does not exist in the system, right? So let's save this. Now let's go back to the postman and send a request. So let the email be LX2, which does not exist in our database. So let's try to log in. So it says that this email does not exist, right? So back into our code. So you can see that if the email does not exist in the system, we will throw an exception. But if the email exists and if this query could find some data, then the data will be stored on get user. So let's console this. So console.log get user, right? So let's head back into the postman and send the request over again. So email does not exist. If there is, this email is not found in the database, and if this email is found, then ignore this message for now, as we are not validating or comparing the password. It's only showing this response, a dummy response. But in console, you can see the data that matches with this email address, right? It is in the form of object. So the next step for us will be to compare the password of the user with the password that is entered in our payload, right? But you can see the password in our database is in hashed format, and we will be getting the plain text as a password from the payload, right? So there is no way to compare this password with the password that is in our payload, because one is the hashed string and one will be the plain string. So we need to use the bcrypt compare method, and here's how we do it. So const compare password equals to await, because we are using the bcrypt. So bcrypt dot compare, and we need to import the bcrypt first. So const bcrypt equals to require bcrypt, right? Now we can run the functionality of bcrypt.compare, and inside of this will be some parameters, the data that we are trying to compare. So this is the plain string, right? The first parameters will be the string or plain text. So the password, and then the encrypted string. So encrypted string will be the get user dot password, right? Now this bcrypt.compare function will return either true or false. If the comparison is successful, then it will return true in compare password, and if it fails, it will return false. So if compare password is not true, right, then we will be throwing an error, email and password do not match, right? Let's save this. So if the password does not match or this bcrypt.compare fails, then we will throw an exception of email and password do not match. But if everything is correct, then the code will move to this response sender. So for that reason, we will always keep our success response at the end of the line, right? So this is the success response. Now let's send the request in the postman and let's check the response. So we will be entering the incorrect password first. So send, and there you can see email and password do not match. Now let's try sending the real password. So 12356 and send, and there you can see user logged in successfully. So this is how you use the bcrypt to compare the hashed password with the plain text password. So now that we have worked on login and register, our users module is almost complete. Now we will be moving towards the transaction module. But in the blueprint, you could see that the transaction module has the protected route. If the user is not logged in, then they will not be able to access the transactions module or anything inside of it, right? So here comes the part of authentication and authorization. So in the next lesson, we will be learning about the protected routes, authorization and authentication. So I'll see you there. So in this lesson, we will be learning about user authentication and authorization, and also we will be learning how we can create a protected route in which only the users that are authenticated can have access to. So now let's go ahead and create a user dashboard API. So inside of modules, as it is related to the user, we will be going inside this users, and inside of the controllers, let's create a new file called user dashboard.js. and inside of it and module.exports, right? Now this will have an access to request and response, and inside of it let's send a dummy response for now. So response.status 200, and then the JSON will be status hello from user register, right? Now let's save this and let's import this in our user routes. So navigate to user routes, and if the request is sent to user routes and the method is get and the URL is /dashboard, then the request will be handled by user dashboard, right? Now let's save this and let's try calling it from our postman. So navigate into the postman and duplicate this user login or register, and then our method will be the get method, right? And then the users /dashboard. Save, and in get we will not have the body. Now send the request. So we get the response hello from user register. Seems like we wrote user register instead of user dashboard, so let's change that as well. And also rename the new request to user dashboard. So now let's send the request again, and there you have it, hello from user dashboard. But this route should be a protected route. Without the user login, we cannot allow the user to access the user dashboard. So we need to protect this route, but before that, let's understand how we can authenticate the users for accessing the protected routes. So let's navigate into login.js, and in this part, we should be authenticating the users. So when the username and password matches and when the user is successfully logged in, we need to provide them with the SS token or the key that they can use for accessing the protected routes. And for creating the SS key, we will be using JWT or JSON Web Tokens. So let's go ahead and install JSON Web Token. So npm install JSON Web Token. So now let's import JSON Web Token into our login.js file. So const JSON Web Token equals to require JSON Web Token. Now before using JSON Web Token in our code, I want you to understand what is JSON Web Token and how authentication really works behind the scenes. So to make it easier for you to understand how authentication works and how JWT works, I have created a flowchart for you. So when user logins and if the login is successful, we will be generating an SS token using JWT. So the SS token created by JWT is like a virtual ID card. It will hold the information of the user that has successfully logged into our system. It can hold the information like user ID, name, and many other details that a general ID card would hold. And using that virtual ID card or SS token, a user can access the protected route or protected resources in our server. Now, in order to access the protected resources, every request must be passed through auth checker. Now, auth checker is like a security guard that is guarding the protected routes. And this auth checker will allow access to only those users who have a valid ID card or valid SS token. And if they do not have a SS token or a valid ID card, the request will be rejected and the user request cannot reach the protected routes. And this is how the total authentication system works, right? So let's go ahead and create a SS token from JWT. So in login.js, right above this response, we'll be writing const SS token equals to, and this JWT will have some delay in processing, so await JSON Web Token or JWT that I prefer calling it dot sign, and this sign method is used to create a valid ID card or valid virtual ID card for our users for authenticating them. So the first parameter will be the payload or the information contained inside that ID card. So for now we will be keeping, this will be an object, so underscore ID will be the get user dot underscore ID, right? And the name will be the get user dot name. So now we have created an ID card with an ID and name inside of it. We have engraved the ID and name in the ID card. Of course, it is a virtual ID card. Now the first parameter will be the data contained by the virtual ID, and the second parameter will be the secret key for verifying the ID card. So you can write any string over here. Let me write my secret key 123. Let's save this, and in the response we will be sending this SS token. So when user logs in and the login is successful, we will be sending this virtual ID that we just created in the response as well. So for that we will be sending SS token as the SS token that we have just created, right? So let's save this and let's try to log in from our Postman. So navigate into the user login, and then with the correct password, let's try to log in. So now you can see we have got the status message and the SS token. Now this SS token is like an virtual ID for accessing the protected routes. Now this SS token, this string that you see over here contains the information of the user, and the information it contains is the ID and the name of the user, and it is encrypted with our secret key. Now you can also decrypt this key and see the data is stored inside of it. So for that, copy this key and in your browser open jwt.io. So once you navigate into jwt.io, in encoded field paste your code over here, and here you will see the stored payload data inside of this SS token. Now you might be wondering, if it is this simple to view the encrypted code and see the data inside of the payload, can someone manipulate the data on their own and access somebody else's account? And the simple answer to that is no. And the reason is, the string that you see over here, the JWT created token or the SS token, is the combination of the payload data which has been encrypted using our secret key. Now they could still go ahead and make changes in the payload data. For instance, if I rename this to Chris, then the JWT token will be generated. But if they try to validate this JWT token or try to use this JSON token for authentication purpose, then the verification will fail. And the reason is, JWT will try to verify this data with our secret key, and it will find the differences between the strings. So it will know that the data has been modified, and it will throw an error of JWT verification failed. Thus, without knowing the secret key, a user cannot manipulate the data that is created by the JWT. So it is very important for us to safeguard this JWT secret key. So instead of hard coding it over here, we will move this to environment variables. So let's copy this, and then inside of env, we'll paste it on JWT underscore salt, right? And we'll be accessing inside of login using the process dot in environment variable dot JWT underscore salt. Let's save this now. So now that we have got SS token while successfully logging in, we can store this SS token somewhere and use this for sending requests in the protected routes. So in the next lesson, we will be learning to create an authentication handler, and we will verify the user JWT token and then allow them access in our protected routes. So I'll see you at the next lesson. In this lesson, we will be learning how we can create a protected route and how we can restrict unauthorized users from accessing the protected routes. So in this lesson, we will be working on authentication middleware. Before diving into the coding of authentication middleware, let's first understand what middleware is in Express. I promised you before that the middleware will have a separate section, and this is the part where we will be discussing about the middleware. So let's try to understand the middleware by using this simple flowchart. In the screen, you are able to see three blocks: function 1, function 2, and in between them there is another function which is the middleware. A middleware is a function that acts as a bridge between these two functions. The middleware over here will determine the flow of our code. It will determine whether the code will be sent to this function 2 or the request will be rejected right from the middleware itself. So it will control how the code flows. So in simple terms, we can say that middleware is a function that either restricts or allows the access to the function below it. In our case, we will be creating an authentication middleware that will handle whether the request that is coming from the client is to be sent to the protected routes or not. It will have all the validations including the JWT validation, and it will determine whether the request coming from the client is to be sent to the protected route or to the functions of a protected route, or to deny it or throw an exception. So let's go ahead and create an authentication middleware. For that, we will be creating a new folder that will be the middleware, and inside of it we'll be creating a new file called auth.js. This will be our authentication middleware. So const auth equals to an arrow function. This is a function after all. So module.exports and then the auth. Now before actually using it for the authentication, let's see how a middleware typically works, right? Now to show you how a middleware works, I'll be introducing a middleware in our user routes. So navigate into the file, and I'll be introducing this auth middleware right above this user dashboard. So right over here. So user routes dot, and for using the middleware we will be using the keyword called use, right? And we will be using the auth middleware, and import this from middleware/auth. And now we are using this auth as a middleware. Now everything below this line will be controlled by this authentication middleware. So when we send a request from a postman to this user dashboard, this authentication middleware will run first, and it will determine whether to send the request to this dashboard or not. So let's try that. In this authentication middleware, I'll be writing console.log and then hello from middleware. Right? Let me save this, and let's go into our postman, and then let's send a request to user dashboard. Now you can see that request keep on going and there is no response. Now if you see at the console, you can see that there is a message called hello from middleware. Now you can see that before this route, before we can reach this route, our authentication middleware is running, right? And this authentication middleware can control whether to send the request to this route or not. Now if you want to send a request to this route right before this, then you should be using the next functionality. So the things that we will be getting an SS in the middleware is request, response, and then next function, right? And if you want to send the code below this middleware, or if you want to release the request from the client below all the functionalities of the middleware, what you need to do is you need to pass the next function. You need to run the next function, and by doing next, you are allowing the code to move downwards. So if I go into this route again, if I send the request, you can see hello from the user dashboard, and also you will see hello from the middleware. So this middleware has run, and this middleware has allowed the SS of our code to move into this routes as well by using the next functionality. Now if you don't want the functions that are below this middleware to be executed, what you can do is you can simply throw an error over here. So throw can't do this now, and then let's comment this next, and let's try to send a request into the user dashboard. So you can see we are getting the error can't do this now, which is triggered by the middleware. The middleware has restricted our access to this user dashboard, right? And this is exactly the thing that we are trying to do. We are trying to run all the validations or authentication validations inside of this auth code, so that if the user is not authenticated, then we will restrict their access to the protected routes. So everything after this authentication middleware will be the protected routes, right? So now that we have an idea of what a middleware is and how it executes, let's look back into this app.js file. And this app.js file, we have been using the middleware. The middleware that we have been using in app.js are app.useExpress.json. This is also a middleware that has allowed us to access the JSON data from the payload. Another middleware that we are using here is the error handler. Now if you navigate inside the error handler, you can see that we are also running this next functionality here. So you can see here, if there is an error in this code, we are sending an error response, but if there is no error, we are allowing the code to move forward to all the routes or functions below this error handler, right? So we have been using middleware from a very long time, but we finally understand now what is middleware, and now we will be working on authentication middleware in the next lesson. So I'll see you there. In this lesson, we will be working on our authentication middleware. Now in previous lesson, I said that when a user logins, we will provide them with the SS token that acts as a virtual ID, right? And if they want to access the protected route, they need to send this SS token to every request. Now let's find a way to send this SS token in the request. So let's copy this SS token, and as our user dashboard will be the protected route, let's navigate into it, and we'll be sending our SS token in the authorization tab. So we'll not be sending our SS token in the body or any other place. We'll be sending it through the authorization headers. So navigate into this authorization, and in the type we'll be sending the bearer token or selecting the bearer token, and in this token we'll be writing the SS token that is provided by the user login, right? Let's save it, and now let's navigate into the auth.js, and then we will be seeing the headers that we are receiving from the request. So remove this code, and instead of this we will be consoling. So console.log request.headers, and this time we will not be reading the body, but we will be reading the headers, and our authorization or the SS token will be thrown or be provided at the headers. So let's console that, and we will be allowing to run this next functionality. So also allow this next, and again send the request. So let the server start, and after it started, send the request over again. So hello from user dashboard, and here you can see we have received the request.headers, and inside of request.headers there is an authorization key, and inside of this authorization key there is a string called bearer, and after this we have our SS token. So we need to take this SS token out of the request. In this authorization header, you can see that the string that it contains is the bearer and then the SS token. But if you look at the postman, we are only sending the SS token, right? But we are using the type authorization type bearer, so this bearer text will be automatically appended to this authorization header. So what we need to do is we need to take out this authorization SS token from this authorization. So what we can do is we can create a new variable called SS token. So const SS token equals to request.headers dot authorization, right? Let's console this, and let's send the request from postman again. And here you can see we are getting the SS token, but we still have this bearer, so we need to remove this bearer and white space from our SS token. So for that, what we can do is we can use dot replace, and then replace bearer and space with an empty string, right? So let's again console this SS log, SS token. So after the server has started, let me send the request, and then we have the actual SS token that is sent to us. So now that we have retrieved the SS token from the request headers, we can verify the SS token using the JWT verify method. So first, let's import the JWT or JSON Web Token. So const JSON Web Token equals to require JSON Web Token, right? Now we will take this and we will use this to verify our code. So const verification or JWT verification. JWT verification equals to JWT.verify or JSON Web Token dot verify, and then inside of it we will be having the token as an string. So our token is the SS token, right? And in the second parameter we will be having the private key, right, or the JSON token secret, and in our case process.env.jwt_salt, right? Now let's save this, and in this way we can verify whether the SS token provided by the client is actually the valid SS token or not. So let's console this JWT verification now, and let's remove this console log as well. So let's save this and let's try to send a request again. So let's go into our Postman and let's send the request. And you can see that this JWT verification has provided us with the data that is stored in the payload. Now if there was an error, or if you try to manipulate this, let me remove this last character from our JWT verification, JWT SS token. So let me remove this Y and let me send the request again. So if I send the request, it fails with invalid signature. So if anyone tries to edit or manipulate the data in SS token, then our JWT verification will fail. Now if the SS token is successful, then this JWT verification will hold the JWT payload, right? So let's rename this as JWT underscore payload, right? And let's save this and we'll be consoling JWT payload over here. So now if I send the correct correct SS token, then I can see that we have an JWT payload over here. If you see at the response of Postman, if the JWT verification failed, it's showing invalid signature. But instead of this, we'll be sending our own custom error. So for that, what we need to do is we need to wrap this with try catch. So try doing this, and if this throw an error, we will be catching it, and then we will be displaying our own error, and we will be displaying response.status, and this time we will be using the HTTP error status code 401, which means unauthorized, right? .json, and then inside of it status, and then failed. After this, message will be unauthorized, right? Now let's save this, and don't forget to write the return statement over here. Otherwise, your function will move downwards to this next and everything will be messed up. So let's remove this JWT as well, and let's try by sending the wrong SS token. So I believe this is a wrong SS token. So let's send the request, and here you can see we have an 401 unauthorized error and the message is showing unauthorized. So we are able to send the custom error by handling the invalid signature error, right? So now let's see what happens if I entirely remove this authorization. So no auth, and let me try sending the request. So you can see cannot read properties of undefined replace. So this error is being triggered by this SS token, in which we are not sending this authorization header for now. So this authorization is undefined, right? And this replace functionality cannot run on undefined. So it is throwing an exception, and not having authorization is also an unauthorized request, right? So let's move this code inside of this try block. Let's save this. And then now if I try to send a request without this authorization, I'll be getting the same error message. And it is because the JavaScript errors are also handled by this try and catch block. If there is any JavaScript error, then it will be handled by the catch block, and inside of the catch block we have written our custom error message. And another important thing this auth middleware should do is to pass this JWT payload in other functions that will be executed after it. So what we will be do is we will be using request.user equals to JWT underscore payload. Right? We are setting the request.user, we are creating a user object in the request itself, and it will have a value of JWT payload. So now that we have an object, user object in the request, all the routes after this auth middleware will be able to access the request.user object. So now let's go inside this user dashboard, and inside of this user dashboard, let's console request.user. And let's see if we are able to access this request.user object that is set by this auth middleware. So let's go into the user dashboard, and then let's use the bearer bearer token, right? And then let's modify this to make this correct, and then send the request. And you can see hello from the user dashboard. So if you look into the console, you can see that we are able to access this request.user object that was set by this auth middleware. So now that we have access of this virtual ID card in our routes or in our functions, we can show the relevant data to the users. So in the next lesson, we will be constructing the user dashboard. So I'll see you there. From this lesson onward, we'll be working on expense tracker pro functionalities. So now that we have an access to request.user object that is provided to us by this auth middleware, we can use that request.user object and then provide user with their own dashboard. So let's work on that. So now let's navigate into the user dashboard. So Command P or Control P and then user dashboard, right? So currently in our user dashboard, there is a response called arrow from user dashboard. So in user dashboard, we want to display the profile of the logged in user, right? So for that, what needs to be done is let's import the mongoose first because we will be running database operations here. So const mongoose require mongoose, right? And inside of this, we'll be working with the users model. So const users model equals to mongoose dot model and then the users, right? So now we will be querying our database to find the user that has logged in, and we will be displaying the user details over in our response. So for that, we need to detect the logged in user. And as you can see in our user route, this user dashboard is running after this auth, and this auth middleware is setting this request.user object as an JWT payload, right? So we will be able to access the request.user from our user dashboard, and inside of this request.user object we will have an ID of that user. So let's try to send the request and see what is inside of request.user again. So let's start up the server. So npm start. So from postman we will be sending a request to user dashboard. So hello from user dashboard, and in console you will be able to see the request.user object that is set by our auth middleware. So in this request.user object, we have an ID of logged in user, right? So we'll be querying our database with this key and value pair. So for that, what we can do is const get user equals to await, and as this is an await statement, this will be async, right? Await users model dot find one, because we are finding one ID only. So inside of it, we'll provide a condition that underscore ID in our database matches with the ID stored in this request.user object. So underscore ID equals to request.user.underscore ID. And we'll be sending this get user object in our response. So status will be success, right? And in data we'll be sending this get user object. So now let's try to send a request from postman again, and let's see the response. So let the server start, and after it started, let's send the request. And as you can see, we will be getting all the details related to that user from our database. Now in this response, we are getting all the data related to that user that is saved in our users model, right? But you can also see that we are also getting this password field and value. And it is very important that we do not send this type of critical data in the response. It might cause some security concerns, right? Although our password has been hashed using the bcrypt, but it is not recommended that we send any critical information in the response. So we need to filter out the data that is displayed in the response. So for that, what you can do is navigate into this user's dashboard, and then where we are running the query, we will be chaining this select function, right? And inside of the select, there will be a string, and the string will determine what type of data we will be needing in the response. So the field that we need are the name field, balance, right, and the email, and we will not be needing the password in this response, right? So now let's send the request again. So you can see that we are only getting this name, email, and balance field that we have declared in our select function, right? And this underscore ID is a unique identifier of the data, so this will always be displayed. So currently in our user model, we only have few fields, right? So it was easier for us to write this name, balance, and email. But in schema, there might be more than 100 fields, right? So writing each field one by one is a bit of a hassle. So what you can do is you can restrict some field, or you can not display some field by simply using minus and then the field name. And by doing this, you are excluding this password field from this query. Now if I send a request again, I can see that this password field has been excluded, but all other fields are being displayed. And if I want to exclude multiple fields, I can simply type those field name over here like this. So now we will not be seeing password and name of the data. So send. So you can see here name and password field has been excluded from the response. Now this will become handy when you are working with a model that has lot of schemas or lot of fields, right? But for now we will be only excluding this password field. So let's remove this. Now if you look into the response again, you can see that we have got this underscore id which will be always displayed, and then we are getting this underscore underscore v, which means the version of the data. If I made a changes to this data, then the version will be updated every time I make a change to this data, right? And this version checking is default feature of Mongoose, so leave it as it is. And like this version checker, there are other features of Mongoose as well. So I want you to navigate into this users model. So inside of models, users model, and in the second parameter, the first parameter will be the schema, right? And in the second parameter, if you provide timestamps equals to true, then Mongoose will automatically provide you with the created and updated date. So let's see how it's done. So let's try to create a new account. So navigate into the Postman, inside of users, user registration, and in user registration, we'll be creating a new account of Chris, right? And Chris, let's send this. So user registered successfully, and in MongoDB Compass, if you refresh this, you can see that Mongoose have added two new fields, created it and updated it. Now this will come in handy when you are trying to detect when the data is created and when the data is updated recently. So when we are creating the model, let's keep this timestamps true from now on, right? Now you might have noticed one thing, when we are logging in an account, we are getting the SS token, right? But when we are creating an account, we are not getting the SS token in the response. And typically when you register an account on website, you are automatically logged in, right? In most of the cases. So let's send the SS token from our registration route as well. And we'll be doing that in the next lesson. So I'll see you there. In our user registration API, you are not sending the SS token in the response. Typically when you create an account in a website, you are automatically logged in, right? So let's fix that. So let's navigate into the user registration page or register.js, and right above this user registered successfully, we will be sending the SS token by using JWT. So let's import JWT over here. So const JSON web token equals to require JSON web token, right? Now let's use this, but instead let's copy the code from this login. We are doing the same thing. So copy this and then paste it in register.js. And in this page, we do not have access to this get user because we are not finding any ID. Instead, we are creating the ID, right? So what you can do is you can assign this creation process a variable. So const created user equals to user model.create. Now this created user will hold the value of the user that is recently created. So we will be, instead of using this get user, we will be writing created user dot underscore id and created user dot name. Now let's save this and let's send this SS token in the response as well. So SS token is the SS token. So now let's create a new account. So our new account will be the name John, and the email will be john@gmail.com, and let's send the request. So the account is registered and we are getting the SS token over here. Now let's copy this SS token and paste this in jwt.io to see the virtual ID card of the user, right? So in jwt.io, let's paste this over here. And here we have a JWT payload of John. So now that we have an SS token of John, let's copy this, and using this SS token, we will be querying the user dashboard of John. So paste it over here and send the request. Now currently we only have one route that is protected, right? But when we are creating a transaction part, we will be having multiple route, and pasting this SS token every time in each route is a little bit of hassle for us, right? So let's create a new environment in Postman so that we can keep our variable and we can use those variable and reduce the task for copy and pasting every time. So go into this environment and let's create a new environment. We'll rename this as expense tracker pro env environment, right? And the first variable will be the URL as we learned previously. So URL will be http localhost 8000/API, because everything will start with the API in our end. So, and the second variable will be the SS token. In this SS token, let's paste this newly created SS token. So let me copy this and then paste it in our environment inside of ETP environment. So paste it over here and here as well. So save this, and now we'll be sending this SS token variable in request.header. So navigate into collection, but first change this environment to ETP environment. Save this and navigate into this user dashboard. And in user dashboard, instead of providing this string or this SS token, we will be using the dynamic variable called SS token. So two curly braces and then this SS token, and save this. Now by using this SS token from our environment variable, we are reducing our task of copy and pasting the SS token every time. Now if we have multiple protected routes, we can use the same SS token that is stored in the environment variable, and this will also help us when we are logging in different users. For instance, if I go to this user login and I log in this Alex, let me send the request. Now I have an SS token of Alex, right? So let me copy this and let me change this SS token to Alex. So paste this and also here paste this variable, right? So I do not need to change this SS token every time. This will have an updated value, right? So let's change this, and you can see that we have an SS token of Alex. Now if I log into John, I can simply copy this and then use it in the environment variable, right? And then all of my protected routes that needs request authorization header will be automatically logged in using the zone account. So this is very handy when we are working with multiple user logins or when we are trying to test login of different users, right? But it would be much easier if this SS token is automatically updated when user logins or register, right? So instead of updating this SS token every time, it will be easier if the postman does it for us. And this is how you do it. So in this user login request, go into the test tab, and in test we can write the code to manipulate the environment variable of our postman. So here what you can write is pm, meaning postman, dot environment dot set, and then the first parameter will be the key, so SS token. We are trying to update the SS token, and second variable will be the value, right? And the value that we want to save here is from the response, right? So now let's assess the response. So pm dot response, and this response will be on JSON format, so we need to run .json, right? JSON function, and then we will be assessing this variable from SS token from here. So SS token. Now let's save this and let's try to log in using the Alex account. So login, and this SS token has been updated in our environment as well. So navigate into user login again. So login with Alex account, right? And then go to user dashboard and send the request, and you will see Alex. Now let's try to modify using the Chris, zone, right? Save this, and this SS token will be automatically updated in the environment. So this user dashboard is using this SS token as a dynamic variable. So if I send the request, we will be getting the account details of John. And also we are sending SS token from this user registration. So let's copy the text of this user login. So copy this and paste it to this user registration as well in the test tab. So let's save this. And now if we create an account using this route, then the SS token, newly created SS token, will be automatically assigned in our environment. So let's go in body and let's try to create a new account. So the name would be Tom of a new account, and the email will be tom@gmail.com. And let's provide them with balance 5 and then send. And there you have it. We have an SS token over here, and this test script has overridden our SS token using the newly created SS token. So if I go to the user dashboard and if I send this request, you can see I am able to assess the login of this new user. So we have balance 5 and this account belongs to Tom. And this is how you create environment and run tests in an effective way. So from the next lesson, we will be working on the transaction module. So I'll see you there. In this lesson, we'll be working on JWT Manager for centralizing the JWT signing process. So if you look into the registration page and login page, you can see that at the end of this code we are using JWT to create an SS token, right? We are doing the same thing in login and register. Now if I want to keep some other field in the virtual ID card or the SS token, then I need to modify both the route login and register. So instead of doing this, what I want to do is I want to refactor it in a single code. I want to create a JWT manager and I want to centralize the JWT signing process. So for that, what I can do is I can create a new folder and name it as managers, right? And inside of managers, I'll be creating a new file and the file name will be jwt underscore or jwt manager.js, and inside of it const jwt manager equals to an arrow function and then module.exports jwt manager. So now let's copy this code from login, this JWT signing, and paste it over here, right? And I did a little mistake here. I got this JSON web token confused with another package. This JSON web token package do not need an await statement. It does not delay the process, so we will not be using await. And in this code we do not have access to this get user. So instead of get user, what we will do is we will be passing the user data while calling this function from other codes, and then we will be using this user as getting ID from the user and then name from the user, and this function will return the SS token, right? And as we are using this JSON web token over here, let's import this class as well. So const JSON web token equals to require JSON web token. Let's save this. So let's save this. And now we'll be modifying our JWT signing in login.js. So instead of SS token to be a JSON web token.sign function, what we'll do is we'll replace it by JWT manager and make sure it is imported from managers. And inside of it, we'll be passing the user account or user object. So in this case, this get user is the user object. So we'll be passing it over here, right? And then let's save this. Now what this does is this JWT manager will get an access to this get user or the user object, and it can get ID and name from that user. And I want to do the same with the registration process as well. So navigate into the register.js and replace this code with JWT manager, and let's import this here as well. So make sure it is imported. And then what I want to do is I want to pass this user object, and in this case this created user is the user object. So let's pass this and let's save the code, right? And by doing this we are centralizing our JWT signing process. Now the advantage of centralizing the process is if I want to introduce any variable over here, let's say if I want to include the balance in our JWT or virtual ID card, I can simply access user and inside of the user the balance key, right? I do not need to modify the JWT signing of login and register. So it is always recommended that you refactor the code that are being repeated in your code base. And by centralizing the JWT signing process in JWT manager, we are refactoring and writing less code and making our code more maintainable. And also we are maintaining consistency of SS token over login and register controller. So let's navigate into the Postman and let's try testing the updated code. So let's go to the user login, and we are currently logging in Zone. So we have an SS token. So let's go to the user dashboard, and here we have profile of Zone. Again to the login, and instead of Zone we will be writing Chris and logging in the Chris account. And then if I access the user dashboard, so everything seems to be fine on this user login. Let's go to the user registration, and this time we will be registering Bob. So Bob, and the email will be Bob. So let's send the request, and we have got the SS token. And if I navigate into user dashboard, and here we have the SS token of Bob and the user detail of Bob. So everything seems to be working fine, and our centralized JWT manager is also working fine. And let's see what data we are getting from the SS token. So go into the environment and let's copy this current value and then see it on jwt.io. So paste this over here, and here you can see the balance is also included, right? And now by centralizing our JWT signing process, if you want to introduce any variable, you can introduce it over here, and then login and register page will automatically include those in the SS token. And currently we do not want this balance over here, so let's remove this and save our file. And this is how you centralized your JWT signing process. And from the next lesson, we will be working on more functionalities of Expense Tracker Pro. So I'll see you there. So until now, we have learned how we can handle the user registration, user login, user authentication, and so much in between, right? And this completes our first module, the user module. And now we'll be working on the transaction module. But before that, let's have a visit at Expense Tracker Pro Blueprint. So here it is. We have completed the first module, the user module. We have worked on user login, user registration. We have worked on JWT authentication, and we have constructed the user dashboard. Currently in user dashboard, we are only displaying the balance and profile information. But after we have worked on this transaction module, we will also be showing the recent transaction in our dashboard, right? And with this, we have completed our first module, the user module, and it's time for us to develop the second module, the transactions module. And as you can see, all routes inside transaction module will be the protected route. We will only be allowing the users who log in or who has an SS token to get access to the income and expenses part. And all other requests without the authorization header will be handled by our auth middleware, and we will throw an exception of not authorized. And this is how we want to proceed. At first, we will be creating the transaction model so as to save the transactions, right? And then we will be working on adding income and expenses in that transactions. And then we will be querying the database for income and expenses related to that user. We will be adding all the income and expenses to get an aggregated view, and we will learn so much more in between. So I'll see you at the next lesson. So let's start working on transaction module. At first, we will be creating a transactions model so as to store the transaction data of our users, right? So let's go ahead and create transactions model. Now, instead of creating a new file, I will be replicating this. So copy paste and then rename it to transactions.model.js, right? So now let's remove these fields as we will not be needing this in transactions model. Now let's rename this users schema to transactions schema, and use this same schema over here, and our model name will be transactions, and this user model will be transactions model, right? And we will be exporting this over here. Now we will be constructing our fields over here. So the first thing that we will be needing in the transaction schema will be the user underscore ID. And this user ID in the transaction will hold the user ID that is inside of the users model. And the reason for it is transactions model and user model are interconnected. Only the users that are available in our users model will be able to create the transactions, right? So there needs to be a link between the transactions and users. And so we are using user underscore ID for denoting the user ID inside of our transactions model. So the type of this user ID will be mongoose.schema.types and then the object ID. Now instead of saving the user ID in transaction schema as a plain string, we will be using object ID type of mongoose, right? And also we need to provide a reference to the user model. So for that, next key will be reference, and inside of the reference will be our model of users. And this will be a required field, so required true. So by providing the reference, we are linking this user ID object with the user ID of users model, right? Now other fields that we will be needing in the transaction are the transaction amount. So this will be of type number, right? And it is also a required field, so required true. And the next field we will be needing is the transaction type. So transaction underscore type, and this will be of type string. And it will also be a required field, so required true, and then it can only hold the value of income or expense. So we will be saving either income or expense over here. So if you want to restrict this field for using only certain variables or certain values, then what you can do is you can use the enum. So in this field, I only want either income or expense, right? And if you try saving any data except income and expense, then it will throw an validation error. So the next field that we will be needing is the remarks. So we will want to ask the user what is this transaction about. So this will be of type string, and this will also be a required field, right? And the next thing that we'll be needing here is the transaction date and time to see when the transaction had occurred. But as we are using timestamps true, it is automatically created by Mongoose, so we do not need to write that. So I think our schema of transaction module is complete. So now let's initialize this transaction model in our app.js. So in this model part of app.js, we'll be requiring /model and then transactions.model. Now let's save this and let's start our server. So server is already running in my terminal. So if I navigate into the MongoDB compass and if I refresh this, I'll be able to see the transactions model or transaction collection over here. So now that we have our transaction model, let's go ahead and create some routes for handling the transactions. So I'll see you in the next lesson. So in this lesson, we'll be working on income handling functionality of Expense Tracker Pro. So in this part, when user logs in and then enters the income, it will have an effect on the balance of the user. Also, it will be creating a transaction record in the transactions model. So let's go ahead and create a add income route. So inside of these modules, add income is a part of a transactions, right? So we'll be working inside of this transaction module, but before creating a controller, let's create a route. So new file, transactions.routes.js. Now let's copy the code of user routes so that we do not have to write this all over again and paste it here. So now let's make some changes. We will not be needing this login and register and this dashboard as well, and also remove all the imports over here, right? And now let's rename this user routes to transaction routes. So Control D to have a multiple cursor. So transaction routes. And then I think we are done in this route. Now let's import this route in our app.js. So inside of this app.js, in the routes part, we'll be using app.use/API, which means localhost 8000/API, and then our module is transactions, right? So we'll be using transactions, and everything that lands through transactions will be handled by our transaction routes, right? Make sure this is imported. Now let's save this. Now in transaction route, let's create a controller. So for that, inside of this transaction module, new folder, controllers, and inside of it, we will be creating our first route, add income.js. Inside of it, const add income equals to an arrow function, and then module.exports add income, right? And this add income will have an access to request and response, and inside of this response.status 200.json status will be hello from add income, right? Let's save this and import this add income in the transaction routes. So if someone sends a request to transaction routes dot post using a post method, if someone access to add income, then our add income controller will be handling this request. Now let's save this and make sure you have not removed this authentication middleware from here, because all of the routes inside of this transaction will be protected, right? So if you remove this, this will be a public route, and then our add income will not be able to access request.user, so everything might fall apart, right? So now let's try to send a request to this add income using our postman. So navigate into postman and create a new folder inside of this expense tracker pro, because we are working on new module, right? So add folder, and this folder name will be transactions. Rename it to transactions, and then inside of it we'll be having an add income route. So let's copy this user dashboard, so we do not have to copy all this authorization logics. So copy this, as this is also a protected route, right? So inside of a transaction, paste it over here. So you'll have a user dashboard copy, rename that to add income, and this will be a post request. And inside of this authorization tab, we are sending a bearer token and then the SS token that will be saved by our environment variable, right? And here we will be changing our routes as well. So API/users instead of this, API/transactions, and then add income. Save this and let's start our server. So after the server is started, let's send the request. So as you can see, hello from add income. Now if I try to remove this authorization, no auth, then I will be getting the unauthorized error, right? Because we are using auth middleware in our transaction route. So let's work on this add income controller. So let's import mongoose first of all. Const mongoose, just to require mongoose. And then inside of it, we will be assessing the model, users model. It will be mongoose dot model users. And then we will also be assessing another model. So const transactions model equal to mongoose dot model transactions, right? Now make sure that this transaction matches with the name that is written in the transaction model. So we have these transactions over here, and so everything should work fine. Make sure that these are exactly the same, even a slightly spelling mistake. For instance, if I use transaction over here, then it will not work because this model is not available as transactions is initialized, not the transaction. So make sure you are maintaining the consistency. So let's save this. So now let's have a look. What are the things that we'll be needing in the payload from the request? So let's navigate into transaction model and let's see the fields. So we'll only be needing this amount and the remarks. This transaction type and user ID will be entered by our code. So now let's destructure the payload. So const, and then inside of it amount and the remarks, right? And this will be restructured from request.body. And then if there is no amount, then throw an error of amount is required, right? And if there is no remarks, then we will throw an error, remarks is required. And if the remarks dot length is less than 5, throw an exception. Remarks must be at least 5 characters long, right? Now let's modify this response as well. So in this we'll be writing success, and in message we'll be writing income added successfully, right? Now before using this database, let's see if our validations are working correctly. So let's send a request. So if I send a request without the payload, I should be sending this authorization. So bearer token and SS token. So send, and then amount is required. So navigate into body, and then it will be of JSON type. So inside of it, we'll be needing an amount key. Amount will be 100, right? And then the remarks will be hello. And this is a 5 characters, so everything should work fine. And here you can see income added successfully. But if I remove this and send the request, the remark must be at least 5 character long. And there is one more validation that needs to be done. This amount should always be in number. If I provide A, B, C over here we are getting the success response, but amount is not in the type number. So let's check for that validation as well. Now we could write the validation logic ourselves, but instead we will be using a simple package called the validator. This validator package is a lightweight package. It will help us check for different type of validation, like whether the value entered is number, is a valid email, is only characters, and so many different other validations, right? So to make our validation easier, let's import this package in our project. So let's close the server now, and then npm install validator. So let's import this validator in our add income. So const validator equals to require validator, right? And we are trying to check if the amount is a valid number. So to see all the validation option that is available in validator, we can navigate into this npm of validator, and we can access the documentation here. So we can check all of these different things. So currently we are needing is numeric, right? This function will check whether the value entered is numeric or not. So let's use this. So before using the validator, let's see how a validator responds. So console.log, and inside of it validator dot is numeric, right? And inside of it we will be sending the value. So amount dot to string. Now it is important to convert the value into string, because without the string this validator will not run. So make sure whenever you are using this validator, you must convert this value into the string first. So let's check the response of the validator. So save this and let's send the request from Postman. So send, and here you can see income error successfully, but in console you can see that validator has responded with false, because the ABC is not a number, right? So let's try sending a number. So let me send 1 2 3 and then send, and then you can see it has responded with true. So this means that this validator will respond with a boolean. So you can use this in this way. So if validator dot is numeric, and inside of it amount, and don't forget to do to string, right? And if this is not the case of it responds false, then meaning that it is not a numeric. So throw an error, amount must be a number, or amount must be a valid number, right? Now let's remove this and then save again. So send the request. If I do 1 2 3, then income added successfully, but if I try to send A B C or anything like that, then amount must be a valid number. So now let's start working with database. So first thing that we want to do is we want to create a record in transactions. So await transactions model that create, and we'll be sending the creation object over here, and the field that we'll be needing is, let's have a look at this transaction.model user ID. Now the user ID we will be getting from request.user, as this is provided by authentication middleware, right? Dot underscore ID. And by doing this, we are trying to assign this created transaction to this user, right? Now the second field that we will be needing is the amount. So amount will be the amount from our payload, and the remarks will be the remarks from the payload, and then the transaction type will be the income, right? Transaction type will be the income. As the user is navigating through add income route, so the transaction type is income. So let's save this and let's try to send a request from the postman. So remarks is received from a friend, right? And the amount is 100. Let's send the request. And here you can see income added successfully. Now navigate into MongoDB Compass and refresh this page. And you can see that a new transaction is created, and this transaction belongs to this user only. By keeping this user ID in transaction, we will be able to determine which user has performed this transaction. And it will help us link the user with transactions. So let's see to which user this transaction belongs to. So open a new tab, and in this tab we will be opening the users. So we'll have a users open here and then transactions open here. So double click this user ID and you will be able to copy this. Now navigate into this users tab, and by using this filter you can search for that particular user. Now by using this filter you can search for any data in this model. For instance, if you want to see only those users whose balance is 100, then what you can do is provide an condition object over here. So inside of this object we will be writing balance and then the value. So click at find. So here we are only getting the data whose balance is 100. You can also provide multiple conditions over here. For instance, if you want the balance 100 and name to be Alex, then you will be getting the required data only, right? So we are trying to search for this user ID in this users tab, right? So what you can do is open an object, and then inside of it you want to write underscore ID, and you cannot simply paste this over here because this will be treated as a string, but this is an object ID, right? So you need to wrap this copied string with object ID. So object ID, and inside of this you need to provide this object ID and then find. So this transaction belongs to Bob. So this is how you use the filter option. So you might have noticed that while creating this Bob account, we provided Bob with balance 5, right? But we added an income in the Bob account of 100, but it is not updated in the balance of Bob. So for adding the balance when an income is entered, what we can do is we can run another query which will update the data of users model. So navigate into this add income, and after the transaction is created, what you can do is await, then users model dot update one, right? And the first parameter will be the condition. So underscore ID will be the request dot user dot underscore ID, right? And then in second parameter, we'll be providing the data to update. So in this, you cannot simply write balance equals to amount, because this will update the balance to this new amount, but we are adding the income, right? We are trying to add a certain amount in the existing balance, right? But this will replace the balance. So what we can do is we can use an operation called inc means increment, and we'll be passing an object over here that needs to be increased. So in our case, balance, and balance will be increased by the amount. And this is how you add a data to the number field in database, right? And in the third parameter, don't ever forget to include run validators true, because without it, the validation in schema will not work. So let's save this, and now let's try to add an income to Bob account. So go into the add income tab, and then this time we will be adding only 10. So the expected balance will be 15, right? So send the request, and it is received from friend. Now it will create a transaction in this collection. So you can see the new transaction with amount 10, and if you refresh this, then you can see the balance of Bob have been updated to 15. And this is how you work with multiple models in a single file. And this completes our add income route, and in the next lesson we will be working on add expense. So I'll see you at the next lesson. In this lesson we'll be working on add expense functionality. So whenever user adds an expense, it will have a negative impact on the balance, right? And it will create a transaction data with a transaction type expense. So let's start working on it. In modules inside of the transaction, let's duplicate this add income. So copy paste, and then rename it to add expense, right? Now let's rename this add income to add expense. So we have add income over here and then here. So select it and Control D to have multiple cursors. So add expense, right? And all the validation will work as it is. And in this part, we will be renaming this income to expense. Now in this query, what we are doing is we are finding this user ID, and then we are adding a balance into it, right? But in Mongoose or MongoDB, there is no operator like decrease. We have increment, but we do not have decrement. So there is a workaround. What we need to do is we need to multiply this amount by -1. By doing this, we are subtracting the amount from the original balance. And let's name this to expense, added successfully. And now let's include this add expense controller in the transactions route. So if someone sends a request, post request to add expense, then our add expense will handle it, right? Now let's go into the postman and create a new route. So duplicate this add income and then rename it to add expense, right? And the route URL will be add expense. Save this and go into the body, and let's modify our payload. And as this is an expense, let's change this. So let the amount be 10 and the expense type be movie ticket, right? Let's save this, and if we send the request, we should be able to see that the balance will be updated to 5 because we are deducting 10 from our Bob account, right? So send, and then expenses added successfully. And then if you refresh this, you'll be able to see 5, and it will also create an entry in transactions. And if you click at find, you will be seeing this, and this is a transaction type expense, and the amount is 10, which has successfully been deducted from the balance of Bob. So what if I send minus in the expense? So navigate into Postman and let me try sending -10 from here. So send the request, and here you can see that the expense have increased the balance, but this is not accepted. Expenses should not be able to increase the balance. It has increased because minus and minus is plus, right? So we should not be accepting the negative value in expense and also in income. So let's fix that. So navigate into the add expense and let's validate. So if amount is less than 1, then throw an error, or 0, throw an error. We are not allowing the negative. So amount must not be negative. right? And let's copy this validation and paste it in our add income as well. So we are taking only the positive amount, and in income we are adding it, and in expense we are deducting it. And this is how it's done. So let's send the request again. And here you can see amount must not be in negative. Expense is negative, but we are deducting it in our code itself. So we are not allowing user to send the negative value. And this completes the adding of income and expense. And in the next lesson, we'll be working on getting income and expenses using a get method. So I'll see you at the next lesson. In this lesson, we'll be working on getting transactions of the user. Now we won't be creating get income and get expenses separately, but we will be creating one route called get transactions, and then we'll be using query string parameters for getting the desired value. So in this lesson, you'll also be able to learn query string parameters. So let's get started. So let's create a route called get transaction inside of the transaction module. So inside of controllers, new file, get transactions.js. So inside of it, const get transactions equals to an arrow function, and module dot exports get transactions. Let it be transactions, and then this transaction will have access to request and response. And currently we will be sending rest.status 200.json and then status transactions only for now. Now let's import this module in our transaction route. So if someone sends a request to /transactions using the get method, then it will be handled by get transactions. Right? Let's save this and let's create a new route in our postman. Navigate into the postman, and inside of this transaction module, let's copy this add expense, and now let's rename this to get transactions, and this will be of get method. There will be no body, but there will be an authorization header over here because this is a protected route. And let's change the URL to transactions. So API transaction/transactions. So instead of using this transactions, I'll be using only slash. So if someone send a request to only /transaction without anything, right? Only /transaction, then it will be handled by get transaction. So we can modify our request URL to only transaction. So if someone sends a get request to this URL, our get all transactions will be triggered. So now let's work on get transaction. Let's start by importing mongoose. So const mongoose, first to require mongoose, right? And we'll be working on the transaction model. So const transaction model equals to mongoose dot model and then transactions, right? Let's save this. In the next line, we'll be creating a variable of get transaction, or let's simply write transactions only, right? And then it will be await. So need to use async here, and await transaction model dot find, and this time we will not be running find one because we are trying to get all the data inside of the transaction model, but we need to send a condition. We need to write a condition that this transaction will be only showing the transaction to the user that is logged in, because transaction is created by a specific user, right? So we'll be writing user underscore id, and it will be on our request.user.underscore id from our JWT authentication or auth middleware, right? So let's send this over to our data. So data will be the transactions, right? And let's modify this transaction to success. Let's save this and let's try to send a request. Now if I send a request over here, you can see that I am getting all the transaction related to a specific user. You can see that in user ID there is an ID called FOFOAC at the last, and this all transaction belong to a single user because we are providing a condition in which we are writing user ID must belong to the one that has logged in, right? Now by using this get transactions endpoint, we will be able to view all the transactions related to a specific user or the user that has logged in, right? But what if I only want to see the income, or what if I only want to see the expense over here? So this can be achieved by creating two other routes, get income and get expenses. So we will have total of 3 routes that will query the transaction model, but it is not an ideal way for getting the data. Instead, we will be asking the server to filter out the data and provide a response to us. So if I want to see only the expense or the income, I should be able to query a server and ask the server to provide me with the relevant data. So we can use query string parameter for communicating with an API endpoint. The query string parameter can be used by the client to communicate with the server and to provide additional information in each request. And this is how we can use it. If I want only the income to be displayed, then I can ask the server by providing the additional information that I am trying to see only the income. So I can write question mark and transaction type equals to income. And by doing this, I am sending additional information to the API endpoint using query string parameter. And we do not need to create an additional route for this query string parameter. This API/transaction that you see over here are called the path parameters. These needs to be declared in the routes, right? These are the resource allocator, but these are called the query string parameter, and these are used to only send additional data to the server or to communicate with an API endpoint. And in this way, a client can communicate with an API endpoint to send the specific data. Now let's send the request, and the response has not changed. Our client is trying to communicate with the API endpoint, but we have not written a logic in API endpoint to handle the request of the client. So let's go ahead and modify our get transaction route. So to assess the query string parameter, what you can do is you can look for request.query. For JSON payload, we are doing request.body. For parameters, we are doing request.params, and for the query string parameters, we will be looking for request.query. Now let's send this request again. And in console, you can see that we are getting an object with key transaction type equals to income, which is being sent by our client. Now we can read this and we can filter the data accordingly. So you can see that we will be getting this request.query in an object type, right? So what we can do is we can simply spread this object in our pipeline. So for doing that, what we can do is 3 dots and then request.query. So if you are not familiar with this spread operator, what this spread operator does is it takes out all the contents that is inside of the object and it will populate it right here. So when we are doing this, spreading this request.query, we are simply writing this. Let's copy this and let's paste it over here. So it will take out this transaction type income and then it will populate it in this manner. And this is done by the spread operator. And if you want more information about spread operator, you can always search for it. So let's try sending the request again. So transaction type equals to income and send the request. And here you can see we are only getting the data related to an income. If I send the expense, then I am only getting the expense, right? And if I do not provide anything, then I will be getting all the transactions related to this user. And you can also send multiple query string parameters in a single URL. For instance, I want transaction underscore type to be expense. Let me send this first. And also I want this amount to be 10. So I can use and amount equals to 10. And now I'll be only getting the data which transaction type is expense and the amount is 10. So in this way, using the query string parameter, a client can communicate with an API endpoint and request for the certain data to be filtered, displayed, or to be processed. And by using the query string parameter, we are querying a same API endpoint to get different responses. And this will save us a lot of time when working with larger projects. So in the next lesson, we will be keeping some of the transaction in our user dashboard as well. We are currently only displaying the profile of the user. Now we will be adding the transaction data in the response too. So I'll see you at the next lesson. So in this lesson, we will be working on user dashboard for displaying the latest 5 transactions. So let's open up our user dashboard, Command P or Control P, and then user dashboard, right? Currently, we are only sending the user data in the response. Now let's send the transactions in the response as well. So const transaction model equals to mongoose dot model and then transactions, right? Now we will be running another function. So const transactions equals to await and then transaction model dot find, and the condition will be user underscore id equals to request dot user dot underscore id. Now let's send this transaction over to the response. And here is a simple tip to save your time. If the object key and the variable of the value is the same, then you can write it in this way. You can completely remove this, and writing in this way means doing the same thing like this. And doing this will save you a lot of time. So let's remove this. We should have done this before, but better late than never, right? So now let's send a request to user dashboard to see the response. So user dashboard and send the request. And here you can see we have a transactions key, and inside of the transaction we have an array of all the transactions related to that user. Now if you have a look at this transaction response, you can see that the recent data or the recent transaction data is displayed at the end. But we want this data to be displayed in the front in an ascending order, right? So you can use the sort function in the find query as well. Previously we did select, but now we can also use the sort. So dot sort, and then you need to type the field for sorting. In our case, it will be the created date, this data that is automatically created by Mongoose, and you will be using this data to display in a descending order. And for the descending order, you should keep dash or minus at the front. If you want the data to be sorted in an ascending order, you can only write the field name, but if you want it in a descending order, then you can include this minus or dash at the front. So let's save this and let's see the response. So send the response again, and our data is sorted by created date in a descending order. And currently we are displaying all the transactions related to that user, but in our API dashboard we should be only displaying the 5 recent results, right? So we need to limit the results. So for limiting the result, what we can do is we can use dot limit and then the limit or the maximum limit of the response. So if I want to show only 2 results, then I'll be writing 2, and I'll be getting the results of recently created 2 data because it is sorted by created date and limit 2. So let me send the request again. And here you can see I have only got 2 data and in a descending order by created date field. So let's modify this limiter to 5 so that we can have at least 5 responses in this transaction. Let's send the request again. And there you have it, 5 transactions sorted in a descending order by created date field. And this completes our user dashboard. So I'll be seeing you in the next lesson where we will be adding more features on our Expense Tracker Pro. So I'll see you there. In this lesson, we'll be working on sending emails from our NodeJS app. Initially, we'll be sending a welcome email when a user registers, and then we'll be working on other functionalities as well. And we'll be using Node Mailer for sending email from our NodeJS app. This Node Mailer package is not only for the development and testing email, it can be used in a real world application for sending the emails as well. So by learning to use Node Mailer, you are also getting prepared for building a real world applications. So let's go ahead and install Node Mailer in our project. New terminal and then npm install node mailer. Now by installing the node mailer, we are ready to send email from our Node.js app. But to send an email, you must need a domain. Without domain, you will not be able to send email, and the domain also need to be configured for sending an email. As of now, many of us might not have a domain or the mail server, so we will be using Mailtrap for testing our email. A mail trap is a free tool that the developers can use to test the email. It provides a simulated environment where developer can test emails without sending it to the real recipients. So let's sign up for mail trap and let's see how it works. So click at sign up. You can create your free account using Google or your email address. And after registering, you will be provided with your dashboard, right? And inside of this email testing, you can see the inbox, and every email that is triggered from our Node.js app, you will be able to see it over here in my inbox, right? So in this page, you will be able to see the code for integrating this mail trap in our node mailer. So you can change this integration from call to node mailer. So it is available here. So now let's copy this code and open up our register.js page. So navigate into register.js and let's import node mailer over here. So const node mailer equals to require node mailer, right? Now let's navigate into end where user has successfully registered, and here we will paste our code. Now we need to replace this username and password with our real credentials. So for that, again navigate into mail trap and click at show credentials. Now copy this username. We might already have a username, but paste it here just in case, and then copy your password and then paste it over here, right? Now by doing this, we have created our transporter. Transporter is like a configuration for the node mailer for sending the email. So now that we have our node mailer transport configured, let's use it for sending the email. So transport dot send mail, and inside of it will be an object that will contain the details of the email. So first key will be the to, and it will be the receiver. So receiver will be created user dot email, right? Because we are taking the email and storing it in the email variable, right? So created user dot email, and second will be the sender. And this sender field, if you are using on a production environment and if you have our own domain and mailbox, then we will be using the sender email as an authenticated sender or our own domain or that exists, right? But as you are using mail trap or simulator, we can use anything here. Let me write info@expensetracker.com, and the next option will be the text, the body of an email. So welcome to Expense Tracker Pro. We hope you can manage your expenses easily from our platform, right? And we'll have a subject, and subject will be welcome to Expense Tracker Pro. So let's save this and make sure that this await statement is used here. Also, we made a slight mistake over here. The sender should be replaced with from. So to and from, right? And this from is the sender. So now let's create a new account from our Postman. So navigate into the user registration page, modify the payload, and then send the request. So the account has been successfully registered. Now let's see in our mail trap. So you can see that we have received an email, and this email was sent to mike@gmail.com, the one who has registered an account, and it was from info@expensetracker.com. And this email is not exactly sent to mike@gmail.com. This mail trap service will trap all the email and list it in the mail trap dashboard. So here you can see we are only receiving the plain text. If you want to send the HTML email, then you can simply create a key called HTML and place your HTML over here. Now some email provider do not render HTML, and if the email provider could not render HTML while showing the email, then they will fall back to this text. So it is generally necessary to have this text as well. So let's copy paste over here, and let's change this to H1 and these to H1 as well, and then a little bit of space, right? And now let's try creating another account. So navigating into the Postman, let's change the payload and send the request. Now this email will be sent to tommy@gmail.com, but our mail trap will trap all the email, right? So account registered successfully. Now navigate into the mail trap, and here you can see a new email, and here you can see the HTML content that we just wrote. And this is how you work with email system in Node.js. And in the next lesson, we will be working on password resetting functionality in our Expense Tracker Pro. So I'll see you at the next lesson. So eventually our users might forget the login password, right? So we need to create a reset password functionality. And for the reset password functionality, we need to create two routes. The first route will be the forgot password route, and second one will be the reset password. In the forgot password route, we will get an email address from our client and then send the reset code over to the email. And in the reset password route, we will be resetting the actual password. So let's start working on it. So for that, let's navigate into the modules, and the reset password and forgot password are the functions of users module, right? So let's create our forgot password route inside of this users controller. So new file, forgot password.js, and here const forgot password goes to an arrow function, and then module.exports forgot password, and this will have an SS2 request and response, right? And now let's send in response status 200, and then JSON status forgot password. And as we will be using mongoose here, so let's import mongoose as well. So const mongoose equals to require mongoose. And as we will be working with users model, let's import that as well. So const users model equals to mongoose dot model users, right? So let's save this code and navigate into user route so that we can import this forgot password. And this forgot password will be the public route because user will not be authenticated if they forget the password, right? So we'll be writing here user routes dot post. If there is a post request and the URL is forgot password, then our forgot password functionality will be triggered. So let's save this and let's create a route in the Postman. So let's duplicate this user login, and then this will be the forgot password, right? And here it will be forgot. Let's see the link. So forgot PW password only. So forgot PW password, and then let's remove the test from here because we will not be getting the SS token, right? And in the body we will be sending the email to send the reset code to, right? So in this route the user will land and they will provide their email address, and we will be sending the reset code to this email address. So let's try sending the request. So forgot password link or forgot password controller is triggered. Now in JSON payload in body we have an email, so let's access that. So in forgot password, so const email is request.body, deconstructing this, and if email is not provided, then throw email is required, right? And now we need to check if the user exists in our database. So const get user equals to await, and then users model dot find one, and then inside of it we'll be writing our condition email matches the email that is entered by the user, right? And this will be async, and then if there is no user, then we'll throw an exception. This email does not exist in the system, right? Let's save this, and in the status let's write reset code sent to email successfully. We are not sending it right now, but let's send this anyway. And let's see if I try to enter an invalid email or that doesn't exist in our database, whether it will trigger this error or not. So navigate into the Postman again, and let me write Chris222, this email does not exist in the database, and if I send it, failed, this email does not exist in the system. Now if I send Mike over here, then you can see reset code sent to email successfully. So let's write the functionality for it now. So I can navigate into forgot password, and up to here the user has provided their email address, and if the email address exists, then we need to create a reset code and we need to save that in the user's data. So for that, what you need to do is you need to navigate into these models, and inside the user model, let's create a new field, and that field will be the reset underscore code, right? And this reset code will be of type number. Currently we will be sending number, right? And then it is not required, it is only conditional, because if someone comes into this forgot password and provide their email, then only we will be setting this reset code, right? Now let's navigate into forgot password again, and now let's construct our reset code. So const reset code equals to, and this is the function for creating 5 random digit in numbers. So we are creating a reset code. Now we need to save this reset code in the users model for this email address. So what we can simply do is await, then users model dot update one, right? And inside of it, the condition will be email equals to email, and this will be the condition for finding that user. And secondly, we will be setting the reset underscore code to the reset code, right? And then we will be using run validators true. Let's save this, and then let's write our email sending code over here, right? So navigate into this register.js and copy this from transport everything and paste it over here, and don't forget to import this node mailer. So at the top of our page, const node mailer equals to require node mailer, right? And now we will be sending an email to created, no, there is no created user, so we will be sending an email to get user.email, or simply email, because we are getting the email from the payload, right? So email, and then from info at the expense tracker, it's completely fine. And let's replace this text to your password reset code is, and then plus reset code that we just generated over here, right? It's here. So we are sending your password reset code is reset code, and let's send this same in our HTML as well. And the subject will be reset your password expense tracker pro, right? Let's save this, and now let's try sending the reset code into our email address. So navigate into the postman, and then let's send the email. So we are sending an email, password reset email to mike@gmail.com. So reset email is sent successfully. Now if you have a look at this mail trap, you can see that we have got our password reset link or password reset code, and here we have our password reset code 42661, and this code should be saved in our user database as well. So let's navigate into our users model, and then let's refresh this page, and let's find mike@gmail.com. So email equals to mike@gmail.com, and then find, and there you have your reset code. Now this reset code is sent to the email address and is saved in the user database. Now we will be using this reset code to reset the password. So we will be working on this reset section in our next lesson, and I'll see you there. So in this lesson, we will be working on reset password functionality. Once we have sent the reset code to the user's email address, we will be using this reset code to reset password and to detect that user is entering the correct reset code from their email. So for that, let's create a new route, and then reset password.js, and this will have const reset password, and then module.exports to reset password, right? And this will have an access to request and response. Also we will be needing mongoose over here, so const mongoose equals to require mongoose, right? And inside of it we'll be writing rest.status 200 .json and then status reset password, right? Now we'll also be needing the users model. So const users model equal to mongoose dot model and then users. Now we will be needing three different things from the payload: the email address, the reset code, and then the new password. So const email, new password, and then the reset underscore code from request.body. Before writing the logic, let's import this reset password in our user route. So copy this and paste it over here, and we will only rename this to reset password, and then this will be handled by reset password, right? And the post request is the same. Now navigate into the post main, duplicate this, and then rename it to reset password, right? And in the body we need to send the email address, the reset code, right, and then the new password, right? Let's save this and let's trigger this. So our URL will be the reset password, and let's trigger this, and you can see we are landing at this reset password. So now that we have email address, we will be able to search for that user. So in the reset password, what you need to do is we need to check some validation first. So if email is not provided, throw email is required. If new password is not provided, please provide password or new password, right? And reset code, sorry. If there is no reset code, throw reset code is required, right? And if new password dot length is less than 5, then throw password must be at least 5 characters long, right? And now let's check if this email address and the reset code that they provided exists. So const get user with reset code. So await users model dot find one, and this time we will be using two variables for finding. The first one will be the email, and that will be the variable from our request.body, and second will be the reset code that we derive from payload, right? And as this is await, this will be an async function, right? Let's save this, and if we could not find this, then simply we will return or we will throw an exception: reset code does not match, right? Now we don't need to check the user first and then the reset code, right? Because it will not be necessary, as we are checking the email address and reset code at once. Now if this does not match, if the email address and reset code does not match, then we will throw an exception. But if it matches, what we want to do is await and then users model dot update one, and in condition we will be writing email is the email, because if it is correct, then this email address is valid, right? And in the second parameter we will be writing password is the new password, but we will be encrypting that. So const, let's import bcrypt, but instead of that, let's go into this register and bring back all the code of encrypting. So copy this hashed password and then go into the reset password, paste it over here, import this bcrypt. So const bcrypt equals to require bcrypt, right? And then we will be saving this hashed password in the password, and don't ever forget to use run validators. true. Save this, and if everything goes right over here, then we'll be writing password is changed or resetted. Password resetted successfully, if that is the word, resetted. So let's save this, and this will be the message, not the status, and status will be success, right? Now let's try to execute this request from our postman. So here the email address is, let's head back into this mongoose and find mike@gmail.com. So Mike was trying to reset an password, so the email will be mike@gmail.com. So in the postman, email address is mike@gmail.com, and the reset code is 42661, and the new password will be 12345550, right? Let's save this, but first let's try entering the incorrect reset code. So send the request, and you can see reset code does not match, but if I send the correct code, you can see password is not defined. So we made a little mistake in our code. So in this hashing we are providing password, but the variables will be new password. So let's send it over here, let's save it, and then let's send the request over again. So send the request, and then the password has been resetted successfully. Now let's head back to this user login, and let's try to log in Mike with the old password 12356. Let's try to log in, and the email and password do not match. But if I try 12345 and then send the request, and the user is logged in successfully. Now after the user has reset the password, we should be removing this reset password, because if we set this reset password or do not remove the reset password, then the user can reset the password over and over again. Like if I type 11111 and if I send, then I can reset the password using the same reset code every time. So let's reset this, remove this reset code from the database. So we will be updating multiple things. So password will be hashed password, and the reset underscore password reset code will be an empty string. So now let's save this, and let's try to reset the password once again. So let's use the reset code for now and send the request. And there you have it, our password is resetted successfully, right? Now again navigate into this and click at find, and you can see the reset code is null. Now the user will not be able to send the same request with the same reset code and password reset again. They need to request for a new password. So they need to go to the forgot password, send a new reset code, and once the reset code is sent, they will be receiving that reset code in the email address. So new reset code is 14822. If you refresh it, here is 14822, and using this reset code, user can reset the email again. And this is how forgot and reset password works, right? Now it is generally a good approach to send a notification to the email address if the password is reset, right? So we will be sending an email notifying them that the password has been reset. And now let's send the email. Now for sending the email, you should be again copying this code and then pasting over there, but we are repeating this code over and over again. So we need to create a new file and then refactor this, and for that we will be using the email manager, and we'll centralize our email sending logic so that we still keep on following the philosophy DRY, do not repeat yourself. So I'll see you at the next lesson where we will refactor the email sending logic in one page. We'll create a manager for that, like the JWT manager, and then we'll be sending the notification email when user resets the password. So I'll see you at the next lesson. In this lesson, we'll be refactoring our email sending logic and centralizing it in one place like a JWT manager. We are doing this because we are repeating our code, email sending code over and over again. So let's create a new file inside of the manager. So we'll be naming this email manager. So email manager.js, and inside of it const email manager, right? And it will be an arrow function, and then module.exports, and then the email manager, right? Let's save this. Now let's go into this register.js and copy all of this code and then paste it in the email manager, inside of the email manager, right? And as we are using this await function statement, this function should be async, right? And the dynamic things that we need in this function is toString. So instead of using to from here, let's write to and use to over here. And another is from, and this from string will always be the same in most of the cases. If not, you can provide this from here. And then this text is always dynamic, and then HTML is always dynamic as well, and this subject is dynamic. So let's remove all of this. So from is as it is, and the text will be text, and the HTML will be HTML, and then the subject will become subject, right? It will all take the values from the function itself. Now let's save this. You have missed a comma here. Now let's save this and let's use this email manager in register. So right below this, what you will be doing is, as this is an async function, right? As this email manager is async, we'll be needing an await statement. So await, then email manager, and then inside of this email manager, we'll be having to. So our to is created user.email, right? And our from is inside of this, so we do not need to pass this from, and the text will be this, right? And then the HTML will be this one, right? And then the subject will be welcome to Expense Tracker Pro. Now let's paste this. Now you can remove all of these code from here. And also you can remove this node mailer and JSON web token from here that are not used, right? So now let's save this code. So we will be doing the same with the reset password as well. So in forgot password where we are sending the email. So instead of this, we will be writing await, then email manager, and inside of it will be the to. So to will be the email, right? And then the text, this will be our text, and this will be our HTML, right? And our subject will be reset your password. Now you can remove all of this as well, and also remove this node mailer require. So let's save this. Now we are controlling our email sending logic from one page, email manager. And if you ever go into the production of this Node.js app, then you can use the production details here, and you are ready to send email if you are using it from many pages. So it is always a good approach to centralize your logic using a manager if you are repeating it in many different places, right? So let's test this and see if everything is working fine. So navigate into the Postman and let's send the forgot password again. So send this request mike@gmail.com, and email manager is not defined. So we have not imported this email manager. So let's go into this forgot password and import this. So at the end, ctrl space and email manager. Make sure you are importing this, and also have a look at this register. Let's import this email manager as well, and let's save this and let's send the request over again. So once the server is started, send the request, and we are sending this email reset request to mike@gmail.com. So node mailer is not defined, another mistake. So another mistake is we have not defined node mailer inside of this email manager. That's a silly mistake now. So const node mailer equals to require node mailer, right? Let's save this, and now we can finally send the forgot password email. So in the Postman, and then send the request, and the reset code is sent successfully. Let's see in our mail trap. So here is the reset password. So the reset password code is 13397. So have a look, 13397, right? So let's use this 13397, copy it, and then go to this reset password and then paste it over here, and our new password will be 55555. But before sending the request, we'll be writing an email on this part reset password as well. So await and then email manager, right? Then inside of it, the first will be the to, so we'll be sending the email to email, right? And then the text will be your password is resetted successfully. If you have not done that, please contact us, right? And the HTML will be the same, right? And then the subject will be password reset successfully. Let's save this and let's try to reset our password. So again in the postman, and then let's send the request. So the password resetted successfully, and let's navigate into mail trap, and you can see we have received a notification email that says your password is resetted successfully and you have not done that, please contact us. And it is a good approach to send the notification email when user resets the password. So this completes our reset password logic. Now it's time for us to deploy our Node.js app in the server, in the live server actually. But before that, we need to add some security measures, or we need to add some of the things or some of the packages for deploying it live. So in the next lesson, we will be looking into these steps. So I'll see you at the next lesson. In this lesson, we will be working on delete transaction functionality. When user enters income or expenses by mistake, they need to be able to delete it, right? So we'll be working on delete transaction functionality for now. And then in the next lesson, we'll be working on edit transaction functionality as well. So let's get started by creating a delete transaction functionality, and it will be inside the transactions module. So expand this module, transactions controller, and then let's create a new file. So delete transaction.js, and inside of it, let's create a new function. So const delete transaction equals to an arrow function. So module exports delete transaction, right? So we'll be needing mongoose here. So const mongoose equals to require mongoose, and then we'll be working on transaction model. So const transaction model equals to mongoose.model transactions, right? Now we'll be having an access to request and response. So here response.status 200.json and status deleted successfully, right? Now let's link this delete transaction to our transaction route. So if someone sends a request to transaction routes the delete method, so in delete we'll be receiving transaction ID from user. So inside of it slash and then colon and then transaction ID, because it will be a dynamic ID, right? And this route will be handled by delete transaction. Now let's save this. And now let's create a route in our postman for deleting the transaction. So inside of this transaction module, let's duplicate this, add expense, and then rename it to delete transaction, right? And it will be of delete method and API slash transaction and then the transaction ID. So let me write ID for now. And in delete method, we do not have body, right? Body is not accepted in delete method, but we will be sending the authorization. Otherwise, we will be getting an error. So let's try sending this request. So we might not have started the server. So npm start. And after the server is started, let's send the request again. So here we have the response deleted successfully. Now let's write some logic in delete transaction. So the user will be providing the transaction ID in the params, right? So let's destructure the params. So const transaction underscore ID will be available from request.params. Now once we have got the transaction ID from user, let's check this transaction ID. So const get transaction equals to await transaction model dot find one, and inside of it the condition. So underscore ID equals to transaction underscore ID, right? and as this is an await statement, this will be async. And if there is no transaction, if our mongoose query does not return any transaction, then we will be throwing an exception, transaction not found. So now let's try sending in the request again in our postman. So send the request, and here you can see a new error that said cast to object id failed for value id, and this error is occurring because we are not providing the valid mongoose id over here. The mongoose id is generally this object id, and it should be formatted, or it should start with 648 and something like that, right? But we are only sending this id, so this error is triggered. We'll talk about it later, and we'll also providing a fix for it. But for now, let's provide a valid id to our delete route. So navigate into the user dashboard and send a request for getting a transaction ID. So inside of the transaction, we have a transaction in the Mike account, right? If you do not have any transaction, you can go ahead and add an income or an expense. So now that we have a valid ID of transaction, let's copy it and then paste it in our ID. So let's paste it over here and let's send the request. Now it says deleted successfully. So you can see that if you provide a valid mongoose ID that looks like a mongoose object ID, then we will not get any error. But if we try to replace with a simple string, anything like this, then it shows a cast to object ID failed, because mongoose is expecting the object ID and we are sending a general string. If you look into our code, we are trying to compare this ID with the transaction ID, but for now, as we are sending this transaction ID, it is a string and it is not formatted as the mongoose object, right? So we are getting this cast to object ID failed. So we need to check that the transaction ID that we will be getting from the user is a valid mongoose ID, and we can use validator package for validating it. So const validator equal to require validator. So for getting the function of this validator for checking a Mongo ID, we can navigate into the validator npm package, and in the documentation you can see that we have a checking function that is called is Mongo ID. So let's copy this and then we will be using it over here. So if validator dot and then is Mongo ID, and inside of it will always be an string, so transaction ID dot to string, right? And if it is not the case, so if this is not a valid Mongo ID, then we'll throw an exception called please provide a valid ID, right? Let's save this and let's try sending the request over again. So send the request again with an invalid Mongo ID. So if we send it, and here you can see we are getting the exception of please provide a valid ID. Now if I provide a valid ID and send the request, it says that it is deleted successfully. So our validator package is validating the Mongo ID. So now let's continue with the delete functionality. So await and then transaction model dot delete one, and the condition for deleting will be the underscore ID is the transaction ID, right, that we are getting from this payload. So let's save this and let's try to execute this in our postman. So send the request for this transaction ID. We are trying to delete this transaction ID. So send the request, and then you can see transaction ID is deleted successfully. Now if you navigate into this user dashboard and you send the request again, you can see that the transaction is removed. But there is an issue. The transaction is removed, but the balance has not updated. And it is because we are not writing the logic of updating the user account when the transaction is deleted. So let's do that. Now when deleting a transaction can be of type income or the expense, right? If the transaction type income was deleted, then we need to deduct the balance of the user. And if the expenses was deleted, then we need to add a balance to the user, and that's how it works, right? So we need to detect what the transaction type was. So for testing that, let's comment this transaction delete for once. And once we are done with the updating of user data, we will be uncommenting this. So let's see what we are getting from get transaction. So console.log and then get transaction, right? Now let's send the request again. We have already deleted that previous transaction, so let's create a new one. Let's add an income. So 10 received from friend. So add this, and then we'll also be adding an expense for testing. So 10 for movie ticket. Let's make this 5, right? And send the request again. Now inside of this user dashboard, we'll be having two transactions. One is of expense type and one is of income type. So let's work with this income first. So let's copy this transaction ID and then paste it in delete transaction. For now our transaction will not be deleted, we are just logging the transaction object. So it's saying deleted successfully, but as we have commented, it will not work. And here we have the transaction ID that we got from the ID of user, right? Now you can see that this transaction is of type income. So what we need to do is, if user tries to delete the income type of transaction, we need to deduct the amount from the balance, right? So for that, what we can do is, if get transaction dot, and then in object we will be having this transaction type. So if get transaction dot transaction type equals to income, then we will be writing our income logic here, and if not, we will be writing our expense logic here. Now if there were more than two expense type, then we need to write else if statement, but as there are only income and expense type, we will be doing just fine with this if else statement. So now that we will be working with the user model, make sure you are importing this users model over here. And now what can be done is, if the transaction type is income, then users model that update one, and the condition will be the user ID will be inside of this underscore ID, and then user ID will be the user ID that we got from here. So get transaction dot user underscore ID, right? And by that we will be detecting the user that had this transaction, and we will make a changes to inc, and then inside of it balance, and the balance will be the amount of transaction. So get transaction dot, and the amount is stored in this amount, so get transaction dot amount. Now as we need to deduct the amount, we will be multiplying it with -1. So let's save this, and when you are using this update one, it is mandatory that you have this validators, run validators true, right? Let's save this now. So let's copy this and then paste it inside of the expense too. But in expense, the only change is that we will be increasing the amount. If the user tries to delete the expense, then we will be increasing the amount, right? So again, save this and then uncomment this, right? Now save this again. Now let's try to delete the transaction of the user. So let's navigate into the Postman and navigate into this user dashboard, and now we will be deleting this income type of transaction. And when I delete this income type of transaction, this will be removed and the balance will be updated to 5005, right? So let's copy this and then paste it in our delete transaction, and let's send the request. So deleted successfully. Again navigate into user dashboard for checking and then send, and then the balance has been updated to 5005 and there is no income to be seen. So now let's try to delete this expense as well. So if I delete the expense, then the amount will be 5010, right? So again paste this in our delete transaction and then send the code, send the request. So deleted successfully, and then again check the user dashboard. So 5010 and there are no transactions over here. Now if I try to run this delete transaction request again with the ID that is already deleted, then if I send the request, you can see that transaction not found because it is already deleted, right? So everything seems to be working fine, and we have successfully created a delete transaction route, and in the next lesson we will be working on edit transaction. So I'll see you at the next lesson. In this lesson, we will be working on edit transaction functionality of our Expense Tracker Pro. If a user makes a mistake while entering a transaction, then deleting that transaction and creating a new one is a bit of a hassle, right? So instead of deleting and creating new one, we will provide user with the option to edit the transaction. So let's go ahead and work on that functionality. So inside of modules, transactions, controllers, let's create a new file. We'll be naming it to edit transaction.js. Inside of it, an arrow function, module.exports equals to edit transaction, right? Now this will have an SS2 request and response, and then response.status 200.json, and inside of it data status edit transaction, right? Now let's import this edit transaction into our transaction routes. So let's duplicate this, and editing a transaction will be a patch request. So in this patch request, instead of getting this transaction ID through params, we will be getting this transaction ID through request.body payload. So remove this. And then if someone sends a request to transactions, and then if it is a patch request, then our edit transaction will handle the request. So now let's go ahead in Postman and then keep this route. So navigate into the Postman. Let's duplicate this one and then rename it to edit transaction, right? And it will be a patch request, and then there will be no ID params. So let's save this and let's try to send the request. So our edit transaction route is working fine. So let's start writing some codes. So we'll be needing mongoose over here. So const mongoose equals to require mongoose, right? And then we will be working on transaction model. So const transaction model equals to mongoose dot model, and then transaction model transactions, right? And then we will be getting the transaction ID from request.body payload. So const destructuring it transaction underscore ID, right, from request.body. And if there is no transaction ID, then throw an exception. Transaction ID is required, right? Now this transaction ID will be an object ID. So navigate into the delete transaction and copy this validation logic. So copy this and paste it over here. Validator is Mongo ID, and this transaction ID is the transaction ID that we'll be getting from request.body. And if it is not a valid ID, then we'll be throwing an exception of please provide a valid ID. And then again copy this code as well. So this get transaction and paste it over here. So we will be trying to find this transaction, and as this is an await statement, this will be async, right? We will be trying to find this transaction, and if this transaction does not exist, then we will throw an exception transaction not found. Let's save this and let's try to send the request again. So navigate into Postman and body, we will be sending empty JSON. If we send empty JSON, then it will be displaying transaction ID is required. So let's type our transaction ID. So transaction underscore ID equals to, if I provide invalid Mongo ID and send the request, then it will say validator is not defined. So we forgot to import the validator, my bad. So const validator equals to require validator, right? Let's save this again. Let's send the request. So please provide a valid ID. Okay, now let's navigate into this user dashboard and get one transaction. So we do not have any transaction. Let's add income. 10 received from friend, that's fine. So again to the user dashboard, get the transaction ID, copy this ID in our patch method, and then paste it over here. Now if I send a request, you can see that edit transaction route has been triggered, and then we are getting in success status. So let's continue with our code. Now let's have a look at the transaction model and then see which fields will be allowing our user to edit. So we will not allow an user to edit this user ID because user ID belongs to that user and they cannot change to another user. So the field that we allow them will be amount, transaction type, and remarks. So in edit transaction, we will be destructuring remarks, amount, and then transaction type, right? Now let's save this. So now let's write the update functionality. So await transaction model dot update one, and inside of it the condition will be the same that we used before. This ID belongs to a transaction ID, right? And the second parameter will be an object for making the changes. So we are allowing remarks, amount, and transaction type. So remarks will be the remarks. But for saving time, if our variable name and the key is same, then we can only write this. So remarks transaction underscore type and then the amount, right? Now let's save this and let's try to make a changes to the transaction. So navigate into the Postman and this is the transaction that we will be editing. So the transaction ID is our transaction ID of income that we are getting from this user dashboard, right? This one. And let's try to make a changes to this amount. So let's change amount to 200, right? Let's save this and let's change the request. And the transaction has been updated successfully. Let's see if the changes has been reflected. So you can see that amount has been updated to 200. So let's try modifying this remarks as well. So here we'll be adding the remarks as well. And instead of receive from friend, receive from there for now. Let's send the request and our remarks and amounts will be updated. And here you can see receive from there and then amount has been changed. Also we can update this transaction type. So copy this and let's try changing transaction type as well to expense, right? Let's save this and let's send the request. And here the transaction type is also changed. Now what if I try to update this transaction type to something that is not in our enum? So let me write this, let me remove this expense and write some random string over here and then let's send the request. So it's currently saying transaction updated successfully, and if I navigate into user dashboard and send the request again, you can see that we have an invalid transaction type. And this is a huge problem because this might break our entire system, right? And this is possible because we have not written run validators true over here. So it is very important that we always run our validators. So run validators true. And now let's send the request again. So in edit transaction, I'll be providing invalid ID type, transaction type. And then the validation has been failed. Transaction type is not a valid enum value for past transaction type. Now instead of showing this, you can also provide your custom validation error. So for that, let's check the transaction type. So if transaction type equals to income or transaction type equals to expense, let's not write equals to. If this does not equals to income and also it does not equal to expense, then we'll be throwing an error, our custom error, transaction type must be income or expense, right? Let's save this. Now if I send the request again, we'll be getting the custom error message here, right? Now there are a lot of things that needs to be done in our edit transaction. For instance, if the user is trying to update an income to an expense, then what we need to do is first we need to deduct the income and then add the expense in the user balance, right? And if they are trying to update the amount, then we must find the differences of amount and then make a change according to it in the user balance, right? So what we need to do is we need to first figure out the transaction type like we did in the delete, and then we should make the necessary changes in the user balance. So there is a lot to be done in this edit transaction part if we allow user to change transaction type and amount. So we will only be allowing the users to make and changes to these remarks and not on transaction type and amount, because we need to proceed further in this course, and writing this all of this logic will extend our course time. So I leave this to you. You can detect the transaction type and you can make the necessary changes. Try for yourself. But for now, I'll be deleting this transaction type and amount, and I'll only be allowing user to make a changes to the remarks. So let's remove this as well, and then this check as well, right? Now by doing this, we are only allowing these remarks to be updated. Now if you want the user to make an edit to transaction type and amount, then you can go ahead and write all this code. But now that you have an idea of how editing and different type of other stuff work, it is not completely necessary for you to write all the logic, and I recommend that you move further in this course where we will be working on deploying our Node.js app into the live server. So I'll see you at the next lesson. So now that we have completed all the features of Expense Tracker Pro, it's time for us to deploy our Node.js app into the live server. But before that, we need to make some changes to our code so that it can go into the production environment. Now the first thing that we want to do is to create a 404 not found page. Now if you navigate into the Postman and send a request to the URL that is not defined by our route, let's send a request, then you will be seeing an error by Express. But instead of showing an Express error, we'll be sending our own error message. For that, navigate into app.js. So right above this error handler, we will be providing our fallback route. So for that, app.all and asterisk, meaning that any requests that are not handled by this route will fall back to this app.all. And the next parameter will be handling the request. It will be an arrow function, right? And this will have an SS2 request, response, and then next function. And inside of it, we'll be writing our own 404 page. So response.status 404 for not found, and then JSON, and inside of it, status will be failed, right? And then the message will be not found. Now let's save this, and now let's try to send a request again into the invalid URL or invalid route. So if I send the request, you can see I have got a 404 not found response with our own custom JSON. And if I provide the correct URL, then it will work as usual, right? And this is how you send custom 404 error response. Now next thing at our checklist before sending it for the production is to install CORS package or CORS package. And this is the package that we will be installing. CORS meaning cross origin resource sharing. Now if you deploy your Node.js app without using this package, then your front end, if you ever try to build a front end for this backend, then it will not be able to access the resource of your backend, because resource sharing is by default only allowed on the same IP. But front end and backend may have different IPs, right? And different places that they will be deployed. So for accessing the cross resources, we will be needing this package. So let's go ahead and install this package. So close the server and then npm install CORS or CORS. Once it is installed, navigate into the app.js and right below this express const CORS equals to require CORS. And now we will be using this CORS package. So right after this express app.use and then inside of it CORS function, right? And by doing this, we are allowing our backend or API endpoint to be accessed from anywhere, right? So now that everything is set up for the live deployment, I'll see you at the next lesson where we will be pushing this code in GitHub. So I'll see you there. So now that we have completed all the functionalities of Expense Tracker Pro, it's time for us to push our code in GitHub. If you do not have a GitHub account, go ahead and create one. After you have created an account, create a new repository, right? And the repository name I'll be writing expense underscore tracker underscore pro. You can write anything that you want, and you can leave this description empty. And let's create a private repository for now, and do not check any of this and create repository. And just like that, your new repository is created. Now let's push our code in this repository. So navigate into our project, and before pushing our code to GitHub, let's create a git ignore file. So new file, and the file name will be .gitignore. And in this file, we can write what files or folders need to be excluded when we push our code into the GitHub. So the things that needs to be excluded is node underscore modules folder, because this will automatically come when someone performs npm install, right? And another thing is .env file. We will not be pushing our .env file as this will contain the sensitive information. So once this is done, navigate into the terminal. Don't forget to save this code and type git init. We'll be initializing the GitHub or Git repository over here. So you can see that node modules and env file will be ignored. It will not be pushed in our repository. So the next thing that you want to do is git add and dot, meaning that we want to add every other thing into our GitHub, right? And then we need to commit this. So git commit -m and first commit. And this will be our commit message, and we are committing our files to be pushed into the GitHub. Now we need to add an origin. We need to initialize our Git repository from the GitHub over here. But before that, let's create a new branch. So Git branch -m and main. We'll be creating a new branch and then navigate into a repository, this part, and copy this code and paste it in your terminal and click enter. This will initialize our GitHub repository into our project, meaning it will link our GitHub repository to our project. And now finally git push origin main. This will push all of our code into our repository main branch. Now once the code has been pushed into the GitHub, this is what it should look like, right? And now we are ready for the deployment of our Node.js app. So I'll see you at the next lesson. Now let's deploy our Node.js app into the live server. And we have selected render.com for it. Render.com provides a free hosting for Node.js app with generous limits. So let's go ahead and create a free account. So you can use any of these ways to create your account. So once you have created an account and verified your email address, this is what your dashboard should look like. Now click at new and then the web service. And it will be asking you to connect a repository. So we have our repository in GitHub. So let's connect our GitHub account. So click at connect and then we'll be connecting our GitHub account. So authorize the render for allowing an access to your GitHub account. Now in this step, if linking of GitHub to render fails, then you want to log out your account and try this process again. Once you have got this screen, allow access to all repositories and then install. Now once you have a repository listed here, click at connect. Now you need to fill this up. So this is the name for our Node.js service. So expense tracker _ Node.js. I'll be writing this, but you can write anything over here. And you can select any region and the branch will be the main branch, right? And the root directory, we do not want this root directory for now. And in the runtime, our Node.js, it has already selected Node.js, so it's fine. And in this build command, we will be replacing this yarn with yarn space install space and -- ignore engines, right? This render has something to do with npm, so if you write npm over here, it will not run. So you can copy this code, you can type this code over here for the build command. And the start command will be yarn run start, right? Yarn install ignore engines and then yarn run start. And you want to choose this free instance type, right? And now we need to set the environment variable. So click at advanced and then in advanced click at add secret file and our file name will be .env file, right? And you need to paste your contents of .env over here. So copy the contents of your project env file and paste it over here and click at save. Now everything else will be as it is and then create web service. Now wait for the render to create your free web service. You will be able to see the log over here, and if everything is fine, then your service will be live. Now if you encounter any error over here, you can copy those errors and search for those issues in Google or get help from ChatGPT. And if everything is okay, then your server will be live. Now to confirm that your server is live, scroll at the top and here will be the URL for your API endpoint. So click it here and then you should be able to see the not found page. So if you are seeing this JSON that you wrote, then your server is live and ready to be tested. So again, if you want to see your URL when you log in next time, you can click at dashboard and then this web service and here will be the URL for your API, right? Now in the next lesson, we will be testing our live URL to see everything is working fine. So I'll see you at the next lesson. Now in this lesson, we will be testing our live deployment to see if everything is working fine. So once you have got your URL for API endpoints, copy this URL. And now let's navigate into the Postman to check our live URL. So open up your Postman and in environments, go into this ETP environment and you want to replace this URL with the new URL. So paste it and our API endpoint will be /API, right? So copy this and paste it over here as well. So save this and your current value should look the URL address and then /API. Now go into your collection and try using the user login. Now before sending the request, let's replace this localhost 8000 with our environment variable URL. So remove this and also remove this API because it is also in our environment variable URL. So use URL over here with 2 curly braces and then /user/login. So try sending the request. And here you can see you have got the response from live server. So congratulations, you have successfully deployed your Node.js app in live environment. Now let's go ahead and test other API endpoints as well. So let's go into the user dashboard and also replace this localhost 8000/API with the URL in environment variable. So replace this with URL, right, and send the request. And here you have response from the live server. So now go ahead and replace all of this localhost 8000 with environment variables URL, and you will be able to test all of the API endpoints. So this completes our Node.js course, and I hope that you have learned a lot from it. I can't wait to see what you build with this. And a huge congratulations for completing this course.